Imagine not using AI in the Lord's year 2025. I know what I did wrong. Dang it. What am I doing wrong here? I think I see the problem. I think it's pretty obvious here. I've misread it like a dum-dum. No! Okay, well, that's still incorrect. I don't know what's actually happening here. Whatever, stupid. Who wrote this? People that are watching this video are gonna think that I'm a weirdo.
Okay, why would you ever want to build an HTTP server from scratch? And I mean like from TCP scratch, not like, oh, I used the Golang HTTP library. No. No libraries, no frameworks, hand-rolling HTTP from TCP. Look, I know Apache and Nginx have both been around for like 20 years, but this course, and specifically the parser
Done.
that we're going to build in this course, is one of the best exercises for newer developers. It'll help get you to that next level. The Primeagen who wrote this course and recorded this walkthrough said,
I feel like this is a great way to go from like a junior engineer into a mid-level engineer.
But before I dump you right into all the string parsing glory that is this course, let me give you just a bit of a teaser of what's going on here, considering it is like, I don't know, 5 hours long or something, which is impressive because Prime actually streamed this walkthrough in a single day, and he only had to take a break to use the bathroom like 17 times.
All right, hold on, I gotta go pee. All right, I gotta be right back, I gotta go pee.
So we're learning all about the HTTP protocol in this course, and we're doing it by building an HTTP parser and server from scratch in the Go programming language. That means we will not be using the built-in HTTP library at all. We'll be building our own. Though of course we will be using the TCP library, which is just the protocol that HTTP is built on top of. So we're gonna start off exactly the way you should start learning a network protocol. And that's by not using a network at all. Prime's gonna teach you how data is streamed from a file into your program through the exact same interface that it's streamed from a network connection into your program. Then he's gonna cover TCP.
Now we're gonna move into TCP land, okay?
And contrast it to UDP and how HTTP is built on TCP, and that's why it makes a lot of the assumptions that it does. Then he'll cover the structure of HTTP requests, breaking down the request line, the header, the body, but he's not just going to explain all this stuff. Again, he's going to build the parsing logic and server from scratch with you. Our server is going to be able to read from a connection byte by byte in real time. Anyways, then we'll move on to HTTP responses and even get into some of the more advanced stuff you can do with HTTP, like chunked encoding and binary data. We'll even serve an entire MP4 video directly over our TCP connection. So there's a lot of really cool stuff in this course. Now, I do not recommend sitting down and binging this course all in one sitting. Actually get your hands on the keyboard and follow along. Make an account on BootDev, it's free, and actually go ahead of Prime and watch him go through the same lesson that you just went through so that you can see his approach, his commentary, and his solutions only after you've had a chance to practice and experiment and challenge yourself. As you know, all the content in this YouTube video obviously is free, but also all the content on BootDev is totally free, at least to read and watch. That said, all the interactive features on BootDev are paid. So if you want to be able to submit your own assignments, if you want to view solutions, chat with boots, get a certificate of completion, that kind of stuff, you will need a membership. And if you want to get one, just use Primeagen's code PRIME to get 25% off your first year if you choose an annual plan. And part of that payment will also go directly to supporting the Primeagen and help him and his content. One last note, the only reason we can put our time and resources into creating these types of courses is due to your support. So please like and subscribe to our channel here on YouTube. It just takes a second and allows us to produce more and more of these long form video courses and release them for free. So really, thanks for doing that. Now, let's go write some Go code with the Primeagen.
Are you ready for the full ass course going on here? So here we go. I'm gonna skip all the additional reading because, you know, if you want to take the course, it's open, which by the way, you can take it without all the interactive parts and it just works. Just so you know, you can take it without any of the interactive parts and it works. So right, like I'm not gonna read the introduction. There's nothing here other than like fun stories that I tell. You know, there's a little fun story about like me the first time I got Shazammed, the first time I got one-shotted. I got one-shotted hard in college. This is why I'm a programmer, okay? I got one-shotted twice. Once by a linked list and once by the social network. It's that simple. Welcome to the startup. There's a few days in your life more magical than your first day at the startup. My best days in order have been my first day at the startup, my wedding day, and birth of my first child. Here at the startup, your first task is to build an HTTP server from scratch. A multi-billion-dollar exec hangs in the balance. Before you begin, the startup has to finalize your hiring first. We will screen all of our newbies by asking them to build a much simpler protocol first. We'll start with reading text from a file and printing it to the console. Look at that. Boop, boop. All right, here's the text. So create a new project. There we go. Create a messages.txt. Let's do this, baby boys. Messages.txt. Let's go. Put that in. Put it in. Create a Go module. All right, Go mod init boot.theprimogen.tv. Let's go. Create a main.go. At the root, the simply for now, print out this string. I got the job. Okay, I got you, baby boy. Baby boy, I got you. I got you. PV main.go. Let's go. Package main, func main, do one of those. Let's see, format, print ln, there we go. And print in that thing, there we go, boom. And let's do that. There we go. All right, we're looking good. I think I've won. All right, I'm not even gonna try, dude, first try. First try, dude, we need a first try counter right now. Here we go. All right, how many first tries am I gonna get? There's my first try counter. All right, there we go. We're currently at 1. Do we get 2? React is my language? Okay, well, that's unique that you have a language. I didn't realize that libraries could be languages. And boom, got another one. All right, we're going up, boys. Boys, we are going up. Okay, you can F this up so easily, right? Like eating 8 bytes at a time. Eating 8 bytes at a time, really easy to screw that up. Here we go. Okay, we're gonna remove this printing. Instead, program will now read messages.txt 8 bytes at a time and print out the data. Okay, true. We're gonna do a little bit of an open. We're gonna do a little bit of a while there's still data in there. We're gonna read 8 bytes at a time. We're gonna print it out with read : that. Okay, when you hit an end of file, error, exit the program. I got this. I got this, boys. Equals, oh, we got that. Dude, hold on. Hey, for you guys, just so you can't be like, you're cheating, super Maven, I will stop the super Maven, which, by the way, you should not use an autocomplete or AI when you're learning, okay? Because if you do that, you're just like, honestly, you're going to be a sad panda. I'm just letting you know. You will be a sad panda if you do that. Wait, what? Which one do I have for, okay, I thought EL did that one. Okay, whatever. There we go. We'll just do that one. We'll do that one. There we go. Little log fatal. We'll get in there, and we're going to go for data equals make byte 8. There we go. We're going to just read out this data, boys, okay? Equals, what is it? It's f.read, there we go. Data, yeah. I'm a little bit elixir pilled right now, so I'm like, okay, which one do I do? Which one do I do here? Data equals data. Oh, I don't even have to do that. Format dot print ln read. Actually, no, I have to do f me. Data string n. There we go. Boom. I know it says do an end of file, but look at me, I'm not even doing an end of file. I'm just doing it to here, okay? Because I'm a rebel. I'm an effing rebel, okay? There we go. All right, anyways, let's keep on going. So I think I got this right. Let's just go like this. There we go. Brother, got another first try up on the list. Let's go. Another first try. I knew I was the best. Okay, there's a reason why I wanted to go through this exercise, and I think it's really, really good for anyone who's ever building their first protocol, because I think understanding reading from a file makes perfect sense. And so right now, just to kind of put us all on the same page, what are we doing right now? Well, what we're doing right now is that we know that we have a file that's filled with a bunch of data, right? And we are going to take that data 8 bytes at a time and just keep on reading it 8 at a time. Like, this is a very, like, you get this, right? It's literally just a contiguous block of things that you read. Okay, so now that we all understand that, you can see that this is working, which is really good. Reading 8 bytes at a time is a good start, but 8-byte chunks aren't how people tend to communicate. You probably have noticed that it was hard to read individual messages through your program. Trust me, this all leads to HTTP, I promise. Yes, I know. I intentionally made it this way for a reason. Let's update our code to continue to read 8 bytes at a time, but now let's format the output. %s represents an entire line. Okay, so now we're going to read 1 line at a time. All right, so this isn't too hard. By the way, I'm going to write really shitty code. So just everyone be ready. Like, this isn't meant to be very beautiful, okay? Look at that. I'm doing that. This is not performant. This is not beautiful. There's nothing about that. That's fantastic. We're just going to crush some butt. Okay, everybody? All right, good. I want everyone on the same page. So I'll just go like this. Bytes.index.newline. Wait, I think there's index byte, right? Yeah, index byte. So I can go data. There we go. Data, let's see. Data equals data, and there we go. We'll do a little slice. So we have those things. So we have this little bad boy right here. If I equals that, we'll do that. I is does not equal 0, right? There we go. So if we found an index, we will simply go stir plus equals string, let's see, string data up to I. Yeah. And then we'll go data equals data starting from I. Right, starting at I plus 1 because we don't want that new line. Very, very simple. There we go. And then I'll go print format. There we go. Print. We'll print all of this stuff up to, we'll do string, and then we'll go stir equals that. Now this, again, this is not great code. But remember, we're not trying to write great code. We're just trying to write code. Okay, so there we go. We'll do this bad boy. Else we're going to go like this, string plus equals a string, and then we're going to go data. We're just going to go data, right? We're just stringing up the data, boys. We're just stringing up the data. And if we have anything left over, wrong language, then we'll just hit it up with one more print. There we go, and that's that, right? So if I've done this correctly, let's go run. Do I even want to run this? Okay, since we're trying to one-shot everything, let's look at this. Reading 8 at a time, we are slicing things out. We're seeing if there's a new line. We're adding it to the string. We're doing a little bit of that. We're doing that. We're resetting the string. We're adding the rest of the data. Yeah, I think we could one-shot this one. We're going to one-shot this bad boy. We're going to one-shot this bad boy. And we didn't one-shot this bad boy. What happened? Who did this? I'm a fraud. I'm a fraud. Go run main.go. What did I do wrong here? So why is this slice out of range? On 26, really? What did I do here? Wait, oh, does not equal 0, you idiot. It's -1, oh my gosh. If you wrote code like mine, there's a good chance you've got a little state machine going on directly inside your main function, which we kind of do, right? It's like a little state machine. This is why you quit Netflix, shut up. Create a new function called getLineSignature. Boom, we're gonna copy this bad boy out. And let's create this. Let's go up here. We're going to paste that bad boy in. Hopefully everyone sees where this is going because it's getting awesome. It's about to be awesome. Notice that we're using a read closer here. For those that aren't familiar with a read closer is just a reader and a closer. If you're not familiar with a reader just simply has that one function on there. A closer simply has this one function on there. That's all it is. It's just an interface with read and close. That is it. Nothing else. Okay, out makes, chan string. Let's go 1. We don't need a lot, right? Return out. Func. By the way, this is how I can always tell someone's using ChatGPT, is when they write something like this, and then they just start onto their next thing. I'm like, nah, I think you're lying to me. I think you're lying to me because I feel like you would do the return because this is like out of band. You know, people write really linearly. Like when someone writes a function from top to bottom and one-shots it, I'm just like, you're a cheater. You, my friend, are a cheater. Okay, so we're gonna do a little defer. So we need to close our channel, right? Because if you don't close your channel, things, you know, are stupid. And then we're gonna go f.close as well. Right, so there we go. We have our 2 closes. And so now all we have to do is just reread this nonsense right here. Take that, yank that bad boy out, put it in here. Let's just do a little equal sign there. And then we also need to go down here, yank one of these. And I know I wrote this all crappy, but hey, deal with it. And let's go like this. Okay, and then let's go lines equals, what did we call it? We called it get lines from, get lines from channel. That's not a good name, by the way. It should be get lines from reader, but hey, this is where we're at in life. Okay, this is where we're at in life. Arrange lines. And then we need to do a little printing. So right here, I'm gonna just take all these things and I'm just gonna replace the printing with the string that I was gonna originally send out, right? There we go. Easy peasy lemon squeezy. And then format print F, and then I think I still need to read that. There we go. So if I've done this all correctly, there we go. And let's see. Let's just make sure I understand the assignment here. Create a new function with the signature. Yep. It creates a channel of strings. It does the reading inside the Go routine. Got it. It does not prefix. Yep, I got that. All right, perfect, perfect, perfect. And then we do this. Update your code to use a file implements read closer. Yeah, prefix everything with that. Okay, perfect. One shot, boys. Boys, we are one shot in this one, and we one-shotted it. Let's go. We're going on. So this is where things get a little bit magic, okay? We're getting into the magic side of things. Because notice what we've done right now is we've used a file, we've read a file, then we just moved it up into a function, and then we used Go channels to send out the information. There we go. This is where I'm at, right? There we go. Why are we reading files? Because this is the best way to understand other things. Now we're gonna move into TCP land, okay? All right, so what we're gonna do here is we are gonna send some data over the wire. By the way, Lane had to make this change because he was totally wrong on some stuff. We're gonna send some data over the wire instead, right? And so what we need to do is we're gonna remove all the logic that reads from a file, and instead we're gonna use net.listen, okay? And we're gonna set up a TCP. And then we gotta call accept, and then we're gonna use the same function, get lines from channel, and then we're gonna print all the messages, okay? So that means we're gonna go like this. So instead of doing this, which opens up a file, right? Watch this, so I'm gonna go like this, get from a file, right? So I could do something like that and get this from a file, but we're just gonna close it. Don't worry about that, right? So I'll go like this. I'll go listener, right? And then we're gonna go net dot, what is this? What is it called? Listen, right? And I can go TCP, and then I can go 42069, there we go. And then I can do a check on this guy, awesome. And then we can do a nice little for loop right here. And instead of doing that, we're gonna go like this, con error listener dot accept. Accept is just like it is in Berkeley sockets effectively. This looks like mostly like a Berkeley sockets thing. So now we're gonna create a server. It's gonna get TCP connections coming in, and we're gonna get this connection, and we're gonna get this error, okay? Very, very simple. And from there, I'll do the exact same thing. We'll go 6 up, 6 down, bam, bam. There we go, do one of those, and then I'm gonna go like this. Instead of doing, or now I just do one of these, I'm gonna go like this, line equals, and then I can range over get line from channel, and I can just pass in a con. Now notice what we did right here. It's literally the same code that we had before, right? Nothing changed. So this is why I wanted to start with the file, and I think this is just really, really great for somebody looking at this for the first time. But you'll notice that I didn't change anything to do with how I'm reading data out. The only difference here is that instead of passing in a file, I'm passing in a connection. Because really, they're the same thing. You can read 8 bytes at a time from a connection. You can read 8 bytes at a time from a file, right? It's the same principle, right? Does that make sense? I think a lot of people don't make that connection, that it's really, really, really simple, that it's just a reader. It's not just that it's a reader, right? That's like a Goism. If you think about it, a file represents some contiguous piece of binary data, right? How you interpret it is, you know, whether it's ASCII or not, whether it actually has meaning or not, doesn't really matter. But a file itself is just a contiguous set of data. An internet connection that you get from somewhere else, it's just the exact same thing. It represents a contiguous stream of data. The only difference is that when you're working with the file, you get to determine how much you read from the file. A connection, on the other hand, it pushes data towards you. You pull data from a file, you get pushed data from an internet connection, but the interface is the same. And so that's kind of like this kind of magic thing that I think a lot of people, that it makes writing internet protocols seem a lot simpler once you realize that you're just simply working with ordered data, and that's it. And once you understand it's just ordered data, it's no different than reading from a file, you go, I get it. It's just a stream of bytes and it's in order. That's what makes TCP good. Oh, the push and the pull is really helpful. Yes, it's really, really helpful, right? It's really, really helpful for people to do that. Let's keep on going. So, okay, let's see what we have to do here to make sure this all works. Okay, all right, let's see. You can terminate the program by using Control-C. You can run the server again and T the output, copies the standard out to a new temporary file. Okay, we can do that one. Let's see. Run and submit the CLI test while the server is running. Sure, we can do that. So I'll go like this. I'll run this thing. So there we go. We have it running. And then I'll grab this thing, and let's do this, and we just got brother, we just got ourselves another first try. Let's go. Uncompiled, untested, First try. Let's do this. Even while telling a story about a horse. All right, let's see. We run and submit this. We did this all. We haven't shipped a way to customize the port on the CLI command. They did, apparently, yes. Admittedly, Prime's probably the only person that might have conflicts on port 42069. I did. I actually had to turn off my voice stuff, like our little TTS AI thing, and I had to change its port to 42068 because, yes, admittedly, I'm the only person that's default first port is 42069. Okay, this is a very important port to me. All my programs do that. So what is a protocol? To put it simply, a protocol is simply a design or a spec for one computer or device to communicate to another. It describes how you break down the data, how exactly it is formulated, the header packets and all that, so that the other side can reconstruct messages sent across the wire. So why does HTTP1 use TCP? Well, TCP is reliable in-order packets. Let's do a little example here. Let's say I needed to send it off something that contained 8 packets in it from one computer to another. Now, how this would normally be done with TCP is I would have something called a sliding window that will contain how many packets we can have out in flight at one time. Let's pretend we had a sliding window of 4. That means I can send out packets 1 through 4 to the destination computer. So 1 would go across. When 1 gets over, the receiver needs to send an acknowledgement. The acknowledgement will come back at some point, and when received, our sliding window can proceed and send this out. While we're waiting for that one acknowledgement, we can send the other packets out that are within our sliding window. This allows us to send a bunch of data at once, not just sending one simple packet at a time. This is how TCP is in order and reliable. Every packet that is broke down for a big piece of data is broken down to individual packets with IDs, shall we say, and a destination, which port it needs to go to, and then it will properly be routed to its address, and the receiver will be able to reconstruct the data in order. And obviously packet ordering makes perfect sense why it's important. If you were to send, say, a JSON object across the wire, remember, that's just text, right? That's just simply bytes. We can send that across the wire. But what happened if you got it out of order? Well, you wouldn't be able to use JSON parse. It would explode. You would get an exception in JavaScript. Now, you probably heard of something called UDP, which is a little bit different than TCP. But generally speaking, UDP is considered more performant because it does not wait for an ACK. But here's the deal about UDP. With TCP, you send across your entire JSON blob. But with UDP, you have to make the decision how you're going to break up all of your data, how you're going to organize it, how to reconstruct it on the receiving end, and then how does the receiving end know that it's missing a packet? And so this is very, very important. So let's just pretend this again. We're gonna send all 8 pieces of data at once, just bam, 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 bam. We have to come up with a strategy to know if the receiver hasn't received a data. Maybe it didn't receive packet 6, so the receiver is gonna send a NAC, a negative acknowledgement, and say, hey, you know what? I didn't get this one. I seem to get everything else, but I didn't get that one. Now, it still may be in flight. It still may come. So you'll have to come up with an algorithm that can receive 2 of the same packets. You're going to have a lot more protection in it that you don't even have to consider when using TCP. But you can see why this is more performant. There is no acknowledgements. And right now, a pretty good packet loss rate is less than 1%. So let's pretend for a second that it is 1%. That means you're only losing 1 packet out of 100. That means you are not waiting for acknowledgements 99% of the time. And that one time it does happen, you do end up getting a NAC, which means you have to be able to hold the data on your server long enough to be able to negatively fulfill requests that you've sent with UDP. Yes, okay, so we're talking a little bit about TCP versus UDP here. This is just simply going to go over a little bit to do with UDP, which is perfectly fine, a lot of fun. So a lot of good jokes. Everyone has a bunch of jokes. Like I could tell you a joke about UDP, but you probably wouldn't get it. UDP is a stateless connection. In other words, you don't actually make a connection. You don't do a handshake. You don't say, hey, I'm going to send you data. Then it goes, okay, you can send me data. Then you're like, okay, I'm going to send you packet 1. And it's like, hey, I got packet 1. And then you're like, okay, I'll send you packet 2. And you're like, hey, I got packet 2. Right? That's what TCP does. UDP, you're just like, hey, hey. And if there's nobody listening, it's like, hey. And that's all that happens. You don't even know, right? So there you go. We got all these things. So this is awesome. So that's one thing that makes TCP so great is it's in order data. So what is the requirement here? Move your main.go file into command TCP listener. So I'm just going to go like this, make dir-p command TCP listener. There we go. Move main.go into command TCP listener. Boom, let's go. All right, we did that one. Done. Run your TCP listener with this one right here. Okay. Nice. In a separate terminal, do this one. There we go. You should see a connection accepted message. Okay. Yep, there we go. We got it. We now have that thing open. Okay, cool. Kill both programs. I'll run this again, and let's see. You should see the yep. Okay, there we go. And so if I do that one, connection refused. Okay, good. We've seen all these things. Awesome, awesome, awesome. That's because TCP requires a connection. Yes, 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 yes. All right, we're going to do this thing. Bam. And we're going to throw that in there, and then we're going to go in here, and then we're going to go up to here. I'm going to yank that bad boy. We're going to paste that in, and boom. We got a first try, boys. We got a first try. We are first trying again. All right, babies. All right, here we go. 6. We are cruising, okay? UDP is a lazy job's worth. UDP is actually fantastic. UDP is objectively the better internet protocol, but only during a day and age in which the internet is reliable. All right, so this one is a very simple one in which we just simply create a UDP version and we rerun this exact same thing, but we just show with UDP instead of TCP. So it's the exact same thing. What's true of UDP? It guarantees packets arrival in order? No. It establishes a persistent connection? No. It doesn't require a handshake? Yes. Bam. So remember that when it comes to UDP or TCP, both of those are just simply protocols. They don't actually have any sort of meaning beyond, like, can you inject a security into however you implement a security issue into however you implement your UDP strategy versus your TCP strategy. So yes, like theoretically, one could argue that UDP has a greater danger because maybe TCP is so well tested and so old versus UDP. Maybe some people are doing some new fancy things with UDP that accidentally, say, introduce some sort of denial of service attack. So maybe one could make that argument, but I just don't think that you should. That's not a good argument. Can you encrypt UDP? Of course you can encrypt UDP. It's just that the encryption is a bit weird in the sense that, remember, UDP is just datagram packets, meaning that you get a packet and that is it. So you have to have you have to provide all of the additional fun stuff. You have to, it's a little bit harder. That's what makes Quick, which is TCP3. So there's no TLS for UDP. It's not the same, right? Because there's not structured in order data. It's a little bit more tricksy. Isn't Quick more secure than HTTP over TCP? No, Quick is just how you frame HTTP. It's just simply it's TCP over UDP. The problem is that you have packets that you have to encrypt the data differently, right? It's not as easy because in TCP land, you have ways in which you can specify structured data. So TCP will send all this data in order. UDP doesn't. You have to do the ordering yourself. Effectively, you put a TCP header into your UDP, and then you could probably do some sort of encryption. You just have to let the things know. You need to let them know where the boundaries are. You have to do the same amount of work. It just looks differently because now you're going like this. So usually what will end up happening is that in your standard networking, you have your TCP layer that structures the data. You have your your layer that does the security, the decryption of it, and then you have your application that gets the data that has been decrypted and all that beautiful stuff. Well, in UDP land, it's kind of like you get all these UDPs, then you have your framing protocol figure out what needs to be decrypted, and then you have to go back to this. It's a little bit weirder, but that's about it. There's some weird oddities when it comes to UDPing versus TCPing just due to that. Did Netflix have it? Yes, Netflix did have its own version of TCP over UDP. There is a protocol for TLS over UDP, yeah, DTLS, yes, there is, but it's just I'm just saying it's a little bit more complicated because UDP doesn't have structure in of itself. You have to do this weird dance that's just unusual comparatively to TCP. TCP just can do things that you can't do with UDP, or it's not as simple. It's not as easy to think about. What do you mean TCP over UDP? Remember, TCP is a packet ordering protocol. UDP is just a packet protocol. So now you have to add ordering to UDP. You can add ordering and reliability to UDP by implementing TCP. The IO reader and writer interfaces in Go are useful for reading and writing data to and from network connections, files, both. Well, really, it's to anything. It doesn't even have to be both. It could be all sorts of things, which pushes data to the application that's reading from it, resulting in a reader needing to be prepared to read data. So when you're pushing data, that means it's coming from some sort of external source. You cannot control the timing of it. That would be a network connection, right? So you're probably asking yourself, why do we use HTTP and not TCP? Well, it actually is a pretty simple answer. TCP guarantees that your data is in order and complete, that there's no missing packets, that there's not problems. but it doesn't really tell you what the data is. Am I sending you just JSON? Am I sending you some sort of image? What am I actually sending you? HTTP gives you the ability to specify what you are sending. So first off, it also gives you a destination within a server, because just because you're on a port and an IP address doesn't mean it's going to the right place still. So first off, HTTP comes with kind of like your main address, like, hey, I want to go to /cats and I want to get all the images from /cats. Next, it's going to have some basic kind of control things. We call these headers or field lines from the RFC. After that, we're going to have a body if you need a body. Most requests don't come with bodies. Usually it's the response from the server that comes with the body, and the body is usually the data you are requesting. So without HTTP, our TCP data would effectively be meaningless. How do you ever even parse it or come to the conclusion for what I am requesting? And during this whole course, we're going to be talking about HTTP 1.1. But the reality is we're not just talking about HTTP 1.1. RFC 9110 actually contains the semantics for all of HTTP. We're going to be primarily using 9110 and 9112 for implementing HTTP 1.1. And the reason being is that HTTP 1, 2, and 3 semantically are equivalent. It's just simply the implementation across the wire that is different. So in HTTP 1.1, we still send headers, but we send the same headers every time. Potentially you're sending really large cookies, or maybe you're sending all those different things that are all the same every single request. With HTTP 2 and 3, there's something called HPAC and QPAC, which allow you to take the same reoccurring headers and actually shrink them down to, say, a couple bytes. This could be beneficial considering how big some of these headers can get. Now, the shape of any HTTP message is going to be the same whether it's a response or a request. There's just some subtle differences. Effectively, everything is called an HTTP message. Now, an HTTP message, the first line is going to be kind of the declaration. So say on a request, it's going to start off with a big capital letter get. This is going to be a get request. The next thing is going to be the destination. So it could be get cats. And lastly, it's going to be the semantic version of HTTP. So it could be HTTP 1.1. Every single line in the HTTP 1.1 algorithm is separated by a /r/n, which I jokingly refer to as a registered nurse because that's the only way I can remember the ordering of /r then /n. So after the first line, the status line, we then go to the field lines. Now there can be 0 or more field lines. Field lines are headers. Simply it consists of a field name, a colon, and a field value, and then one registered nurse at the end. And how HTTP 1.1 knows it's done is that there's an empty field line. It's just simply one registered nurse and nothing else on the line. After that, it's just the body. Now, you're probably asking yourself, well, how big is the body? There's a couple different strategies. There's chunked transfer, and then there's also content length. You've probably seen content length a few times if you've ever been perusing request and response. The content length will tell you how big the body is in bytes. During the course, I'm going to be referencing the RFCs 9110 and 9112 quite a bit, so if you take a look at those, it's actually pretty helpful, especially 9110. It's a very long document, and it could take quite a few hours to go through, but it would definitely shed a lot of light on why things are the way they are. So let's get into the HTTP world. Are you guys ready for the HTTP world? But if you're still implementing TCP on top of another protocol, wouldn't it be slower? No, it's a common misconception. What makes TCP slow? Remember that there's like this whole sliding window thing that goes on. Don't worry about all the requirements, but TCP, there's a lot of back and forths to how you send data, right? Then you send a bunch of data. This represents the handshake, by the way. Then I will send, say, 3 pieces of data because my window, say, is 3. And I have to get messages back for each one of these pieces of data, right? And until I get back, say, this one, I can't send the next one. So if I get back, let's say this one fails, but these 2 pass, I can't move my window forward until I get this one successed because my window is only of size 3, and I'm kind of trapped on this one packet. Now with TCP over UDP, we don't have to acknowledge every single packet. Instead, we can negative acknowledge packets, meaning we didn't get that packet, meaning we could actually go much, much longer. We can send much less packets back. We don't have to wait. You can just send all the packets you want. And I'm like, man, I just missed one. Here you go. Hey, can you please resend this one packet to me? I got everything else. So that's why TCP over UDP actually tends to be a lot faster, or one of the many reasons, because you don't have to have this whole like sliding window slow thing. You can just spam it and you can just receive it, right? I don't have to be like, hey, I got 1, hey, I got 2, hey, I got 3, hey, I got 4, hey, I got 5, right? You don't have to go through like that whole thing. You can do other things. The missile knows where it is because it knows where it isn't. Exactly, that's UDP. There's like a lot of things you can do that you can't do just with TCP. Yeah, there's a huge, yes, because you're just doing less. People don't realize how much less you can do with UDP. And the reason why this is all possible is because networks are so reliable today. UDP wasn't the default because 30, 40 years ago, networks weren't as reliable. When you have like a 20% drop rate, it becomes much, much harder to implement protocols that follow constantly, right? All right, let's keep on going because we got a lot of stuff to do. HTTP works because plain text is binary, because HTTP uses TCP. If the HTTP request or response is too big to fit into a single TCP packet, it can be broken up into many packets and reconstructed in the correct order on the other side. TCP guarantees that data is in order and complete. I've already talked about that. At the heart of HTTP is the HTTP message. So if you haven't been inside the protocol, I'll be referencing a lot of stuff from the RFC in this course. The RFC is giant. Okay, RFC 9110 and 9112 represent HTTP 1.1, or a good part of it. 9110 is like the semantics of HTTP, which means that it applies for HTTP 1.1, 2, and 3, which is quick. But HTTP 9112 is just HTTP 1.1. And so we're going to really be just focusing on that because it's really easy to understand. And if you understand HTTP 1.1, you technically understand HTTP 3. You just may not understand the actual protocol representation of it. So that's kind of why it's okay to start at 1.1, because you get the picture. So there we go. So here is what HTTP 1.1 looks like. It has a start line, then it has a CRLF, which I like to call it a registered nurse, a /r/n. It's much easier for me to remember that way. A field lines. These are headers. Field lines are headers. They just use the term field line in the RFC. They don't, field name and a field value. I know, we call them headers. And then we have a message body, which is optional. Okay, fantastic. You can see right here, bada bing, bada boom. All right, so what is our assignment? Our assignment is run your TCP listener program to redirect the output into a temporary file. Shazam. Got it. Okay. In another shell, do this. All right, perfect. There we go. There we go. We got those two things done. Kill both programs, and then do this. Deal. We're first trying, boys. We are first trying so hard. So dang hard. To be clear, the startup will build HTTP 1.1. Up-to-date technologies at a serious software org. Impossible, right? All right, so there you go. There's all the stuff I talked about with the RFC, right? There's 7231 is like the active reference that people tend to use. Here's the other two that are really good. This is the old HTTP. There's a lot of RFCs for HTTP 1.1. So don't get confused. We are going to be referencing the newest one that's more broken up and I think easier to understand. All right, which RFCs will we be referencing on this course? The primogens. Dang. Wrong. Okay, we'll be doing this one. So probably have already figured out, curl is a command line tool for making HTTP requests. If you cat, this will be what is created. This is basic HTTP right here. Nothing to it. Very, very simple. This is a raw HTTP message looks like, specifically the original one. So now if you remember this, here is the start line. Here are the fields. Here is the empty. You can't really see it, but here's the empty header. Apparently, they didn't have the empty header in here. Here, let's go like this. Temp, what's it called? HTTP. No, it was raw, right? It was raw get HTTP. There we go. You'll notice that there's an extra additional line right here. That's because for HTTP to work, there's that extra empty header in between the message body and the headers. That's how you signify that we're going into body parsing. And since there's no content length, there's nothing that says that there's a header here. There's no chunked encoding. We know there's no message body. Right? Typically, that's how you do that. All right. That's at least how all HTTP 1 has kind of done things, is you need a content length or a chunked encoding. Transfer chunked or whatever it is. I forget the exact name for it, honestly. It's been long enough that I forget the little details. Okay. So let's see what a raw post looks like. Yeah, let's post it up, boys. All right, there we go. We have the post, so now I'm just going to curl, but let's grab the curl post right here. Bam. Awesome. There we go. That should get everything in there. Awesome. Now we should be able to do that one. We should be able to grab the submit, Put it in there, and we passed it again. Oh, boys, we are just first trying like a boss. Okay? All right, you probably already figured this out or knew, but curl is a command to line you up. We've already talked about that one. There you go. So I put this out in a more obvious way to look at it, which is a get. We have a start line. We have our field lines. We have our empty field line. We have an empty message body. For a post, though, we have our start line. We have our field lines. Notice that we have a content length 22. That's this right here. That's 22 right there. It says it right there. We even say the content type, which is JSON, so that helps. Like, that's why whenever you use a server and automatically an object comes out, it's because the convenience is from the header telling the protocol or telling the server that what comes through is JSON, and it can take the liberty of already doing that for you. If you've ever worked with something that adds a little extra convenience to it. That's also why your client, when you receive an image or if you receive JavaScript and it has application text, it will fail to load often. It's because you have to tell it that it's loading JavaScript for your browser to be like, it's a safe resource to execute JavaScript with. Which the to request has a message body. That'd be a post. Gets typically don't have bodies associated with them, but you can. You can technically do any of it you want. You probably already figured this out, but curl is a command line tool, blah, 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 blah. Which line is not a field line? Field line, not a field line. That's the start line. Boom. In most of our Go courses, we encourage the use of standard library testing packages and tend to use table-driven tests. But the PrimeGen X Netflix, by the way, yes, X Netflix, because I quit, has a different preferred approach. So we'll roll with that in this course. Yes, it's true. So this is typically how people write apparently tests. Is this? Now me, I do not like table-driven tests. I think these are an abomination. And the reason why they're an abomination is that I do not like adding logic ever. I want my test to be as declarative as possible. So this is how I prefer things when it comes to tests. I want things so dead simple that I never, ever, ever have the possibility that I get misinterpreted, right? Like that I can somehow goof stuff up. I don't want to have to, like, I hate debugging table tests. I hate having to set breakpoints or print effing through a bunch of not needed ones or adding if statements around tests. I want them to be simple. I want to turn on or off things much easier. I do not like table tests. I have never been a table test guy. That's it. I actually hate tests. Well, okay, that's fine. When it comes to doing something like HTTP, you should probably have tests. The reason why I say you should have tests is I have a very simple rule, which I think I put it in here, and I tell people why I do. There you go. So I try to make my tests big, just generally speaking. The more things I can cover, the easier it is to, like, underneath move things around without the test breaking, right? I think everybody gets that. End-to-end tests will probably break less than unit tests. Pretty reasonable, right? But I rarely write tests. I only write tests for functions I don't think I can get right first try. So if you ask me to sum an array, I'm not going to write a test for it. I already know I can do that. I can do that every single time. I'm not worried about it. It's just not something I think that there's going to be a high probability for a bug. If it comes to text parsing, okay, easy to screw up. There's some cases that I may not have thought about. It's a little bit nicer to have tests for. So I kind of have this, I have that as my mentality. Okay, there we go. So here we go. I prefer the simple procedural approach. Yes, I like this. Fewer conditions, fewer things for me to get wrong in my tests. Correct. Because I don't like logic. Okay, logic is where bugs are at. Last thing I need to do is have tests for my tests. We'll be working with a request line parser, so let's get our directory structure and test dependency set up. So Lane has changed my directory structure, and that's okay. We're having internal requests. All right, we can do this. I can roll with this. I'm not afraid. All right, so I assume we need a little request.go, package request, and then we also need a request test.go and package. I would, you can typically do that one. There we go. That's also part of the request package. Okay, nice. Okay, so we're going to just keep it like that so we can reach for internal stuff. Install the testify package. Func, what's the test we're going to be doing? All right, I've added a simple test that doesn't test any application logic yet, but ensures you have testify and everything set up. All right, let's just go like that. So we'll go like this, bam, 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 bam. Do that bad boy, and then we can go like this. Go mod tidy. You don't have to do all that other stuff. LSP restart. You don't have to do that. You don't have to use go get anymore. You can just use go mod tidy. That's what I prefer to do. Go little go mod tidy. You know what I mean? All right. We can run our test to make sure they all work, but I'm not going to run my test to see if they all work. Instead, I'm just going to assume that I'm right. You know what I mean? Bam. First try. Didn't even test. Just like my lack of test, didn't even test. So there we go. So parsing the request line. So we're gonna start with the request line. By the way, this is your request line, your start line. It's how you like. It's like it's the declaration for what's inside of the request, inside the HTTP message. Now, it's time to get to the best part of any project, the string parsing, which, by the way, I actually like string parsing. I personally find string parsing fun. Some people hate string parsing. By building on top of TCP, we already have code that handles plain text data. Now, we just need to take that plain text and turn it into structured data, ensuring that it follows the HTTP protocol. So here we go. Here's our example given stuff. Now, notice that this is actually an incorrect example. So, Lane, I'm going to have to report this. Here we go. I'm going to report something. Yes, I'm gonna have to report an issue. Sir, your get example at the top has a body, but it does not have a content length that reflects that it has a body. This is incorrect. Okay, this is incorrect. You have run afoul. Tips Fedora. Boom. Submit. Appreciate your feedback. Appreciate you, buddy. Should have known better. Idiot. Idiot. Thanks for your attention to this matter. Ding on the yeah, dude. I know. Classic maintainer. Well, the nice part is that Lane takes my shitty writing and turns it into nice writing. So he might have just accidentally pasted this incorrect, and he meant to have this as a post with all the other stuff. Like probably accidentally goofed the two up. But either way, doesn't really matter. We want our HTTP parser to return a struct that looks like this. Yes. Boom. So let's grab that bad boy. Let's grab that struct, and I'm going to add these two things to my harpoon, so I can go because that feels good. You know what I mean? No, that's not what I wanted. I wanted this thing right here. We want our structure to look like this. Okay. This way, our application logic, the server code, has a nicely structured HTTP data to work with. The goal is to take the server we've created in the last section and have it parse out the start line according to the RFC here. So you can go check the RFC if you're ever curious. I made sure I always linked out all the parts to the RFC that were relevant. So this is how you actually look at, like, say, the HTTP version. You can read this. It's actually a pretty simple way to read this data, right? HTTP version is an HTTP name, a slash, a digit, dot, digit. In other words, it's HTTP slash 1.1. Right? So I tried to link out the RFC wherever I could. That was super relevant. And then also included like inline version, so it's really easy. It's a bit hairy to read, but I think you guys get that. So there you go. You can do this. So the assignment here, we are using test-driven development. Uncle Bob would be proud. On a real note, when it comes to black box RFCs like this, good tests help us move blazingly faster and avoid bugs. So this is where I actually think test-driven development is good, in the sense that there is a singular right answer here, which is the protocol. I read the protocol, I make the test from the protocol, I fulfill the test by implementing it. To me, this is a much easier way to do TDD, and this actually makes sense, right? This is where things are well-defined. It's also a black box, and I like it, right? It's when it's not a black box that I don't like, right? Like, I wouldn't do it for something I don't know. This is a well-defined. All right, so here we go. So now we have this one. So here we go. Let me try grabbing that. That's not going to copy either, is it? I wonder what's going on with that. All right. Let's go like that. Let me just do that. So there we go. We have our request and our request line. Why did you put it that direction? That upsets me. That actually upsets me that you define. I know you can do that with Go, but I don't like that. Okay, I don't like that. Okay, so there we go. There's our requests. And then let's see. Don't forget to capitalize your exports. Yeah, I know. Don't forget. Yeah, I know. I hate that. Hey, it's still better than public static void main. Yeah. Okay. First off, Lane. Okay, I haven't read this yet. This is something new Lane has added. First off, Lane, public static void main is actually, it's much different than a capitalized export, because first off, it's a static function that can be ran on a class object, and also this is the main entry point, okay? And this is the return type. You don't have to say the return type, okay? You don't do this for every function, Lane. Okay, don't be dogging on Java just because of one small little thing. Come on, dog. All right, we're going to stub out a new function right here. So this is beautiful. Let's stub it out. Okay, there we go. So let's stub that function out. All right, add the following test to this thing. Okay, I'm just going to, dude, how do I copy things? All right, and then let's go into here and, yeah. There we go. We're going to add the import. Let's add this import. All right, is there anything else? All right, let's just make sure I understand everything. So we're going to do a new request from reader, which should be this guy. Awesome. New request from reader. Let's do it. All right, we have, and that does strings, HTTP 1.1, host, localhost 42069. Good job, user agent, curl, accept, **. So there you go. And then you can see the empty line right here, right? There's the empty header, right? Because remember, every header is separated by a registered nurse. So you can see the first /r/n, and then the second one is just right here. This is the empty one, right? Because there's nothing there. We now have an empty header that signifies the end of the headers. Awesome. So we'll have a complete request, and then we expect coming back out that, by the way, you're using assert as opposed to equal. Oh, interesting. I would have used require the whole time, because assert, if I'm not mistaken. Wait, which one is this one? Yeah. Does assert? How does assert work here? I forget if assert is okay. I can't remember if assert doesn't fail immediately. So me personally, I'm not an assert boy. I'm a require boy. A require fails, but it fails immediately. Assert, I believe, can keep on running and then only fails at specific spots, or fails once the whole test is done, which is like a little bit weird, right? The code looks magnificent. Well, thank you very much. So there we go. You can see I do a get, we do a slash, we do this. Awesome. Test a good request right here. We do another one. This should have get, it should have coffee, it should have 1.1. Okay, perfect. This last one should do this one. This should just be /coffee, HTTP 1.1. You'll notice that the start line right here is in fact a failure. Okay, good. We have ourselves a failure. And we should expect there's an error. All right, awesome. So I guess we get to kind of make up our own errors here. So I'm going to go like this. var, let's see, error, what are we going to call this thing? Bad start line, right? I don't know what to call that thing, right? Error F, bad start line. Why not? There we go. Perfect. Everyone's on board, right? I think that's how you do these things. All right, beautiful. Is everyone ready for this bad boy? So we have our test, it's up and running. Okay, so now what do we need to do? We need to implement request from reader function to parse out the request line from the reader. Here's some things to keep in mind. For now, you can slurp the entire request into memory using IO read all. Okay, that makes it really easy. Create a parse request line function to do the parsing. Remember, new lines in HTTP are /r/n, not just /n. Technically, that's not necessarily true inside the RFC. If the first line is separated by a /n, you must assume that all following lines are separated by a /n, which is not necessarily like that great of an experience. And I think there's a lot of parsers that don't do that, and so it will automatically fail. But a part of the RFC is that you can actually use just /n, and so it's like a really inconsistent parser. Yeah, so don't worry, don't worry about that thing. Okay, that's one of those things that just use /r/n. If you don't use /r/n, there will be some like transit along the way that's still running some old library that doesn't accept that, and it'll just like your stuff will just fail. And you will have no idea why. And it'll be very confusing and very painful because you didn't realize that there's some node from 1999 and it's still parting like it's 1999, and boom, you're dead in the water, right? So we're gonna do all these things. So let's do, I'll get the function up for func parse request line. And what should we pass into the request line? That's a great question. How do I want to do this? I will take in some right now, let's just try byte for now, and it will return a request line, or it's going to return an error. How does that sound? That's a pretty reasonable interface, I'd say. All right, I'm happy. I'm happy with that interface. Okay, so, interesting. Okay, so you're using string.split. I would use bytes.split, but I guess we can use string. We'll use just string, right? We're not going to concern ourselves. Dude, we don't have to concern ourselves with strings or with bytes. Ew. Verify that the method part only contains capital alphanumeric characters, right? Verify that the HTTP version is 1.1. Yep. All right, here are some additional references that might help, but don't overthink it. This step should be pretty straightforward. True. Add more test cases and request underscore test go to cover any edge cases you think you might be here. Yeah, right. You think I'm going to do... You think I'm going to add tests? What are you, idiot, Lane? All right, so there's some things I don't like about the interface I made. Because if you think about this, I have request line. I should have the rest of the string that is remaining, and then the error. Does that make sense? Because that feels like a better interface, at least to me. I have not taken my own course or looked at my own course in about 6 months. So I've actually forgotten the way I originally did it. But in my head, it's easier to have something that can parse a request line, right? And just be like, okay, here you go. And then returns the rest of the string that it doesn't know about. So watch, I can go like something like this. This is what I mean by that. I can go var separator. Why not? I think I probably spelled that correctly. And if I didn't, If I didn't, then guess what? Don't care. Remember, registered nurse. There we go. And so I'll have this one. Index equals, let's see, let's go like this. Strings index. It's funny when I can't remember how I wrote this. And now it's like I get to rediscover how I wrote this. All right, there we go. So we have our index. If IDX equals -1, meaning we haven't first found our new line yet, we haven't been able to parse out our start line, then I'm just going to return nil, and then I'll return the string that we are using and nil. There's no error, but there's nothing for me to return. We haven't done anything. Now, I guess if I were to write Go in a better way, perhaps I could return an error being like incomplete start line, right? And then that way I know I'm sending back a very explicit message like, hey, it's an incomplete start line. But for the sake of this, I don't think I need to do that. All right, here we go. So we have the IDX, we have the separator. So now we have the official line, or we have the good part, the goods, right? We have our start line up, wrong language. You do not do that here. That is not how we do this. B up to the IDX, right? All right, and then rest of line. Rest of message. Rest of message should be B, IDX plus the length of the separator, right? Remember, we're skipping the separator. Don't include the /r/n. Your life will be miserable if you do that. Don't do it. Do not do it. I've made that mistake many of times. So I'm going to return rest of, I'm going to return, that's a good one, request line. There we go. We'll put in one of those. I will have rest of message, and I'll have nil down here. So we're gonna fill this out. So we have our start line. So now I'm gonna have parts, which, by the way, again, I just want you guys to realize that I've been playing with Elixir. That's what you need to do to be able to parse out a start line in Elixir. I just want you to look at that for a second. That, my friends, let's do it. Go is more verbose. Go's simplicity sometimes bites you in the butt. And this is one of the places where it does bite you in the butts. All right, here we go. Parts, let's go like this. Strings dot split. And let's go start line. We'll have our start line, and I want to split it with a space, right? There we go. We have a beautiful little space right here. Fantastico. And so we should be able to get this bad boy out. And now I cannot remember from the RFC or not. I'm pretty sure the RFC allows one or more white spaces. Maybe here, let's see can we go back to the RFC? Where's the RFC? I know I had the RFC out here. Let's see, what does the RFC require? I just can't remember. Message parsing, I think we can request line. Okay, yes, a single space. Okay, so you don't have to worry about multiple spaces. So if somebody provides you a space, that's a malformed message. You can see right there, singular space. Very, very easy. Very, very nice. Pattern matching is pretty nice. I'm even a Go fan. Yeah, I'm a Go fan. I love Go. I am someone who actually genuinely loves Go. I think Go is really, really great. If length of parts does not equal 3, meaning we don't have method, path, HTTP protocol, then we have ourselves a bit of a problem. So let's go right here, and so we can go like this. I like the word malformed. Let's go like this, malformed, and we'll call it request line because that's technically the better, that's like sometimes I call it like a start line, but a request line I believe is a better way to say that. Malformed request line. Wow, that is way too large, but here we are. I guess I can go rest of message. It doesn't really matter because I have a malformed request line. Right, there we go. Way too long. Oh man, I've gone full Java on this one. So that means I should be able to do the following. I should be able to do method is going to be parts 0. Right? Request target, that's right. I always call it a path. Request target would be parts 1, and HTTP version would be parts 2. But we need to do a bit of validation, right? We need to do a touch of validation. Now, there's different ways in which we could attempt to validate this. I could validate it within this parsing function, or I could validate it afterwards and have something that actually does a request line validation check. And so we can do something that's kind of fun. Let's just do it this way because maybe I haven't done it this way. This kind of sounds fun to do. I'll go like this, request line, and I go valid HTTP, and then we'll have a boolean right here, and I'll go like this, r.http version return, and we're just gonna have it strictly equal HTTP version 1.1. There is nothing else that it can do, right? Our request line equals this one, return RL, bam, bam. If RL dot valid, if not valid HTTP, then we're gonna return a nil, and then let's have a, we'll stick with the malformed, right? It's I can have a better error, unsupported, insupported, unsupported, insupported. HTTP version, right? Unsupported HTTP version, right? Boom, error, there we go. And then of course we can, it doesn't really matter what I return back. Error, unsupported, bam. All right, there we go. All right, so I think this is probably how I would do it. Okay, so remember, we're gonna keep things simple because we could do that. So I'll go like this, data, equals IO read all. Remember, there's this nice reader function. I believe you can do it, you're supposed to do an error, right? Right? Read all, yeah. So if we have this one, I'm just gonna return nil error. What is it? Is it errors dot, you do wrap, unwrap. Where's the wrap function? Where's the one that you can do a nice like little wrap on it? Do we just do format error F, unable to read all, unable to IO dot read all, and then do we do a W here? I always forget this part. I haven't played with errors in a little bit to have like the proper one. Is it errors join? Is it always errors join? I have always just done this, but I don't feel like that's very good. I don't feel like that's a good way to do it, and I've never liked it. Errors join. Okay, I wasn't sure if join is correct, if join is the way you want to do it or not. So then I would just paste in this one, and so that means I'd go format, error F, unable to read, IO read all, right? And then I could also do and then do that, and do that. There we go, right? Yeah, okay, that's fine with me. Once we have the data, I'll have the request line. We'll have rest data, and then I'll have, let's see, hold on. We'll go stir equals string data. We'll do that, right? Since we're working with strings, we'll keep it as strings, even though this is not, it's not really the way I would like to do that. It makes me feel a bit uncomfortable, to tell you the honest truth, just working with strings like this. And I don't know why. I think it's part of me is this thing where it's like, I cannot live a life in which I do things that like involve copying. It makes me really angry. Return RL error, right? Okay, this one does a request, so I'm gonna go request. There we go. And then what is in here? We have request line, and that's gonna be an RL. There we go. Oh, let me guess, it's not a pointer. Okay, copy it out. Perfect. Okay, so if I've done this all correctly, then we did this. Okay, there we go. Did a quick 70 lines of code. We're gonna go back to this one. And we have request from reader. We have all these ones. We have get 1.1, get one, all this one. And there we go. So now if we've done this all correct, we should just be able to take this thing and run this one and go. Damn it. Why didn't that work? I should have first tried it. Okay, I got a failure. Damn, I'm an idiot. I'm not even a programmer anymore. Oh, I didn't realize you wanted it like that. Okay. I didn't realize. I should have read the test. Okay, I should have read the test. Hey, I just wanted to do that whole like make it red, then make it green thing. You know what I mean? I was just doing the right thing here. Okay? I was just doing the right thing. That's all. Okay? I was just doing the right thing. All right, so let's go like this. Let's go HTTP parts equals parts 2 strings dot split. Parts 2, also not one of those, but one of these. Yank that one. Bam, malformed one. This 2 HTTP parts. Okay, so if it's not a 2, we have an malformed request line. That seems good to me. Or HTTP parts 0 does not equal HTTP, right? Or I guess HTTP parts 1 does not equal 1.1, right? So now I can take out this whole valid HTTP part because I thought I was going to have that, which I'm not going to have that. So let's just take that out. Bada bing, bada boom. So there we go. We have all of those. So now all I have to do is go, instead of parts 2, I'm just going to go HTTP parts, obviously 1. And now, obviously, now that's first try. Okay, no, that's not a wrong one. Okay, hey, you know what? I'll say my fault. My fault. So what? Maybe I didn't read all the things. Maybe I didn't read all the things that I need to do. Okay, I obviously have a nil pointer dereferencing that I goofed up. Let's find out what happened here. I probably didn't read the test well. All right, there we go. So what's the ish bish? Okay, panic, request from reader, internal request 65. All right, we can do that. Let's go like that. 65 right here. Request line does this bad boy. I guess I don't really check for error, huh? So if the error does not equal nil, I should probably do this, huh? I'd like to say this is Go's fault, but it's not. it really isn't Go's fault. Where is the skill issue? All right, unfortunately, parsing code tends to be just one edge case after another. Yes, it really truly is. I remember how I said TCP guarantees data to be in order. That's true, but I never said it would be complete. TCP, and by extension HTTP, is a streaming protocol, which means we receive data in chunks and should be able to parse it when it comes in. So instead of a full HTTP request, we might just get this. G. Then we need to be able to do this. G. It needs to be smart enough to know that it's not done yet and keep reading until it gets the full request line. True. Paste in this code. Okay. What is this? What is this? Oh, into our test. Oh, I wrote this. This was pretty clever, by the way. I wrote this. This is pretty clever. I'm pretty clever. Okay. I am pretty smart. Okay. I'm pretty smart. I wrote that guy. All right, update your test suite to use chunk reader instead. Okay, there we go. We're gonna use chunk reader right there. Reader equals chunk reader. And what do we want here? We want the chunk reader. Okay, so we want to do it that way. Okay, I got that. Whoa. Did I go somewhere else? No, I didn't. Okay, so we want to go chunk reader this guy. I can do this here. I'm just going to copy and paste this bad boy. DI that one. Let's see, what do we got here? We got chunk reader. We're going to do the get right here. Then we're going to pass in this new reader. This chunk reader is actually really, really simple. A chunk reader simply is a struct that just will emit out a certain amount of data at a time. This if statement can be modularized using min. Really? Let's see what happens, boys. All right, so there we go. So this should be pretty easy. We're just going to read bytes 1 at a time or 3 at a time or some amount at a time so it's not obvious. And then now we need to update our parse line to return the number of bytes it consumed. Okay, that is also a very nice way to do this. If it can't find the /r/n, this is important. It should return 0 and no error. Okay, nice. So previous me, which I think did it more correct, is that this thing, instead of taking, see this, if it took in bytes, I probably would have done number, but since it takes in string, I return string. I think that's more correct, all right? I'm just saying, hey, I think it's more correct, okay? I think I'm more correct here. Very Sigma stream, thank you very much. Good morning, chat, what are we building? HTTP. It's in the talk. Okay, all right, so we've gone through here. We're gonna do a parse request line. This seems fantastic. Returns the number of bytes it's done. Add a new internal enum. I just use an int to your request struct to track the state of the parser. That's right, we now need to create a parser. So I'm gonna go like this. Type parser state is just an int const, and we're gonna go like this. Init, which is a parser state, equals init. And then we're gonna have done. Oh, we can't have init, can we? Init, oh, how do we do this? State init. State, what's it called? Read, or what is it? State done, right? Parser state equals done. There we go. Oh, we don't do these, do we? No commas. Init. Oh, it's an int. Yeah, that's right. We can just do that. We can just do that. You know, actually, I'm gonna go with string. I feel like I like strings better. You know what I mean? Because then I can read them. If there's an error, it just feels easier for me to read. You know what that means? You know what I'm talking about? You know what I'm talking about? I feel like I like that better. And I kind of want to make some changes because honestly, I want to consider more, so obviously we're going to have like a state parser and all this kind of stuff. I feel like it makes more sense. I'm curious how we want to do this. Implement a parse data method. It accepts the next slice of bytes that it reads and does all this. Yes. Okay. So I see how we're doing this. Let's see. Hold on, let me see this. I don't really like this transition. I feel like it's a touch confusing. Implement a new function, request parse data int error. It accepts the next slice of bytes that needs to be parsed into the request struct. It updates the state of the parser, and it parse line field. Yes, it returns the number of bytes it consumed, meaning successfully parsed, and an error if it encountered one. Okay, cool. So let's start here. Okay, so this should be pretty easy. So what I'm going to do is I'm going to need to go up to this thing, and we're going to have a state, which is going to be a parser state, right? I'm also going to take this, and I'm going to delete that, and I'm going to put it up top. I have this thing where I just don't like, I like everything that's needed should be above. It's just like a me personal thing. It's just how I like to live my life. So that's my parser state. And so now let's go here, and we're going to take a request from reader. And how do we want to do this? What we're going to want to do is instead of doing this read all business, which is not necessarily the greatest way to do things, I'm going to go like this. I'm going to create a request, and this request is going to be this bad boy right here, right? There we go. A nice little pointer to a request. Fantastico. We have these things. And so when I create this, actually, let's go like this. Let's go func new request. And this thing should return out a request. And I'm going to go like this, return request. And I'm going to have state should be, what's it called? What do I call it? I call it state init. Right, there we go. Fantastic. I kind of like that. It doesn't make you feel a little bit better, right? It makes me feel a little bit better doing it this way. New request. There we go. So I have my new request. Everything looks good. We're ready to start rocking. And so now I want to create a for loop instead of reading everything at once, right? We want to simulate reading slowly over time. We don't know how long this thing's going to be. You'd never want to do, obviously, read all in practice because it could just hang. You know, you don't want it to just hang because you only need to read through the headers. The body parsing doesn't need to happen right away, right? You can send off a message, hey, I got a new request. It's to this path. It's a post. It has these headers. And then it's, you know, you're able to run. In fact, you don't even need to parse all the headers. That's why often you'll notice that some libraries, when you want the headers, you have to do some sort of async operation like an await in JavaScript. That's because after you read the first line, you already know what handler to call because you have the path and you have the verb. So if you have a post for /foo and your first line already contains /foo, you can call that handler and then it can await the headers while you're still waiting to parse. That's why there's all these like little speed up and tricks that you want to do. And this is why it's also really good not to, I mean, and this just is also just an insane way to do things, right? But it was good for our little initial reading, right? So I'm gonna go like this, data equals make bytes. Let's just go with 1024. I like nice powers of 2. It just makes me feel happy. I'll go like this, buff. Let's go buff, and let's also go n equals 0. This is kind of where I'm at. I'll call it buff index. We'll call it 0. I feel like this is the right way to go currently. Okay, we'll see what happens here. So now that we have that, we're gonna go like this, request.parse. I'm gonna parse out some stuff after I do a little bit of reading. So I'll go like this. I'll go reader.read. I'll read in the buff, okay? I'll read in the buff, and I'll pass in the slice starting at buff index here. So I'm gonna read starting right here. So obviously I start from 0 to 1024. I'm gonna read out that data. In here, I'm gonna get n and error. I still don't know really what to do with errors right now, right? Do we pass back out the errors? Probably something we need to go to do. What to do here, question mark, right? If we get an error while reading, should we just pass through the error? You gotta remember end of file is also an error. So it's like you probably should handle end of file. That means that the connection has been closed, right? So there's some things we gotta kind of figure out here. So there we go. So we have this bad boy right here. So we've read out some data into the buff, which means that we have our new buff index goes all the way up to buff index plus n, so we have a little bit of a goofiness. So we actually want to be able to take the request and we want to be able to parse out our buff starting all the way up from here from buff index plus n, right? Do you see that? We want to parse all that out, get out all these answers, and then the output of parse should be something a little bit different. So let's go in here and let's go like this. Let's go func r is going to be a request, right? And we're gonna go parse, which is gonna take in some data, right? Which is gonna be a byte. I like working with bytes. Bytes make me happy. And then I'll pass out an int and probably an error. That's probably what we wanna do. How much of the buffer we parsed and our error. Does that sound pretty good? And then we'll have another funct called our request is done, which is gonna be a Boolean, which I'll just call done, because you don't need the but is. What is this, C#? Get that line out of there. And I'll go like this, return r dot state equals state done, right? There we go. Pretty straightforward, right? So now we're building up our state machine to actually do parsing. Because before we just kind of raw dogged it. We just grabbed all the data at once, parsed the header line, said we parsed it correct, or not the header line, sorry, the start line, the request line. Everything was great, moved on from there, right? So now we're gonna start actually doing more proper stuff going on here. So we're gonna create a new request, we're gonna make our buffer for reading, we're gonna read out the buffer. Still don't know what to do with this error yet because we got to kind of figure out that thing. And then we're going to take this request, we're going to do that, and that'll be readn and error, right? So if we have an error, we should probably also return out an error, right? There's something there that's really important about that. And there we go. And so once we parse out this thing, this looks beautiful, right? And then we'll go like this, while not request done. There we go. We're just going to keep on reading while the request is not done. Pretty straightforward. Now, this readn, we obviously have to do something with that. That shouldn't be too hard. You can imagine that what we could do, I think an easy way to do this is that once that data has been consumed, we no longer need the data. So I theoretically should be able to do the following. I should be able to say, okay, buff index equals buff index, or it'd be plus equals n, right? So that's where the new buff index is. Here, well, in fact, we'll go like this. Here, we're going to rename index to length, right? It makes probably a little bit more sense to call buff length. So that's our buff length. All right, so we're going to read our buff length. Now, whatever data we have read, we can go buff length minus equals read n, right? And then we can copy. Actually, let's not do that quite yet. We'll do that at the end. And we can copy. This takes a destination and a source to read from. We're going to take our buff as our destination, and our source, of course, is going to be starting at read n up into buff length. Now, there might be an error here. This is always one of those things that it gets a little bit tricksy. Whenever you're playing with slices, real easy to goof this up. But that should be, I'm going to take my destination, which is just my buffer, and I'm going to take from the offset of read n up until the length and move that all in. And I'm going to move that to the beginning. Then I'm going to adjust my buff length, and we're going to call it a day. Pretty straightforward, I'd say. Everybody understanding it? I think everyone should understand this. Pretty easy. So there we go. So now we have a nice reading mechanism. The reading mechanism is super simple. We don't care about the underlying, how it's parsing and all that. We just care about the reading. Reading bytes after bytes after bytes after bytes, keeping a buffer going like this. We also have this one problem, which if you haven't guessed, we have this whole problem where theoretically the buffer length could exceed the buffer we've allocated, and we need to make our buffer bigger. Not currently worried about that, but that's just a call out. Note, buffer could get overrun. A header that exceeds 1K would do that, right? Or really just, or the body, right? The body would also do that, right? So obviously, things you got to be a little bit careful about. All right, so there we go. We're going to drop that problem. And so now we have this thing. So we're going to just drop all of this. We're going to drop all of this. We're going to return request and nil. There we go. So now the parse needs to be more correct. So I'm going to go like this. I'm going to go switch, right, r.state, and we'll go like this. Case state init. If we're in state init, we'll do this. State done. We're going to return 0 or like nil, right? If we are done, we're done. That's that. Maybe. I'll go like this. Read equals 0. Read equals 0. There we go. And then we'll do a little for loop on top of this. This will make sense here in a second why we're doing this. And then I'll put that out here because I typically like that. Outer, and then do a little break outer. Right? There we go. That's typically how I prefer to program this, is I have a state machine that keeps on running. Because you can imagine you could also get a really large piece of data that contains several state transitions. So you want to keep looping. So it's like, oh, I can parse the start line. I can parse a header. I can keep parsing header. So I can parse all the way up into middle of the body. So you want to be able to do that in like a single for loop, but you also want to be able to return how much you've actually read. Okay, cool. So we're kind of getting places. So I'm kind of like doing things. That labeling gives me the ick. Oh, labeling gives me the ick for sure. But I also just hate returning from a deeply nested item. It's just a me personal coding technique that I found bites my ass a bunch. So there we go. So we're going to parse based on this data. And so if we're in state init, that means we need to be able to parse out the header. So I'm going to go like this. Let's go back into here. I'm going to change this to byte because I just prefer bytes, okay? This is how many bytes we've read from there. Let's go. So that means I can go like this. Bytes. There we go. We have a separator, which let's take the separator and let's go like this. There we go. So now we have that bad boy, which I'm going to go like this. We read 0 bytes, couldn't find anything, no errors, right? So if we have no separator, no /r/n, no registered nurse, we're not returning anything, no errors. It's just not simply there. All right, our start line is same like that. Our rest of message is that, which is good, which we don't actually even need to worry about that, right? Read equals this, right? That's how much we've read. So now we're going to take this little, this, and we can go bytes, and we can actually just take that bad boy. And I think we can do, does it have split? Does it have split? And, okay, it does just have split. Okay. Byte. There we go. So we have all the exact same stuff, right? Look at that. We have all the exact same stuff that we're just doing. We're just simply replacing things with bytes instead of strings. Because remember, a string is a byte. Or a string is a byte array. It is the exact same thing. They're no different. All right, so this is where the only thing that becomes a little bit different. So I can just go like this just to make it easy. Remember, we're not concerned about performance on this. I can just string these ones out, right? By stringing those out, makes it really easy. Awesome. All right, so now we have these things, which is going to just simply be a string, string, string. There we go. That's correct. And then a read. That's how many bytes we've read. All right, so there we go. I've upgraded this request parse line from a string into a byte array. I prefer bytes. I think bytes just make more sense to think about when you're parsing stuff out. It just feels more correct, at least in my head. Okay, awesome. So now we do read 0. If we are in state init, I'm going to go like this. I'm going to go, what's our return format? Request line, that's right. So I'd go rl n equals parse request line, and then let's just pass in the data, right? The data starting at read. Right? Because how much have we read? I don't know how much we've read. If we've read stuff, most fantastic. If we have an error, then we'll just simply go like this. I didn't read anything. There's an error. We don't care. It's wrong. Get the hell out of here. I never want to talk to you again. You're a loser. If we don't have that, we can go r dot request line equals rl, right? And then we need to do that whole copying business. And then we also need to go read plus equals n. Fantastic. If n equals 0, then we simply need to break outer, right? We need to get out of here. We haven't read anything. We're unable to move forward. You're going to have to keep on parsing for us, right? All right, everybody on the same page? If you're not on the same page, I'm sorry. We're moving fast. We got to get things done. So as you can see, we now parse the request line. If there's an error, we go, error. If n equals 0, we just simply break outer and return. If we have actually done this, we go right here, and then we need to go to the next state. So that means I need to go like this. I'm gonna go like this, state.done, right? That's the next state. Now, I bet you there's a nicer way to actually like make this state transition. Right now I'm doing it this way. I bet you we could come up with something that's better, right? You could have an array of states through, but we haven't quite done that, right? So I could also do something like this as well that is kind of interesting. I could do something like this and have a state.error, right? I'm not sure if this is any good. I'd have to actually think through this, but I think that it's going to be fun to do this anyways, just because I want to kind of do this just to see how it feels, right? So I can go state equals state.error. That is incorrectly spelled. I've never been afraid of bad spelling. Never been afraid. State.error. Return, what's it called? 0, let's see, errors. Should I have this defined? By the way, for us Go people, do you like to have your errors defined like this? Or do you actually, you know what, me personally, I don't like how many, it makes me feel like I'm yelling at myself. So I'm just gonna like this error malformed request line. I feel like that just makes me happier, honestly. Error unsupported HTTP version. The hard part is that now that I'm getting into Elixir, my brain is like elixiring really hard all the time. And I'm finding myself like just changing all sorts of things that I normally wouldn't do. Request in error state. Request all in error state. There we go. I'm currently defining it like that, but I feel like I shouldn't do that. I feel like there we go. So if you try to do anything, if I'm in an error state, I just say, hey, you can't do anything. There you go. So all right, I'm happy with this one. Super fantastic. We'll yank this one, and we'll also have error. Which will be state.error, and that way my little for loop can have and not request.error, right? I guess, or I could do it the other way around, or r.state equals state.error. Yeah, that actually might feel better because it is technically done. There's no progressing. Who cares? We're not too worried about things yet. All right, so this looks nice. We have all this beautiful stuff. We're all feeling good about what we've done thus far. I have my error state, I have my state machine, I have my initial state, which is the parse lining. If we encounter something in which we can't finish the request, we should be able to do that. And we have our done, we have our loop that keeps on running, and then ultimately we'll return this. So if I've done this all correctly, my test should continue to pass. Now, here's the deal. I have not actually attempted to try this out because, bros, we are just first trying every try. So here we go, first try, and we first try, and we nailed it. Nothing. Come on, let's go. Okay, here we go. Okay, we are first tryers. Let's keep on going then, huh? Congratulations. Parsing data as it comes into the program is much harder than parsing an entire message. Yes, I think we can all agree to that. Parsing things byte by byte is actually a very hard practice, and it's a really good way to tell if you're actually doing something well by us doing it like this, right? We are reading it one byte at a time. We get G, E, T, space, / C, O, F, F. And so we're just running through this loop over and over and over and over again, which actually makes it really, really nice to do. So I actually don't know how I did. So look, we're about to look at my code from before. This is kind of crazy. Let's see how I did it. Okay, so we have our CRLF. That would be our that thing, our buffer size 8. That's how, I'm curious. So we actually go request from reader. We're going to do this one. We do a little state. We have a request state initialized. So I did it a little bit different. I did a new request this time. We did this. Our buffer size here is teensy tiny. If you look at our tests, we also recall that we added some test cases where only 1 or 2 bytes are read at a time. We want to test at these small buffer sizes to ensure our parser can handle the edge cases where even something as small as a request line is split into multiple reads. Yes. That said, in production, it's probably a ridiculous buffer size. You want to probably optimize for performance, and my guess you'd likely start with the buffer size way larger, right? Or something. I don't know. I just work here, right? I have no idea how big of a buffer size you'd want to start with because you have a balance between allocation and processing of the stuff. But I'm sure you could kind of figure out a nice little line so you don't have to reallocate. You don't have to do any sort of additional stuff. You'd have to do some testing yourself, but I'm sure there's a number that just makes sense. And I'm sure somebody already has a number that makes sense. They're like, hey, if you do this, this is the optimal HTTP GET request. If you are an like some sort of node that just simply is a relay that forwards things on a proxy, you probably have a different buffer size than if you're doing an application, right? All of this stuff is testing. Okay, next I want to point out there's a difference between reading and parsing. True and true. Nice, look at this. I have this little bad boy right here. So let's see, how close is this? Oh, nice, we do this little bad boy right here. Nice. Ooh, you know, I did, okay, so this is what I was actually curious about. So I have in here, errors is end of file. Then we say, hey, state is done. That's it, which is kind of true, but I'm not sure if that is even true within the context of this, right? If we do a read and there's an error, how do we handle when a file has been closed, like, right? Because HTTP works with a request and response. We should effectively never run into an end of file like that. I feel like that there's a fundamental break there if we hit an end of file. You know, so I'd actually like to rethink about that a little bit. This can be confusing, but it's important to understand the difference. When we read, all we're doing is moving data from the reader, which in this case of HTTP is a network connection, but it could be a file as well. Our code is agnostic, programmer's second favorite term of the universe, into our program. When we parse, we are taking the data and interpreting it, moving it from a byte into request line struct. Once it's parsed, we can discard it from the buffer to save memory. Right. What's the difference between reading and parsing? Reading moves raw bytes into memory, parsing interprets them. Boom, that is correct. All right, state machine. A state machine is a fancy word for a system that can be in one of many different states. For example, this function is not a state machine. Correct. Because it doesn't have any internal state. It just takes 2 numbers and returns their sum. But this function is a state machine. There we go. Yes, in some sense, this is an extremely simple state machine. The machine is very one-dimensional. It just simply has a bit of state into it, and we mutate it through a function call. But it has internal state count, and each time we call add, it changes the state of the counter or of the counter struct. It's not a pure function, it's a stateful function. We built a state machine. The combination of request from reader and request parse functions create our state machine. We keep track of several pieces of state. We also actually have where are we in the state machine. That really gives it that state flow, or where people traditionally think of a state machine. They think of a state machine having several steps that we read through. How much data we've read from our reader, how much data have we parsed into the buffer, the current state, yeah, loaded. It's a loaded term here of the parser, done. All right, which describes the state machine? Any function that modifies a variable, a system that changes based on its internal state. That's what I would personally choose. There we go. Got it, first try. All right, connect the parsing. We've got all the tests passing now. Now it's time to actually use our parser in our TCP listener. By the end of this lesson, you'll have a TCP listener that can parse a request line from the curl request. Right? Hey, that would be cool, right? That means we're literally using a real library to test things. Typically, I would do a state machine as something that has states that it has to move through. It should be able to be represented by a push-down automata, right? But to be completely fair, I didn't write this part. He wrote this course, and the Wags Lane technically wrote this state machine excerpt. So if you're gonna blame anybody, we're gonna blame it on Common W Lane. Okay, let's everybody rare L lane really quickly and then put this in the YouTube video. All right. Rare L lane. Yeah, there we go. Yeah, lots of L's. I can handle them. I mean, his name literally starts with an L. Bro can handle the L's. Believe it or not, this step is super easy. All right, we already did the hard parts. Delete your get channeled lines function. We're working with HTTP now, not just new lines. Similarly, delete the resulting logic that prints the text coming back across its channel. Instead, call request from reader, assuming it's successful, and print out the request line in this format with dynamic data, of course. Okay, we can do that. Run your TCP program again from the root and redirect it. Yep, we can do that. Okay, so let's go like this. I don't have this. Git init, git add this, git commit, blah, blah, blah. I could have done Batman, but we didn't do Batman. There we go. So I'm gonna go like this. TCP listener main.go. So let's just take this bad boy. Let's delete that bad boy out. Take a listener. We're gonna do this. We're gonna get a new listener. We're gonna get a new connection, and we're gonna go like this. Request equals request and an error. We'll call it R in this, and then we're gonna go like this. Request, right? Because we have a module called request. So request from reader, pass in the con. Dude, guys, we've owned the cons. We've done it. Right? We've done it. We've owned the cons. And then we're gonna go like this. Format print L or F. How did I do this? How did he want this bad boy? All right, let's go like this. So I'm gonna wanna go like this. Log or format print F. Yeah, I like that. Let's go $. Yes, I like that. And then let's go %s/new line / I forgot to put those /new lines. Target %s/new line. And then version is %s/new line. There we go. And we should be able to go like this. R.method, R.request line target, R.request line HTTP version. There we go. Format that. There we go. We've now done it. How do you guys feel? Pretty good? I feel pretty happy about that. Nice. Nice. Okay, now we need to submit this. First try. All right, let's get into the next hard part. Honestly, so the next part's gonna be a lot more difficult. It's actually why I wanted to do this course specifically for Lane, because I feel like this is a great way to go from like a junior engineer into a mid-level engineer, is just making these understandings. Because when you understand really how HTTP works, it doesn't matter if it's HTTP 1.1, 2, or 3, you understand it at a more fundamental level. So when you see something like, oh, why do I await the headers? You understand internally its implementation. You understand the request response model. You even can naturally understand the WebSockets protocol. It'd be fun to do a WebSockets protocol one. Maybe we'll do a WebSockets protocol one in Elixir or something like that. That'd be a lot of fun. Are you implementing the full HTTP protocol or just partial? At the end of the day, it's two different things, right? There's parsing of the protocol and the server implementation of the protocol, right? So those are two very different things. So we're gonna implement the full parsing. It won't be the full server implementation, right? Because there's like a lot of edge cases. Like, how do you respond to a thread that panics in a server? Well, that requires a lot of, now you have to do like a recover. Yeah, there's 1,000 edge cases. It becomes deeply unfun. But parsing of the protocol is many, many less edge cases. Still a lot of edge cases, but many less edge cases. When we say headers, it's important to note that the RFC doesn't call them that. The RFC uses the term field line, but it's basically the same thing. The field syntax right here. Here, I inlined the field syntax for you. If you want to go read about it, go check it out. That's right here, right? So if you go right here, you can see the field line parsing. It's actually pretty straightforward stuff. So if we were to take this, we could take this. This guy is just simply a field line equals a field name, OWS. So what is OWS? I believe that means unlimited amounts of white space, right? Some amount, an optional leading white space, right? So some amount of white space. So this can be as long as it wants to be or none. It's 0 or more white space. Notice that there is no white space right here. A field name does not have optional white space. A field value has optional white space on both before the field value and after the field value, which is kind of annoying, but whatever. It is just what it is. It does not matter, right? One important point to note that there can be an unlimited amount of white space before and after a field value header. However, while parsing a field name, there must be no space betwixt the colon and the field name. In other words, these are valid. That's not valid. All right, good. Okay. Create a new package in our internal directory called headers. I made it a separate package because we'll use the header package for both parsing the request and for sending responses. This is a stylistic choice rather than a design capital D choice. Yeah, this is just It's just simple stuff. That's all I'm doing. I'm not trying to make things too hard. I think I'd write this a little bit different if I was trying to actually ship something, right? Headers.go, and I think everyone can understand that. We'll have headers test.go, package headers. There we go. All right, here's our type header. It's going to be a type header is this guy. All right, that seems pretty reasonable. I like that. Whoopsie daisies. Let's go to headers, and let's go to headers test. There we go. Bum. All right, let's put in that bad boy. All right, awesome. Create a new method for parsing a header in, let's see, a request into the headers. There we go. We're going to parse this bad boy right here. Func, that by, did we miss func? There we go. Here, Lane, I'll give you a little piece of feedback. The header parse definition is missing func. Not that it's like a big deal. That's pretty easy to, Let's keep on going here. Okay, so we have this bad boy. So create a headers.go. We're going to have to do a bit of a parsing. Create a new headers test go with the header package. And we're going to do this one right here. Can I not copy this one? I feel like it's not copying for me. So we're going to go like this. All right, I forget, is it testing T? Is it a pointer? I can't remember if it's a pointer or not. All right, there we go. New headers. Func, new headers, header. I don't think we need to do that because it's technically just a map. I don't think you need to return it as a pointer. Those are one of those things I always forget. Fantastic. We got ourselves a bit of a test right here. So let's just make sure that our test is looking good. Okay, we got new headers. We need to have a require coming in from here. Awesome. We have a cert coming in from here. Again, I don't think I'd use the difference between the two, but I don't think that's really all that interesting. There we go. Headers.parse done. All right, so there we go. What do we got here? 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 All right, we're going to create this new thing right here where we're going to parse out these headers. Okay, fantastic. Update your parse method to pass in a single test. Let's see, method to pass this single test. It should mutate the headers by adding new parse key value pairs and return n, the number of bytes it consumed. Done, whether or not it finished parsing the headers, and error if it accounted an error. Look for CRLFs. If it does not find one, assume you haven't been given enough data. Consume your data. Yep. I'm sure there's like some parsing that you have to be a little bit careful about with headers that I haven't thought about, but whatever. Right now, we're going to do this right here. All right, so I'm going to have this one const. I think you have to do var when it comes. No, maybe you can do const. I can't remember. CR registered nurse, right? /n/ there we go. Right? And I'm also going to do it on byte because I want to use it as a byte, right? Okay, this is where we have to do a var, right? There we go. All right, we're going to return a new map string. There we go. We have a new map. There we go. It's just a headers, though. Fantastic. Now we're going to parse this one. This one should be pretty easy. We're going to get data coming in, and we are going to go like this. For red equals 0. Okay, we're just going to do another parsing, right? We've already parsed once. We're just parsing again. We've done this. We've seen this. We know what we're doing. It should be pretty easy. Now remember, do you remember what field lines look like? Field lines look like the following. We have a field name, we have a colon, we have optional space, we have field value, optional white space, and then a registered nurse. And then we stop, we're done parsing headers when we encounter the empty field line or a /r/n without any content in betwixt it. Okay. All right, there we go. So we're going to do this one. We're going to parse this bad boy out. And so how are we going to do this? It should be pretty straightforward. I'm going to go like this. IDX. Yes. Let's go like this. Let's go index. No, we don't need to do index byte. We're just going to do index. We're going to go data, and then we're going to pass in our registered nurse. If IDX equals -1, well, guess what? We're going to return. We're gonna break, right? We don't want to do anything like that. We're gonna return n. Here, let's do done as a boolean. Why not? Makes me happy, right? Don't you just love a booleans? The new booleans. All right, there we go. Wait. Oh shoot! Hold on. I realized that I don't want this. That's called the naked return. I do not do naked returns. So this should be pretty easy. So here we go. We're going to do all this. So I'm not even going to read what it tells me to do because I'm pretty sure I already know what to do. So we're going to read out this one. If we run into a registered nurse, then we know. So now I'll go like this. If IDX equals 0, that means we have hit the empty header, right? This is the ending. So now all we need to do is we need to go like this. Done equals true. And we need the break, right? We are done. We've read everything we need to read. Okay, the end. Else, let's go like this. Let's take this bad boy out, and we need to grab out the header in right here. So let's go up here and let's have a func, and I'm going to call this parse header, which is going to be a line, a field line, a field line. That's going to be a set of bytes. So we already know that this is a field line. It should either work or it should not. So that means I'm going to return a key, I'm going to return a value, or I'm going to return an error, right? Easy peasy, pumpkin seedsy. This should not be hard. I'm going to go like this, parts equals bytes dot split. There we go, and I'll go field line, and I'm going to split it with the colon. And we're going to go byte, whoopsies. We're going to put that one in there, and we're going to do this, and we're going to do this, and we're going to have this nice little parts, and let's go like this. If parts, length of parts does not equal 2, if, ooh, actually, no, I need to do a split end, don't I? And we're going to just do 2, right? Wait, hold on, what is split? Let's see, I forget, what does let's see. Splits it into 2 sub-slices, separated by a separator, right? So if n, let's see, at most n sub-slices. The last sub-slice will be unsplit remainder, right? Okay, so that means 2 means 2 sub-slices, right? Because you could imagine your field value, I believe, can have a colon in it. And so if your field value can have a colon, what ID am I using? A NeoVim, baby. If I have a colon in my field value, I don't want to have multiple splits. Right? So there we go. If it does not equal 2, we have ourselves a bit of an error, right? So we would have bam, bam, error, right? The error would be format errors. Let's see, malformed header. There we go. Bam. So there we go. If we don't have those 2 parts, we do that. Else, let's parse out these 2 bad boys. That means we have our name equals parts 0, and we have our value equals parts 1. We're going to want to take this one, and we're going to want to go like this. Bytes. Do we have trim? Do we have trim space? Trim space returns a subslice of S by trimming off all the leading and trailing white space. Let's go. Let's go. Great function. Good function. Hey, good function. Let's go. Good function. Good function. Everybody clap for the function. Clap for the function. Let's go. Good function. Split n always returns 2 subslices. Won't length parts always be 2, thus never return an error? No, because it can return a 1, right? Split n is... splits this thing, is separated by a space, and return blah 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 blah. Returns at most n subslices, so it could return subslice of 1, right? Little bit of an issue, right? We don't want 1, we want 2. I just couldn't remember if the n refers to how many times does it split, or how many subslices it is. Because if it's how many times it's split, then I do 1, but if it's how many subslices, I do 2, right? Classic off by 1. All right, there we go. We got the name, we got the value. So now I believe I need to do a little bit of sub-checking in here, right? So I need to go like this. If bytes DAS has a suffix, let's go like this, name. So if I have at least a singular white space, I'm sure there's like probably a better and more sophisticated way to do this white space checking, because, you know, technically it doesn't have to be that kind of white space. How would I check to see is white space? Bytes, is there like a white space? How do I check for white space? That's actually something I don't know. Is there a white space checking function? That I don't even know. Because I think a more complete answer would be that I have to check, because you could imagine that I could have localhost, and then I could have, well, I guess if I had a /r/n, then it would break. My parsing would break. Yeah, we're just gonna keep it as space. We'll just keep it as space. I think that's fine for this one. There we go. So there we go. If I have suffix, if the suffix contains 1 empty space, guess what? You had optional space that should not be contained in there. You have broken our contract, and I feel offended, okay? That is not good. You have hurt my feelings. So if I have this suffix, then I'm gonna return out 7 up, 7 down, paste that in. Malformed header is actually good. I'll go like this, malformed field name. Okay, malformed field line. Look at that, I'm even using the proper term. All right, there we go. So we have suffix. If we have that one, we have our spaces. We should never have our spaces, else we are gonna return name, value, nil. All right, there we go. Do that one, and we'll string that. String that. There we go. Perfect. So this looks good. So we have our value, that's trimmed space. We have our name that has that one. Then we return these 2. And now we're going to go like this. We have these bad boys. And so then after that, I'm going to take this and I'm going to go like this. Name, value, equals parse, just a singular header. And that's going to be data up to IDX. There we go. We have that bad boy. And if I've done this all correctly, which I think I've read right there. Yep. It's like this. read plus, let's see, plus equals n plus 2, because obviously 2 being the length of the registered nurse, if we're going to be super specific about that. Here, if we have an error, we will obviously return a, how do I do errors here? Bool error. I'll just like this, false error. Else, we'll go into here. What is n? Oh, I don't use n, do I? I use IDX. There we go. So we'll do those two things, and then I'm going to go like this. Now, when we do headers, now here's the interesting thing, because this already, a map is already a pointer, correct? So that means I should be able to go like this. I should just be able to go name equals value. This is where the named stuff I'm always a bit confused by, like what's the rules on that? There we go. Okay, perfect. So this should parse out as many headers as possible. And if we hit the empty one, it should return that as true. So that actually looks pretty good. I'm actually pretty happy with that one. It should fill up it should fill everything up. So if I go into here, let's test our header. Our header goes like this. New host, localhost, this. Okay, perfect. So this is a great test, by the way. Notice that there's a colon and then a second colon. So if I've done the incorrect split n, this should obviously happen. I should be able to see this one. Awesome. I do think that it would be important to have something like this, where we do something like header missing a key, right? It should return. I forget. Okay, this is something you may have to remind me of. When you have a map that's a string in Go, it returns out the 0 value for the item in the second location or in the value location. So a 0 item for a string is an empty string, right? Pretty sure I'm like 99% correct on that one. It's one of those ones where if I'm going to first try this, I would like to first try this properly. You know what I mean? I'd like to first try this one properly. All right, there we go. So this should result in an error, right? There we go. We have an error. Let's also, I feel like this is a bit of a cheating an example. You know what I mean? So let's also have foo-foo, and that should have bar, right? Let's at least get 2. At least let's parse out 2 things, right? Bar. Ooh, can you hear that lightning? Foo-foo, right? Okay. Now, personally, I do not like accessing headers like this. I kind of feel like there's something wrong with accessing headers like this. I kind of feel like you should have a headers get and a headers set. I don't really like exposing the underlying implementation of a header as just a map string. I think I'd rather wrap it. It's one of those things where I don't like, typically I don't like exposing underlying implementation just in case I change my mind how I want things stored, and then I don't get like totally effed out of my mind, right? You know what I'm talking about? You know what I'm talking about, baby boys? Right? Because if you're super concerned about speed, and you're always receiving, say, less than 10 headers or 20 headers or even 30 headers, you could use an array and do an index search. It's just better than a map, right? It's one of those things where it's nice to have wrapped behavior. It's not even a strategy pattern. It's not OOPing. It's just that you have to be smart with how you do things, right? And this is just simply being like, hey, you don't really want to expose that it's just a map, because maybe there's things you want to do to it. Maybe you want to be able to have extra behavior on top. I don't know. It's one of those things where I'd have to think about that. Ooh, that is loud. If I lose my internet connection, I'm sorry, everybody. I'm going to continue to keep on recording if my internet goes down. And I'm going to keep on going through the course. I just like to do this live. Okay. So I believe I've done everything that I need to do. Add more test cases. I've already done that. Single valid header with extra white space. Oh yeah, we do want a little bit of white space. Did we test this one? Here, we'll go like that. There we go. So if I've done this correctly, that should pass. All right, here we go. Invalid spacing header, we already have that. I have this bad boy, and now, of course, I'm going to run it. I know what I did wrong. I technically did not first try this one. I'm such a dummy. Right. Wow, that's really loud. I forgot to do that. Okay, well, look at that. So even though I got it wrong, here we go. All right, so what are we doing wrong here? Let's go like this. Go, test. Bam. All right, what's your problem? What's your actual problem here? Expected this one, actually got that one. Okay, so that's wrong. How did I get that wrong? Let's look at this for a second, because I must have done something wrong here, because why am I getting all the way to here, right? Why am I, like, 2 past makes me feel like I definitely did something really obvious, and I have yet to figure out what I did wrong. Okay, so what do you do here? We're gonna read up until a registered nurse. That should be the beginning of this all. We're gonna read up to the index, but not including the index. Okay, so yes, I think I see the problem. I think it's pretty obvious here. Let's go like this. Let's start with where we've read up to our index. Okay, I think that's better. And then we do all that. There we go. So does that fix our problem? All right. Malformed header line. Okay, cool. Where did we get this one at? We got this one at line 15. Line 15 should be right here. And that should be this one right here, which is like, are you sure? What's going on here? Let's go like this. I'm going to go like this. Format, print F header that we're about to parse. I'm going to do a little one of these. I'll do 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 one of these. And then I'll string up that data.read IDX. There we go. That should probably tell me everything I need to know. Okay, so that looks really good. I like that. That's a very beautiful thing we have right there. This one, why is that? Why? ¿Por qué Maria? All right, so obviously, what have I done wrong here? Right? I slice out the data from read to IDX. I get out of my name and value. Then I update my read by IDX and length. That seems like generally correct. I'm a little bit surprised about that, so maybe I'm just, again, maybe we're dumb here. Parsing header. Let's find out what we got here. This is the part that goes to show that parsing is hard, especially in a language like this. Every single time now, dude, I've become such an Elixir Andy where it's just like, oh yeah, I see this one. It's way easier to do it this way. This is just way easier. You know what I'm talking about? Like, this is way better. You know what I'm talking about? You know, hey, baby. Like, if I just use Elixir, it'd be so easy. Actually, I don't even know if it'd be easy in Elixir, and I'd probably be making all the same mistakes. I just like to pretend like I'm actually smart. You know what I mean? You know what I mean? Yeah, I think you guys know. Okay, so I've obviously done something wrong here. What have I done? Oh my gosh, it's so obvious. It's so obvious. Oh my gosh. It's so obvious. Do you guys see what I did wrong? Who here sees what I did wrong? Anyone see what I did wrong? I do. I see two things I did wrong. I believe I have a +2. Right? Do I have a +2 in here? No, I don't have a +2. That's fine. I don't have to worry about that. Right here. Okay? Right? We're not slicing down the header, shifting back to 0. We're moving it through. So when I have an index of 25, I've misread it like a dum-dum, and this should be better. Okay, well, that's still incorrect. I don't know what's actually happening here. Expected 23, got this. Okay, well, what did I do wrong here? Okay, that's line... All right, that's line 20. Oh, yeah, okay, oh. Well, that's because I hard-coded it to be something different. Okay, that's fine. That's fine. Here. I should technically return a 50. I should be returning a 52, right? I know what I did wrong there as well. I know what I did wrong is there as well, because when I do this, it should still fail. Yep, that makes sense. That's because when I do done is true, I gotta also remember that I have to remove out that thing. So red plus equals length of the registered nurse, right? We have to slightly move it forward. Does that make sense? My bad, because the empty header still has something we're reading. There we go. Should be false. Okay, good. Now we're on to header 21. Done equals this. Wait, what's the example they give? What? No, that's incorrect. Lane, that's incorrect. 2/r/ns, 2 registered nurses is a finish. 2 contiguous registered nurses is correct. Lane. Gosh dang it, Lane. Right? Absolute cinema. Yeah, I'm the correct one, unless if there's something I'm missing. Let's see. Look for a Sierra. Let's see. If it doesn't find one, assume you haven't been given enough data. Yep. If you do find one, but it's at the start of the data, you found the end of the header, so return the proper values immediately. Did you see that? Return the proper values immediately? Yeah, you're the wrong one, Lane. You're the wrong one. Feedback. Feedback time. Quickly, feedback. Excuse me? Did you hear the thunder? The thunder of you getting the test wrong! Exclamation point. If you find 2, read them and weep. 2 registered nurses in a row, the function should return done. And your little test does not. How does it feel? Submit. Let's see, because last time I did like an LLM response, I'm actually curious. Thank you for the report. It seems you may have a mistake. You can get help by talking. Oh, yeah, no. First off, I don't have a mistake. You have a mistake, tough guy. Damn, Prime. Prime is hurt. I know, I'm hurt. Okay, so it should be assert true. Done. Assert. This one should be false because there's an error here. There's an error here. Truing. There we go. Nailed it. Nailed it. Dude, we're header parsing, boys. All right. Not a first try. That's a fail. That's a fail. I will accept that fail. Hey, guys, that's on me. Constraints. We've got our header parsing mostly working, but we're actually not being as strict as we would be to match the RFC. Let's fix that. Case insensitivity. Ever wonder why there's usually a get method on a header object to get the header values? This is why I knew internally I needed to get in a set method. I just couldn't remember why. Of course, case insensitivity, I'm an idiot. It's because the darned keys, not necessarily values, are case insensitive. If you use a hash map directly, you'll have to account for content length and content length and content length in SpongeBob case. So here we go. Also, there's only valid characters. That right? It has to be a token, and a token has a certain set of what is considered like valid tokens. So here's what a valid token should be. There we go. Digits and then special characters, and at least a length of 1. There we go. That is what a token should be. There we go. My bad. Should be easy. A content length. So let's go like this. I'm gonna turn this into a struct, and I'm gonna have headers underneath because that's just the way I would prefer it. To tell you the truth, this is how I would want to do this. I'd put it like this, and then I'd go headers, right? And then I'd do that and do one of those, and then I'd go like this. Let's take this guy. Let's take that. Let's put him up here because he is going to be before the header stuff. Let's move this thing down, and then let's put him right here because honestly that feels a little bit better. And then we have this header.parse business, and we also have func h headers, and we're gonna need the, since that thing was a map, we didn't want to have to do that. Now we do have to do that. We have get name string, which is gonna return out a string. And so we're gonna go like, so this is interesting. Yeah, we'll do that. We'll keep it like that. Return h.headers.strings.to lower name. There we go. We always do that. Func.h.headers set name value string. We're going to do that bad boy. I'm going to yank that one, put it in here, go here, go here, go here. Bada bam, bada bam. Easy peasy pumpkin seedsy. Do we return an empty string if the header is not present? Yes, that's because it's a 0 value. Remember, the 0 value of a string is an empty string, not a nil. Take it or leave it. I'm not saying it's good. It just is what it is. You know what I mean? Set. Not saying it's fantastic, not saying it's horrible. It just is what the thing is. All right, there we go. So that means I should be able to jump into here, and I should be able to go like this, and I should be able to do a little get, and then do one of these, and go like this. There we go. That seems nice. Get. There we go. Beautiful, 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 beautiful. So if I've done everything correctly, I should be able to have both a get and a set. Fantastic. And then I also need to validate these tokens, right? Is the name actually within the valid set of characters? Because you have to be within the valid set of characters. And I also need to add a little extra test that tests to make sure that these things are valid characters. Here we go. So I'm going to grab all of these guys. So now I can't remember. I know there's probably a really great way to test for this. Is valid token, right? Let's see. Is token, right? So I should be able to go like stir string, right? So I have to go check for these ones. So is token, so I can take this guy, and this thing will expect it to be a length of 1. So this is where I was at. I was gonna switch this one and go, oh yeah, look at that bad boy. Look at that bad boy. Oh yeah, that's good. Actually that's return, actually, hold on. It is, whoa, it's found equals false. Found equals true, and then let's go like this. This is a nice. This is one nice thing about Super Maven is this thing. There we go. True. Can I also go like this? Can you go a? Can I do that? I can't remember if that's allowed in Golang. I thought there was a way to do this. Is it that? Isn't there a way to do this? Am I crazy in Golang? Isn't there a way to do that? Okay. Okay. Really? There's no way to do that? I just feel like it has to be allowed to do that. Is this just me being I swear there was a way. Dude, I somehow just don't. I feel like I just don't want to believe you. With the regex you can, I don't use regeces, right? I'm not a regex guy. I'm just not a regex boy. Regexes make me feel angry, okay? There we go. If not found, I'm return false, right? Boolean, there we go. Yay. Can you do that with the case? Okay, so if that's the case, You can do this, case. You can do that? Okay. By the way, I'm using what some people would refer to as the devil's lettuce of programming. Oh, you can't do that, can you? I actually have to do them all, right? I can't. Okay, you're right. Found equals true, right? I can't fall through. I can't fall through because then it won't match the rest of the stuff. Okay, my bad. Found equals true, right? There we go. Look at that nice big... there's probably nicer ways to do this in other languages. This just ain't that language. You know what I'm talking about? Okay. Okay, I feel like I've been lied to. Okay, I've been lied to. Someone told me this was true, and now I've been lied to. Okay, I am not happy with my life. Okay, I'm not happy with my life. We gotta stop this. We gotta stop this right now. All right, there we go. Beautiful, there we go. I like it. Okay, so if we parse header, we do all these things, and so then when we parse it, we have all this thing, and we're gonna go like this. Now, I forget token. Does token apply to both field name and field value? I cannot remember that. Field name is a token, correct. Field names, okay, they can only be tokens, which are defined in 6.11. So I gotta go like this. If name is token, name, if not is token, name. Wait. Oh, you're right, it does return back. I can just go like this, right? It's all the same thing, right? There you go, there's your little byte array. We got this beautiful thing right here, so if I hit this nice little token right here, then I'll go like this. If it's not a token, let's return 0, false, and the error would be simple. Okay, let's do an inline error. I feel like I like inline errors better for this one. Malformed header name. There we go. There we go. So if it's not a token, we return that. Beautiful. So we're gonna read through this. We're gonna do that. We're gonna parse the header. We're gonna validate that it's a token. Bada bing, bada boom. Now the thing I don't remember is update your parse method. Add a test case right here. All right, let's do this again, and let's go like this. Beautiful. Let's go, people. The Thunder tried to get us. The Thunder tried to get us, but it couldn't. It just didn't have the ability to get us. It did not have it. Fantastic. Let's keep on going. Multiple values. We have one more bug in our implementation. To new web developers, this can come as a shock, but it's actually perfectly valid. Oh, yes. I do. Honestly, even after I've written HTTP from scratch on multiple occasions, I forget this, and it's also the devil. Let's see. To have multiple values for a single header, for example, Lane loves Go, Prime loves Zig, TJ loves OCaml, is perfectly valid. That should be the name. That should be the value. Right? Isn't that just like the devil? Did you know that? You can have headers with multiple values. I am still convinced this is just insane to me. All right, add a test starting with a header that matches a header in the data to be parsed. Update your parse method to check if the header key already exists in the map before inserting it. If it does, append a new value separated by a comma. Let's go. That's why we used a set method, right? That's why we use set methods. So, okay, we're gonna go like this. Name equals, let's go like that. We're gonna paste that bad boy in, and then we gotta go like this. If VOK equals h.headers.name, then we're gonna go like this. If okay, right? That's found, right? Yeah. So if it is there, we're gonna go h headers name equals format. Let's just go like this. Sprint f, %f, comma, %f. Look at that bad boy. Look at that bad boy. Take the previous one, add in the new value. Else, we're gonna take this, put it into here, and we're just gonna go name equals value. Yeah? Yes. Yes. Aren't we all happy? Headers. Now, that should be pretty nice for us. Now, let's see, update your parse method, add a test. Yes. So, that means I should be able to do the following. I should be able to go like this. Host equals that, and let's just yank that one and paste it in here and go like this. Actually, it can be the same value, right? There's nothing that says it can't be the same value twice, right? Ooh, what a great test this is. Right? Done should be not there, and we should do this. Okay, great test. We never actually tested this condition, did we? Good test. So we should actually see the following. All right, so there we go. Now, they put spaces in here. Now, I can't remember if the RFC requires, does the RFC require spaces? I actually can't remember if it requires spaces or not. May combine multiple field lines within the field section with the same field name into one field line without changing the semantics of the message by appending each subsequent line value separated by a comma and optional white space, which we're not going to be doing. The order in which the field lines with the same name is received is therefore significant to the interpretation of the field values and must not change. That means, aside from the well-known exception noted below, that must not generate multiple field lines with the same name in the message, whether the header or trailers, or append a field line when the field line of the same name already exists in the message, unless the field's definition allows multiple field line values to be recombined as separated list. At least one alternative, blah, 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 blah. In practice, set cookie header field often appears in a response message across multiple fields. Yeah. So my only question was, does it always just append all the values, or is there any sort of like duplicate header? There we go. The server must not apply a request to the target resource until it received the entire request header section, since later header fields lines might include conditionals, authentication, credentials, or deliberately misleading duplicate header fields that could impact the request processing. Okay, we're just going to assume that this is correct. There we go. And now, of course, before we move on, you already know what we got to do. You know we got to take this. You know we got to do this. You know we got to run that. You know we got to get first try. You know we got to move on. Okay, just to make sure, I actually never really did test this. So if I do that, go test. Let's just make sure that that fails. There we go. Good. I just wanted to make sure I'm actually testing things, because technically I could just not have added a test and everything just works. You don't want to lie to yourself. You cheat to yourself. You cheat the forest. You know what I mean? And you do not cheat the forest. Okay, there we go. So we have this assignment. Okay, add to parse. All our test cases, let's say all our tests are passing. Now let's hook it up to the state machine and watch it parse the full set of headers. Back to the request package, we're going to update our request parse method to include header addition. Yep, so that means we're going to need to do some things. We're going to need to definitely jump into here and go all the way up to our state machine states and go, let's yank that one and go to the D and go state headers. And we'll go headers, right? So now we have that bad boy. We can go down to parse, and inside of here, we should have a case for state headers. And we should also have one more. We should also have a default. And that should, let's just go for us for now, go panic. Somehow we have programmed poorly, right? And then let's update this one, state headers. I know this is not like the greatest state machine in the universe, but here we are. We have this one. So now we're kind of ready. We have our state headers, and now we need to keep on doing headers until we are done. Create a new test function. This one will be focusing on parsing headers correctly. Okay, let's do that one. I'm gonna copy this one, go into here, and we're gonna go func test parse headers, and we're gonna go t testing t, some low t testing as they call it. Got him. All right, we have this little bad boy, which oh my gosh, Lane. Okay, Lane, we're gonna have a little chat. Lane, community note. Yeah, you found a problem. Excuse me, sir. The header code in the parse function is producing a header without a get method. Clearly the get method is for lower casing the name value provided. Without this, content length and content length would be two different values. Get your act together. I also love you. There we go. Submit. Just in case he's wondering. Actually, I just want to let you know that actually, rare L lane has been downgraded to uncommon lane L. Uncommon L. I am gonna go like this. I'm gonna take all these little header calls, losers, and I'm gonna go headers, open bracket. Let's go like this. Let's do a little classic people fighting one-eyed Kirby, right? We all know about that fighting one-eyed Kirby. Hit it in here, and I'm gonna go like this. Headers dot get, and just toss that right in. There we go, like that. Classic one-eyed fighting Kirby. You know what I'm talking about, baby boys? All right, there we go. So we have this bad boy. We have the header. So let's go back to our request. Jump into here. You're probably wondering how am I navigating so fast? Because I'm like, oh, hey, I want to go to header tests. Oh, I want to go to request test. Oh, I want to go to request. Yeah, it's called, guess what, losers? It's called Harpoon. It's great. You wouldn't understand. Headers is going to be headers. Yeah. There we go. We got the little header struct. Let's do this. Again, we're not going for any sort of performance. We are going for just going through a course linearly. We're not really thinking too hard through things. All right, so what do we have here? We have this additional method in which should now grab out these hosts and everything. So we need to properly do this, which means that I need to do the following. I need to go like this. I need to, once I get to here, where's my new request, right? How do I create a request? Request goes like this. So now I'm gonna go like this, headers, and I need to go headers There we go. I don't like, okay, for whatever reason, this makes me feel real weird. I feel like this needs to be a pointer, don't you? I feel like this needs to be a pointer. I feel like I'm going to run into one of those weird state updating issues that pisses me off and then I hate my life. And so I'm just not going to do anything, okay? So I'm just going to keep it as a pointer. There we go. All right. I've run into a couple issues and I can't remember them all in Go when you run into them. And so I'm just not going to run into them, you know? All right. So now that we have that, what I'm going to do is I'm going to go like this. I'm going to go n done equals this r dot headers dot parse, bring back in that data. And that is going to be, where are we at? How do I do this? Switch state, red. Okay, I'm gonna go like this. Current data, wrong one. I do not like the song we're listening to either. Data, read. I kind of feel like this is a good thing to do. So at the top of every one of these, that way I can just go like this. Current data, I like it, I like it. And then I update the read, I do all that. And then in here, I go like this, current data. And then I'm gonna go like this. I'll go down here and I'll go if done, then I'm gonna go like this. R.state goes to the next field, which right now we are doing things very raw doggy. Okay, we are very raw dogging it. If we go like that, how do I do the errors? Okay, the errors, I'll just go like this. 0 okay. Else, n is how much we have parsed, people. So I'm gonna go like this. Read plus equals n. Yeah. And if I'm not mistaken, this contains also the length of the headers. It does. Excellent. All right, so we have our read. We have our read as their plus n. We're going to be done. We're going to move on. And that's that. There we go. Okay, looking good. We have our read. Our read is nil. And that's what we're doing. Okay, this is feeling good, people. So I think I got this, okay? I think I got this first try. You know what I mean? Test headers, I think we're going to get that. And we're going to do it 3 bytes at a time. That feels hot. That feels good. That feels ready. I feel ready just to take this bad boy, copy it in, paste it in, don't even look. Okay, I didn't get it. Something happened. Okay, yeah. I totally get that. I don't know what I did wrong. Okay, shoot. People, I somehow got an infinite loop, okay? All right, you know what? The only way I can actually recover from this infinite loop and the embarrassment of ruining something. Hey, Primegen, you should show your promo code at some point. Hashtag marketing. Lane, it's right here. boot.dev/prime. Idiot. So, what happened? My guess is that the thing that's going wrong is this right here. The parse is, my assumption is that parse is probably correct, right? Because if there's no new line, then we don't do anything. Else we parse out the header, and then either we return false, or we return all this stuff, and then we go again, we keep on going, and we keep on moving forward. So I don't think it's that. My guess is that it's this thing, it's this state machine right here, that I read an error, right? If it doesn't equal this, we do this. If n equals 0, then we return 0 nil. Right? There's like nothing we can do. Like, hey, we couldn't read anything, but there's also nothing that we need to do. Fix your crap. There we go. That ran it. Okay, it's still not. I lost. Okay, I'm a loser. So what did I do wrong? Let's just go like this. Let's just go test. Let's just test them all. Okay, so what do we get wrong here? Request test line 40. Okay, line 40. 40, oh, right here. Oh, no error. Wait, what's the error? No error? What do you mean? Malformed field line. Wait, what? What's a malformed field line? What, porque, and also Maria? What do you mean, malformed field line, porque Maria? Porque Maria. Wait, hold on. Porque Maria. Okay, so what is actually going wrong here? Because this should not have been a malformed error. I'm a little bit upset about this being a malformed field line, right? Malformed field line should be right here. Malformed field line. Is it malformed field line is saying this one right here? Okay, interesting. So it's saying that I did not get a good parsed header here. Let's go like this, just to make sure I understand what's going on here. Let's just go format, print, f, parse header. Here, can I just use, I prefer slog, honestly. I like slog info, and let's go like this, parse header. Let's go like this, field line, right? And then let's go string field line, right? Yeah, let's do that. There we go. And let's just test this thing out. So where's my problem at? Okay, how come I don't see it? Porque, oh, there it is. I agree. That is a malformed field line. Good answer. Good answer. Hey, good answer. That's a malformed field line. Good answer. Good answer. That's bad. I agree with you because that's not a field line. I think we know what went wrong here. Right? It has nothing to do with this. It has everything to do with this. Okay, so let's walk through our parsing here. So our parsing has read set to 0. We go into here and we go state init, and then we do this one, and then we increase right here. Now up here we do current data is read. Do we do any copying or moving of data? It does not look like we do any sort of copying or moving of data, which is probably the right way to go about doing this. We just sit here and we do this. Okay, so we should hit state headers. And then we should take the current state. Oh my gosh. Is this doing the thing I think it's doing? Is this doing what I'm thinking it's doing? It is? That's insane. I mean, I guess it's not that insane. I mean, it can't be. I guess it's not that insane. Okay, so it's not doing what I thought it was doing. I thought it was, okay, I thought it matched this state init case, and since I changed state to equal this, it then matched the next case, but I'm like, no, that can't be right. I refuse to believe that. I refuse to literally believe that. I refuse. I still kind of refuse to believe that that's the case. Okay, so what went wrong here? So we do this parse line, we get all this stuff, and everything's looking good. So I'm gonna go like this. Okay, I wanna prove to myself this doesn't actually happen. I'm gonna go like this. Let's use slog again. Slog just feels really nice, you know what I mean? All right, let's go like this. Parse current, let's see, we're gonna do a parse line, right? We're gonna go request parse, and we're gonna have current data, and current data is that thing right there, but we probably want to hit it with the string because it's not really a string. And then I'm going to go in here and I am going to do a little bit of a parse line. We're going to do a little bit of state init, and I'm going to go like this, a state, because now actually I'm curious. Now I actually have no idea if this is true, right? Now I actually have no idea if this is true. Let's go like this, state headers. I just want to see if this does that. All right, so you can see that it's growing. Yeah. That's perfect. So this is where it should happen, right there. Shazam should cut that out. State init. Wait. Yeah, okay, that makes sense. Current data equals this. Current data equals this. Then state. Oh my gosh, did I do? What did I do? What did I do here? Wait, how is that possible? I thought my current data was different. I thought my current data was this thing right here. I thought my current data was that right there. What do you mean? All right, so let's look at this thing and go like this. Let's go read. I want to know what read is, okay? Read should be effectively 0, right? Read should be 0 until it's not 0, right? You know what I mean? Now I'm actually curious, right? So read should be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Bam, state headers read equals 16, which is the correct one, which should be this. Yes. Yes, that's correct. State equals headers equals 16, which is good. Then we get that, and then we have this current data equals this. Wait, what has gone wrong here? Because why am I getting this new one? Why am I getting this out? Why am I getting this out? Why am I getting that one out? Okay, now I'm a little bit concerned that I'm somehow not returning things correctly. Am I not returning parse? This is why I like, this is typically like why I like single return statements, because it honestly gets way easier. If you don't do that, it feels really, really confusing, and I always end up hating it. All right, this seems like this is the exact reason why I like only having one exit point, because I always make this mistake. It's so easy. Here. Return 0. State read init equals 0. State read headers equals this one. Hold on. Okay, that's a 0. That should be, this is a /n/add, that should be a 0. Then we find this, and then we have a current data equals ho. That can't be read, but read equals 16. Why aren't we returning? ¿Por qué? And also, Maria, why aren't we returning? Right? Why aren't we returning? See, I hate that kind of stuff. See, you see what I mean? Like this. Oh, okay. It's obviously, okay. Shoot! See, this is why we have to be smarter. It's this thing right here. I'm so stupid. So this is obviously what's happening. Does everyone see what's happening? I returned simply 0 nil. That's stupid of me. This is why you should not do that. It should be break outer because it needs to return the already read data. I'm returning, I'm not reading any data. Super, super simple. I'm the dumb one. I'm the killer. I'm the person in the room that is causing all the problems. Okay, it's as simple as that. We'll jump up here, remove that. There we go. Everything is working. I'm the killer. The killer's in the room, and I happen to be the killer here. All right, do one of these. All right, fantastic. Move on. I'm the dummy. So there we go. This is all looking good. I believe we all have the right stuff. All right, what's the next one? Let's test our request line and header parsing live with the TCP listener. Again, we already did the hard parts. What? Update your application to print the request line to look like this. Request line, header values, header key value, key value, key value, key value, key value. Got it. So we're going to go like this, and then I'm going to go like this. Let's see. Header, key value, key value. Ooh, interesting. How do I get keys out? I don't have that feature yet, right? We don't have a feature to actually iterate over the keys. So how should we design that? Anyone have any plans on this one? This is one I don't actually have a simple plan for. I don't have like a function. I don't have like a headers, right? Like I don't have like a for each, right? Do you for each over it this way? Like how do you do this one? I could create an iterator, but iterator in Go, an iterator in Go is just awful. You know what I mean? Yeah, for each, we're gonna CB func name value string. There you go. I think that should be good, and then I should be able to go slices. Don't they have a for each? Don't they have a? Do you not have a for? What do you have? Do you have anything in here that allows me to do this? Well, it's not a slice. It's not a slice. It's actually a map. It's a maps module, right? And this is, let's see, returns an iterator over the key value pairs from M. Okay, so I can go all, right? So I can go all, then I can go, but I can just go like this, right? I can just go for name value range over h dot headers, right? I can just do this, right? CB name value, right? Because it's an internal thing. I don't want to expose my internals to you, boy. I don't want my internals to get all up in the business here. That's how, I mean, I guess this is one way to do this. I don't know if I love this, but hey, here we are. Here we are. Here we are, right? Here we are, headers for each, func, yes, that thing, and then I'm gonna go like this. Yeah, it makes sense. Yeah, it's the thing to do, right? It's like if you have this you know, it's its own set of problems, you know? This is that thing that I always run into, which is like, you can spend forever trying to figure out a nice way to make things really work out, or you can just move on, right? We're not trying to, oh yeah, key value. I'm not trying to design the world's greatest interface here. We're just trying to understand how these things work. And so I don't think we need to spend too much time deeply considering how you'd want to do this, right? Whether you'd want keys or not keys, it's just like, meh. Time to just get working. Look at this. Not even do anything. So here, how do we do this? We have to take this one. There we go. All right, we're banging, boys. Boys, we are banging. There we go. We got this one, and there's the headers. Waybar. My waybar is asking over and over again to see if 42069's awake. You can see it right here. It's attempting to see if it's awake. That's why we're getting so many messages. Can I just kill waybar? pkill-9 waybar. There we go. That should prevent all that extra crap from happening. There we go. We're going to have that bad boy. We're going to do this curl. We have no response, so I have to manually kill it. We do that thing. We have that thing working. Murdered, absolutely. Take this bad boy. We're going to grab this bad boy right here, put it in here, and get the pass. Let's go. First try. We got it, boys. First try. Let's go. Let's go. All right, we're going to move on to the next one. There we go, babies. All right, parsing the body. We're almost done parsing the request, which frankly is the hardest part of an HTTP server, in my opinion. Well, it's the hardest part of, we got to probably re-say that. It's the hardest part of doing the HTTP protocol, not the server. The server has its own set of problems. Here we go. We're right here. So now all we have to do is current code parses the start line, the field line, the extra registered nurse in between. Now let's tackle the message body, but beware of the edge cases. Yes, lots of edge cases. According to this RFC at 8.6, the user agent should send content length in the request, and should has a specific meaning in RFCs per RFC 2119. This word or the adjective recommended mean that there may exist a valid reasons in particular circumstances to ignore a particular item, but the full implications must be understood and carefully weighed before choosing a different course. All this to say, for our implementation, we're going to assume that if there is no content length header, there is no body present. Good answer. This is a safe assumption for our purposes, though it might not be true in all cases in the wild. I mean, technically, we addendum this thing when we do chunked encoding. In the request package, update your request parse method to parse the body in addition to the request line. Add.body field to the request struct. It should be in the byte right here. This is where we'll store the raw body's bytes. All right, let's do that. Okay, func, test, parse, body. Let's go. T, testing, T, here, put it in. Align this bad boy. So now that we have that, we have this thing right here. We have content length 13. We have that one. That is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, there we go. Got it. Okay, bytes to read, 3. There we go. There we go. We're going to have a body. A body should just probably be a set of bytes. Okay, fantastic. We're going to have this one, partial content, content length 20. Reader equals this one. What is the error that we're expecting here? Content length 20. What's the problem? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Yeah, this is still a weird test case, and I'm still a little bit unsure if this is a good test case. And what I mean by that is that the thing that's bizarre about this is that if a connection is terminated, meaning we get an end of file before we've read all the data, what is the appropriate response? Right now, we do return an error, but I'm just curious what like the actual appropriate response should be. I don't have a good answer to this one right now. I'd have to think more about it and probably just review what other people have done, right? Bad request. But no, you can't do a bad request. The connection's already been closed. I can't send back a 400 if it's already broken, right? That's the confusing part, right? Like, do you execute the request if the connection is closed, or do you not process the request at all? Right? It's a lot of questions. It's just a lot of like design questions. I don't know. I actually don't know. All right. So now we need a new thing. We need to have a, let's go up here and let's have one of these, FD, CW, whoopsies, CW. Let's have state body, I like your body. Let's go in here and go to state headers, go down here, go to case done, do one of these, go to state headers, FHD, that body, there we go. We're in here, we're looking good. And now we're gonna parse the body out, okay? So how do we know how much body to parse out? It actually should be pretty straightforward. We should be able to have content length equals, I'm just gonna call it, length. Length is going to be, length stir is gonna be this. Actually, let's just go like this. Let's add a convenience function somewhere up here. Which is going to go, where should we put this? Where should we put this bad boy? Func get int header, right? Get int header, right? And it's going to be headers, name string, right? I just want to get int off of the headers. Maybe we should do this differently, and then we should go like this: default value int. There we go. All right. So I'll go like this: value equals headers. Dot get. You know, I think I could also change how this works. Maybe it would be better to also include a Boolean. You know what I mean? To say like, hey, this thing doesn't actually exist, right? Right? Maybe that's like the better way to go about that. What do you think? I think that kind of is a better way to go about that, right? I think that would honestly, like, personally, I think that's a better interface anyways. Just as like a thing, just as a thing. Exists, there we go. If not exists, that's gonna break a test though. Return a default value, there we go. Else we're gonna go like this, value string, and then we'll go value equals, actually, do we have to do an I can't remember. Stir conver, right? Stir conver dot a to I, does a to I? Yeah, there we go, a to I. And then we can just go value string, and that has that. If error, we'll just return default value, else return value, right? There we go. All right, so our default value will be 0, meaning that if there's nothing there, then we're good to go. Let's go back to here, go down to state body, go into here, length equals that, get int r.headers, and then, ooh, that's a terrible interface. We'll do one of those, go on in here, put in a name right there, there we go. There we go, and we're gonna go like this, content length, and there we go. Let's go. If length, whoopsies. If length equals 0, then we'll just simply go like this. R.state equals state done. There we go. Right, we're done. There's nothing we need to do. But if there is something we need to we now need to parse out the body, which is kind of an interesting problem, I would say. I would say. This is how I would look at it, is I would go like this. There's a couple different ways we could do this. One way I could do this is that every time we get data in, I could just append it to the body until we make it there. Or B, I could say, hey, I parsed nothing until I can parse the entire body. So who should be the responsible party for aggregating the data? For the sake of this one, I think that it's probably, aren't servers by definition stateless? No. By definition, they're not stateless. HTTP is supposed to be a stateless protocol, but servers themselves are not stateless, right? Super simple. You count how many requests come in, right? But HTTP itself is supposed to be stateless, if I have that correct. I can't remember. I can't remember if there's supposed to be some sort of state. I don't think there's any state added to this. You have conditionals and all sorts of stuff you can perform on an HTTP request. Anyways, okay, so now we have the body. So let's just go like this. What I'm going to do is I'm just going to keep this pretty simple. New request. All right, don't I have a new request? Do I not have a new request? Oh, I have new request. That's what it is. I'm going to go like this. Body, empty string, right? I'm going to jump up here, and I'm going to go body, string. I'm going to go 7 up here, delete that one, because that's obviously me being stupid. Right? We can all agree. Bro's dumb. Bro's real dumb. I'll go like this. Okay, so if we have that, I will now go like this. Remaining equals is going to equal, how do we want to do this? How much data should we take? Let's go like this. Let's go length, r.body, right? Length minus this length. That's how much we should get. Okay, so if I already have some data in the body, we'll aggregate on the body just to make this simple. And that means if, I'll go like this, then I will go, how do we want to do this? I just want to make sure we get the right amount. Okay, we'll go like this, remaining equals this. I'll go r.body plus equals. I know this is really gross, but just deal with it. You know, current data up to remaining. There we go. So we're going to do that up to remaining data. That's how much we should be grabbing out. And then we'll go like this. Then we'll go a minimum of this or the length of current data. That should be pretty obvious what's happening here, because you could imagine you could have more data afterwards. You could maybe have a second request ready to be queued up coming in. I don't know how exactly that would all work in your server, but you could imagine you could have more stuff. All right, let's go back in. We're going back in, people. Wouldn't it be up to the length of the current data? No, it's up to the length of the content length that is remaining. So we're either going to have the amount we need left or the amount of current data that is remaining. Then we're going to take this and we will simply say, hey, get the remaining right there. And then I'm going to go like this. If length of r.body equals length, well, guess what? r.state goes to the next field. State.done. There we go. And then we should take the amount of data we've read, which should be the remaining amount of data, which is going to be read plus equals remaining. There we go, because this is going to be important during trailers. Trailers, remember, that's a thing. Don't forget, trailers are a thing, people. All right, there we go. This is all looking very, very good. I think this should just work because, you know, first try, that's who I am. So this is our new test right here that's doing this, which should be partial content and that content, which I think is the right thing. And if we do a read from this, how does a read work? Read is on the outside. A read should happen right here, which is if we get an answer. So this is where I have the to-do, right? If there's an end of file, we have like an unexpected thing crashing. So we're just going to say, it's just an error no matter what. Your connection should not be closed. This is looking good. As someone on the sysadmin side of things, rather than the programming side, watching you code, this is downright surreal. Is it weird that I'm not even, imagine not using AI in the Lord's year 2025? Is it strange that someone could actually remember an entire programming language? And a handful of APIs? Isn't that like a funny world we now live in, where remembering how to like write a for statement with your hands and what functions exist on the standard library is now like, oh, dude, that's not good. That's like, obviously you're not trying. It's just like, how is this? How is the world? How has this happened? All right, so there we go. We have this beautiful boy right here remaining. We do all the parsing. We get it all done, and we're going to call it a day. So this is lovely. Let's just call this good. I like everything that I think I'm seeing here. Did I actually get this all in here? There's the partial content. There's the full content. Now, let's go. Do we make it? Do we get it? First try, and not a first try. Dang it. Man, okay, the first tries are definitely on the way down. First tries are definitely on the way down right now, okay? Let's go like this. First tries, not looking good. All right, what happened here? Hold on, okay, hold on. I'm actually a little bit confused as to what is the problem here. Okay, hold on. What was the problem here? What are they saying here? Okay, hold on. What is happening here? Internal headers test 17. Oh my gosh. I feel cheated. I feel cheated. I want you to know this right now. I am cheated. You are cheated. We are cheated right now. We've been cheated here. Okay. 2021. Oh no. What's the last one? I already have this written right here. Where's the true? Where's the true? All right. What's your problem here? Wait. Did I already define host? Oh, I did define host. All right. There we go. Yep, okay. Same problem here. Dang it, dude, look at what I got owned by. I just want you guys to know this right now. I got owned in the stupidest possible way from not first trying that. All right, let's go back to this one. Let's grab these ones. Actually, let's just go like this. I'm going to grab all of this, right? And then I'm going to jump back to here, and I can go like this. We're going to go into here, and we're going to go r/headers, yeah. Let's take out that. Let's put that bad boy in. And we got this one. What are we doing here? Oh, wow. I mistyped that twice in the same way. That's insane. I just mistyped that twice the same way, acceptant. Dude, that's crazy. I got to learn to type better. All right. Did I really just... Okay, good. Okay, good. It's not me owning myself. This is good. All right, so good. I actually do have a problem, 102. So they're claiming that this is a problem. Okay, good. So I must have done one thing wrong, which I feel like I can call, is right here in state headers. I'm saying it's done. No, it's body, people. All right, interesting. What happened here? All right, so we have headers test 26. Okay, what happened in headers test 26? All right, that should be a false. No, that should be, wait, what? This should be missing header, right? Or missing, I think I had it as missing key. So everything's good, but now look, we are now freezing on the other one because I have some sort of infinite parse. Oh, shit, right? That's what's happening. And for whatever reason, I think I know there's like a problem going on here, is that if I look at this thing, why am I not returning this? I should be getting an this, right? When I read, I should be getting an end of file error, and if I get an end of file error, that should be something that says like, hey, you done effed up. You done effed up. You done effed up. You done effed up. You done effed up, right? So let's find out what am I doing wrong here, because my guess is that I'm not doing this part correct, right? You know what I mean? I'm not doing that part correct. So let's go like this. Let's go like this. Let's go format, print. Actually, you know me. I'm a slog boy. Okay, I'm a slog boy. You know I love that. Parse state body. And let's go like this. Remaining. Yes. And then we go body. Let's do r.body. And then let's go read. And then I'm going to take this one. I'm going to actually jump over to here. And I'm going to put it in there because honestly, little nicer. You know what I mean? It's a little nicer having it right there because the body could be long. And then, okay, good. That's what I thought. So look at that. Read 3, remaining this, and then we can't seem to go forward. What am I doing wrong here? I have a missing condition, people. I have a missing condition, which the condition of my life. If, okay, watch this one. Here we go. If length of current data equals 0, then break. We can technically break outer just to make sure that always remains clear, but break should break on the outer. And if I do that, that should give us, okay, that's what I thought. Okay, so we can see that we're doing hello world. You can see that we get that all parsed out. Then we do hello part. This one, that one's not parsing it out. You know what I mean? Outer dance. GC, yes. Break dance, boys. Boys, we break dancing. All right, I like that. It makes me feel better anyways. It is way better. If I'm going to use labels, I'm going to use dance. Dude, I didn't even think about that. That way I can at least smile when I'm making a horrible decision. You know what I mean? That does make me happier. Okay, so what have I done wrong here? Oh, what was the problem? All right, unexpected error, end of file, really? Oh, really? Request 42. I mean, in some sense, yes, this is true. Like when we hit an end of file, it is really a problem here, right? I kind of feel like this is a bad test design this thing. I don't know what. Hold on, let me think about how would I want this, because This should, I mean, I see why this is breaking, right? Okay, so this is why, if I'm not mistaken, I think I understand why this thing is breaking, in the sense that if I go here, let's just, oh my gosh, who did that? Who did that? Who did that guy? Who did that guy? Why would you have that in there? Okay, so that's not the way I want it. That's fine. Let's go like this. Let's go like that. There we go. Okay, so that should just do that breaking one. Okay, so I'm actually curious, how would I prevent this, right? Because what's happening is I get to here, I get to the content length, but the length never gets executed. And why does the length never get executed? That's because on the outside, what is actually happening here? I tried to read the buffer. The buffer is actually getting nothing left. Let's just see what happens here. I'm gonna go like this. I'm gonna go slog.info.request from reader, and I'm gonna go state. I just wanna see what the state is. Does that make sense? State. Before equals this, FRR that, paste that in, and then let's paste that right here, and then let's go. No, let's actually not do it before. Yeah, let's not do it before because I'm gonna kind of bottom out of my error. All right, so you can see we do a bunch of inits because we're parsing that line. Then we do a bunch of header parses because we're getting them one at a time. Then we hit them with the body parse. And the body parse goes, okay, we're now into body, but we're also completely out of data. So I guess what I could do, I mean, to prevent this, okay, so now we're actually coding around a test, which is kind of annoying. This is one of those things that's really annoying because this is, I'm actually coding around a test as opposed to coding around something that could actually happen. So there's a couple ways around this. Edge cases, exactly. So one way I could do this is that instead of setting just state straight to body, right? Because this is where our contention is. We actually transition to body, but we've ran out of data, so the next time we go to read, it says, hey, we're at the end of the file, and it closes our fake connection, which thus means we actually get 0 data back out, and if I go into here, right, we do this whole thing. So I guess what I could do just to make, I mean, man, how do I want to do this? Let's just see if I do that, right? Because, I mean, that's how I would think I'd want to, I mean, this is just one way to possibly do it, but then I think, yeah, we're frozen, because we never actually hit the end. I know why that's happening. I know why that's happening. That also makes perfect sense. The reason why that's happening is you go right into here, and this always hits 0. We're always breakdancing. So maybe that's not the way we want to do this. Damn, that's, this is a great weird edge case. I'm trying to figure out how to solve this without making it feel unrealistic, right? Because you want something that actually performs more in the realism of it all, because when there is an end of file, it is actually an error, right? It's actually an error, and this should error out. So let's keep that. Let's keep that bad boy, right? We're going to keep dance. Let's keep that. So one way we could get around this, honestly, is by just putting a little bit of extra space there. I really do hate that, okay? Because this breaks at line 42. So this should break further than line 42. Now it goes to 52 or whatever, because it's right here. Like, I really don't like that. That will effectively move the thing forward. What lesson are we even on? Wags Lane, we are on this one where we're parsing the body. There's a bit of an oddity, Lane, that I think that maybe we didn't think through too well through this course, which is when you receive an end of file, it should result in an error. Meaning that a request from reader really should be broken if you get a request, but the request ends in an end of file, because that means the connection theoretically has been terminated, which means that you can't handle this request the normal way you would handle the request. And so there's like this whole problem. And so right now I'm getting around that by adding a singular space at the end of each one of these, which it just feels kind of, that does feel a bit hacky. I think we can all agree that feels hacky, but I think I'm right. Like, how would you do this, right? Can you walk through the Git course on boot.dev without subscribing? Yeah, but you just get no interactive features. So that's the hard part about doing this correctly, Lane. I have to change how I'd want to code. Okay, so this is how I'm going to do it. I could technically make this work out and change how I programmed something, which is not necessarily the way I'd want to do this, because I just find it easier to do this. But what I could do is that in headers, I only switch to state body if we'll go like this. Func our request has body, bool, right? I have a little boolean in here. And then what I'm going to do is I'm going to go into here and I'm going to yank that bad boy out. And I'm going to go like this. Return length equals 0. Obviously, I'll do a little to do here. To do when doing chunked encoding, update this method, right? Pretty easily done. There we go. So that means my state body, I'll go like this. If r dot has body, well, then we're going to do state body. else, we'll go like this, r.state equals state done, right? Not what I want to do, but I think this is probably the way to do it, because then I don't have to do this whole check, right? Because well, we do have to do this check because I have to, like, to do, here, panic, let's see, what is it called? Chunked, not implemented. There we go. There we go. That way I don't accidentally do anything. I believe that should also give me the correct stuff. There we go. Okay, good. All right, fantastic. I think this might be correct. All right, unexpected error, received this one, but porque also Maria, right? So how did I land on that one? Let's just think for a second, because this one should not happen. We should not receive that as an error. If I've programmed this correctly, which should be 48, which should be this one right here. Wait, hold on. Okay, hold on. It's line 42. I was like, wait, 48. All right, so there we go. So it's saying that is one, but it shouldn't be one, because if I'm not mistaken, I can jump to here and I can go like this, state headers, and I'm gonna go like this, slog info, let's see, parse headers. Oh my gosh. Why are you doing that? Why are you doing that? Parse headers ending. And so let's go like this. We have an ending right here. And I have, see, has a body, r dot has a body. Wait, what is my has body? Is that, oh. Oh my gosh. Dude, stopping. Okay, stop that. Okay, sometimes being a logic wizard does not always wizard in the right way, okay? A wizard arrives precisely when he means to, okay? I just want you to know that. A couple streams ago, AR, the only reason why I'm hand-rolling slog statements right now is so that I don't use AI to code this, because that would be way too easy, and I don't want to do that. I'm not going to do that for you guys. I'm doing it for you. I'm not doing it for somebody else. I love Gandalf. Oh, you love the Gandalf. All right, there we go. No, fail is just one. It's per lesson. Did we fail the lesson or did we not? I already +1 the lesson fail. All right, so I'm going to call this good, even though, you know, really, I don't like this, and this is why. In the real world, we would not get an EOF after reading data. Therefore, we would nicely transition to body, which would allow us to then transition to done. But I am doing the transition here. Wait, it's kind of like, have you ever done recursion? It's kind of like doing the base case checking in the body. It's like I'm doing base case checking in the botting, and so just like personally as programming wise, it pisses me off, if that makes sense. Isn't there, it's because the solution doesn't return error if the number of bytes reaches the content length size. Allows for, seems reasonable, I think. No, end of file is always an error, Lane. Lane, you cannot have an end of file on a request response model. What do you do? Like, should you ever process a request in which the connection gets obliterated before you have a chance to even touch it? Something tells me that I would have to think way more about how a server should interact with it, right? That's a very different experience. And so I don't have a solid answer, though. You do, though. You might have an early EOF. And if you do have an early EOF, you should handle the error condition of this, which is what I'm doing. I'm erroring. I know normally EOF is not blowing up. I'm erroring. But our tests are not doing that. Where do you, let's see, where do you respond if the connection is terminated? Exactly. That's what I'm doing, is I'm actually properly saying, hey, there was an error because we have an end of file. Here, handle the end of file error. Right? So I actually think I'm doing the right thing here, which is end of file, here you go. You deal with it on the outside, because this is just parsing. Right? Just like, I don't know what to do with that. You think of how you want to handle this thing. Do you want to process it still? Do you not want to process it? What do you want to do, girl? Girl, tell me your feelings. All right? All right. So I'm just going to move on. I'm going to say I'm right, and we're going to keep it there. Live body. It's finally time to end-to-end test our full HTTP request parsing assignment. Again, we already did the hard parts. Update your application request line headers to do this one. Body, string. Okay. Be sure to stringify the body for printing. Run your TCP listener. Do all this one. Okay, we can totally get that one. Let's go like this. We're going to go to our main. We're going to go here, and we're going to go here, and we're going to do this one, and we're going to jump here, and we're going to go like this. We're going to have body, string. We're going to go here, and we're going to go like this. Body. Wait, is it all capital B body? No, it's not. Body, there we go. And then we're going to go here, and we're going to go %s, a new line, and we're going to go, where is it? It should be r.body. Oh, yeah. There we go. There's your body buddy. And we're going to do this bad boy. We're going to take this one right here, and we're going to go to here, and we're going to paste that one in. There we go. We're botting. We're going to go body this bad boy. We're going to go here. Damn it, Bobby. Then we're going to take that one in. There we go. We have this nice thing. There's our body. We're going to cut that thing out. Look at that nicely parsed body. We're going to take this one. We're going to take it out here. We're going to run it. We're going to pass it. We got it. First try. Let's go. Okay. Real world, you'd have content length or chunked headers. Correct. Real world, also, your connection, if it terminated, you'd handle an error condition, which is what I'm doing. I'm providing the error conditioning. This is just kind of like a... I understand. I wrote this, okay? This is my fault, so I don't like what I did. I'm just saying I should think more about that. Let's take a look at the struct we've been parsing so far. Request, okay. Now compared to the request, let's see, to HTTP request struct. Now compared to the official Golang HTTP request struct, right? You see there's a few differences. We have a request line struct, while they have elevated the method, target, and version into their own top-level fields. It's basically the same data, but the layout is a bit different. We have header struct. They named their header. Again, which is funny that it's header. Header is like a little bit goofy. I think it should be headers. Okay, because it's actually 0 or more headers. 0 is plural. Idiot. Again, the same data, slightly different layout and naming. I prefer to call them headers because that's usually how web developers refer to them. The Go standard lib refers to the entire collection of field lines as header, but I digress. Yeah, that's just strange. I think we can all agree the word header is incorrect. Can we all agree that header is incorrect? Type 1 in chat if you think header is incorrect. I think I'm correct. I think headers is correct. I think header is just not correct. Rare go L. Hey, go get some L's in there, okay? Can the course be updated? The course can never be updated. It's forever stuck in time. It's on the blockchain. You wouldn't understand. It's not on the blockchain, and yes, it can be updated. The most important difference is we have body field that stores the entire body as a byte array in memory, while the standard Go lib has read closer. Yes, so they do a reader, which I actually still think even their headers, I don't know how headers work, but I think headers should be done with the reader as well, right? I actually think you should have headers as a reader, and I think you should have body as a reader. I actually think having it as an object is incorrect. If you're really trying to get like maximal performance, because once you parse that first line, you can call your handler to go on. And your handler, if it needs access to the headers, can then do the proper weighting and doing whatever. The most important difference, we have a body field that, yep, blah, 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 blah. Our solution is perhaps simpler, but it's more limiting to the users of our library. We force them to load the entire body into memory before interacting with it. The Go standard library allows the user to read the body in chunks or even stream it to a file, which is often necessary for larger bodies. More on this later. Yes, I also don't have a problem with, like, if you're just building something to understand it, taking the easier path I think is way more superior than worrying about every possible usability interface until you understand the problem in its completeness. How does the Go request handle bodies different? It streams it with an IO closer. Yep, that's what we're doing. It has no headers. It does not store the body at all. Requires, okay, that top one. There we go. All right, congratulations. You made an HTTP request parser, and honestly, that's the hardest part of this course, but the course, we are not done yet. Let's build the actual server interface that handles the request and sends the responses. Now, whether you're getting your data from YouTube or Twitter, every single server has implemented the HTTP protocol, which, remember, is on top of TCP. Though that technically may be a lie. With HTTP 3, it's actually on top of UDP, which actually implements a form of TCP on top of UDP. Bing! Now, not all the implementations of HTTP are perfectly identical. If you go off and you peruse some of the horror stories, there's like these very little things that didn't work out. I can think of one time at Netflix in 2016 in which I actually got hit with a bug because, guess what? Headers were being parsed case sensitive. not case insensitive on a specific TV. Not every implementation is equal. But if you were to implement a server now and say you used Go, you could use something called the HTTP package. It's already available. You could start TCP servers or you could start UDP servers in Go. You don't have to implement these because at some point somebody implemented all of this and put this into the standard library. If you were to use Rust, you'd actually have to use Cargo to be able to install an HTTP server, but Rust does have a TCP server. Every single time somebody has to implement it at some point, and we have a specification to hopefully make sure every implementation is the same. Headers, they should be case insensitive. The status line should look a certain way. If you've broken any of these rules, hopefully you're getting back a 400, a bad request. The basic life cycle of any HTTP request usually comes from the client. Now this client will send off something called a request. Now this is just a subform of the HTTP message specified in the HTTP specification. There's a lot of specification I just said there. And this usually will consist of what is called a status line, field lines, and a optional body. It can also include trailers at the end. Trailers are just simply headers, but they're computed at the end. You can think about this when it comes to, say, really large file uploads. We don't know how big this file is going to be, but we're going to send you a bunch of data, and at the end, we want to send you, say, a checksum. That checksum needs to be dynamically computed, so therefore that checksum won't be known until the end, so we will have a trailer at the end of the request. So now every single request is going to go across the wire. It's probably going to be passed through many different implementations because every single connection along the way is going to be forwarding the request on to the final destination, the server. And when the connection gets to the server, it's going to parse out the status line. That status line is going to say, hey, here's where it needs to be routed within the server. It's then going to go from there and make sure that it has everything parsed, the query parameters, all the stuff that your server does. And then you're able to go off to, say, the database and get any information you want, maybe go out to a third-party service, maybe even call good old-fashioned ChatGPT to get a response back, and then you're going to send that back with what is called a response message. The response message is going to be identical shaped as a request message. You're going to have a response line, you're going to have field lines, and you're going to have an optional body, and of course, an optional trailer at the end. Trailers obviously for chunked encoding. This is the request response model of HTTP. Notice that in TCP, there is no request response model. It is simply forming data and being able to have that same shaped data be both on the client and on the server. There's no kind of responsibility of the server now to respond to something. Whereas with HTTP, it's also implementing a behavior on top saying, hey, when I do a request, I expect back a response. The response should have status codes that kind of indicate if it was successful or not. That's why often you'll see something called a 200 status code. That just simply means, okay, that was good. I believe it's literally called status okay. A 400 is simply just a bad request. Maybe you didn't provide the right information for the request. A 404, which we've all seen, is simply means that, hey, not found. We couldn't find it. So every single response comes back with more than just simply the information you're looking for, but also the status about the information. Obviously, not every single language is going to be great for the request response model. If you take something like Node, if you have a high compute task in a JavaScript environment, since JavaScript is only single threaded, you could actually greatly affect your request response per second. Typically, though, most people's handlers are actually pretty thin, and it's just a series of grabbing a bunch of data from some external sources and then taking that data, putting it into some sort of formed object, and then sending it down to the client. So they're very, very light, barely affecting the RPS itself. So we're going to have something that's going to be pretty straightforward. We're going to just build a very simple server. I like how Bun did it, right? You just say serve, port, this, and then you get this out. I know we could build like a whole routing mechanism and a string parsing mechanism and a path and capturing values and all that, but that's just way outside the course. And honestly, it is just completely different. So there we go. So we're going to just do it kind of like, we're going to do the bun style, right? So I just want to do serve, port, fetch. Okay. So it's fairly similar to Go's HTTP listener serve, right? There we go. Server, address, handler. There we go. Boom. Listen and serve. We're going to follow a similar pattern with a few differences that I'll point out as we go. In this, by the way, at this point in the course, I can't remember what I did. So this is like the first time I'm doing it, right? To quote the famous philosopher Foreigner, it feels like the first time. All right, and this step will be upgrading from TCP listener to an actual HTTP server. It will accept valid requests and send valid responses. That said, for now, no matter what request is sent, the response is always the same. All right, create a new main.go and HTTP server. Let's go. Jump into here. HTTP server. Let's go. We're going to jump into here. We're going to go main.go. We did that. We're going to go package.main. We're going to go func.main. We're going to go func yo mom. We're going to go func soul brother. There we go. Dogfooding your own course. Reading my own code. I know, dude. Reading my own code is one of the most painful activities known to man. Reading code that's over 3 months old is just. It's like a masochism, really. It's like a big old chunk of masochistic love. Don't be talking about Mop Joe Mama. Factual pain. Yeah, it is. It's a factual pain source. I either get so turned on by my own code, my own old code, or disgusted. No, dude, I know. There is every now and then I see some of my old code and I go, that's the greatest code ever written to man. And then other times I look at it and I go, I hate it. That's why you comment your code. Commenting has nothing to do with it. There's there's nothing I could do with a comment, right? It's still gross. I never not liking your code, I think, is a sign of somebody who always wants to improve. Technical debt is every line of code I've ever written that's older than 4 seconds. Everything that I've written that I quit looking at is old, right? It's old and it's bad. All right, we're going to create a new one of these. Create a server package in the internal directory. Well, let's go. Let's go internals. So I'm going to go like this. We're going to go here, and I'm going to go like this. Server. And now let's go server.go, and we're going to go package server, and then I don't know what to do from there. So how should we do this one, by the way? I'm gonna drop request test and header test and just have this, and let's move this guy up to here. There we go. That looks good. All right, here we go. Create the new main thing, create a new server package in the internal, do this one, copy and paste this command into the follow. There we go. We got this one right in here. So I'm gonna go like this, main right in here, HTTP, and let's add that one, and let's put that one at the tippity top. There we go. All right, so we have a server. Let's go like that. Let's go. So we have a serve port. We're going to have a log. We're going to defer a close. Okay. This is kind of weird. Weird. I'm going to go like this. There we go. We're going to have a little OS with a sig-chan syscall to make sure that we can do that. There we go. Server shut down gracefully. There we go. All right, so I like everything that we have here. So I need to have this thing called serve port, but there's still a bit of a problem here, unless if we're going to be doing something a little bit different. All right, so I have no idea what exactly they want me to build here. All right, as you can see, we have a serve function. This is where all the magic happens. It accepts ports and starts handling requests that come in. In a future step, we'll allow it to accept a handler function, but for now, we're going to hard code the response. Nice. Notice the sig-chan code. Dude, what a sig-chad. And this is a common pattern for Go to gracefully shut down the server because server.server returns immediately. It handles the request in the background Go routines. If we exit main immediately, the server will just drop. If we want to wait for a signal like Control-C, we can stop. In your new server package, we're going to have a server struct. Yep, we're going to have port int. Okay, so we're going to have to go. Let's just jump over here and go type server struct. Bam. I don't know what it's going to be. And we're going to have func new. Wait, how do we do it? We just have like serve, right? And that's going to be port uint16, technically. And that should return a server or an error, right? Yeah. What's the other thing that we need in here? It's a close function. That's right. Function s server close. That should have an error if we want to be a proper closer. I'm just going to return nil for now. Okay, return server. Bam, bam, bam. Nil. There we go. All right. Server equals this. All right, here we'll go like this. There we go. Run the server in the background. This will do the whole like creating up the TCP port. Let's go like this. Let's go error. I guess, I mean, we could technically do this one and go error right in here, and then this thing actually has to go. This has the whole Go func code in here, and we'll go like this. Listener equals this, equals net. This is my guess is what we need to do. I'm just riffing right now, right? We're just riffing TCP, and then let's go port Let's go format sprint f. We're just a riffing. %d. Let's do that bad boy. Port pont. Pont. If there's an error, we'll return out the error. There we go. There we go. We're going to return out the error. Else we'll do a listener. We'll return nil. And then in the listener, we'll go like this. And we'll go con equals this. Listener dot accept. There we go. If let's see, equals or does not equal nil. Hey, thank you for that. I appreciate that. We'll just return, right? Else we're going to do something with the con. And so I kind of like this idea of taking this guy. I kind of like the idea of putting this guy right here. You know, we do a little bit of that. We're going to do a little bit of that. We're going to run a little bit of that. And then I can go like this. I can just go run that server, go run that son of a bitch. You know what I mean? It's like, it kind of feels a little bit nicer to go do that. And then I can go like this, nil, do that one, hit it right there, hit that bad boy right here, and then do the other way around. Yeah. And do a little listener on that one. Maybe I like this one better. Hey, maybe I like this one a little bit better. Net.listener, right? Do we do a little listener right there? Listener, there we go. I could accept this because it then just reduces a lot of the fluff, you know what I mean? There we go, see? Okay, I like that a little bit better. It makes things a little bit top down. Makes me feel better about my life. So now that we have this con, what are we going to do here? Run connection. All right, there we go. We have a con, which is going to be an IO read closer, really, if you think about it. There we go. Go like this. Go run connection, con. There we go. So now we can actually handle multiple requests running at any one point. Feels kind of good. I kind of like where this is going. It's kind of weird. I find myself programming more like I'm doing Elixir here, but hey, what can you do? Instead of putting functions on server, we're just doing this. All right. Okay. Oh, nice. Okay, you just do this bad boy. Okay, so you want to do that. Okay, that's fine. Yeah, see, there's a bit of a problem here that you'd have to, like, go through, right? So I can go like this, closed equals true. This is kind of that weird part, you know, like, is this something I want to do? I don't even know. Is this good? Closed equals false, right? And then we could technically go like this, if s.closed. Then we could just return, right? Stop listening afterwards. But once it goes to here, like, there's nothing I can do. It just sits there and does stuff, right? I don't know, right? Well, what else do you do, right? And then there's also, like, if you're reading from connections, you're going to also have to do some stuff. So it's a little bit weird. It's a little bit weird. Weird, but whatever. Well, I'm typing into that. Okay. Let's just pretend I've done all these things. Okay, handle, connection net. Okay, so we've kind of come up with something pretty similar here. We'll do a little bit of serve, we'll do a little bit of close, we'll do these kind of things. All right, I think I'm right on here. I think I generally like this. That's what we need to respond with. Okay, so handles, let's see, a single connection by writing the following response and then closing the connection. Let's go. All right, so I'll go like this. You see that? I almost sent a nurse registered, not registered nurses. Almost messed that bad boy up. You know what I'm talking about? Okay, almost met the, right. Let's go like this. We have a write. We have a write, read. Is it a read, write closer? Read, write, closer. What am I doing? Sorry, I can't even think. All right. So we got all these things. So let's see. We're going to do a little curl localhost into this temp server. We're going to do a little bit of this. We're going to cat this bad boy out. We're going to do a little bit of a curl. We're going to get those things out, and we're going to respond. Okay, so let's see what happens right here. I am actually curious if this is going to work. Okay, jump in here. We have these things, and then we're going to do that. And so if I've done this all correctly, and I go run command, that one, it should just run. Okay, it's running. We're running. So now let's go here. We're going to copy this thing out, and then we're going to jump back here. We're going to go like this. Let's go. First try, boys and girls. First try. Give me that confetti. No one was ready for me to first try that one. You guys thought I was just out of control. You just were not ready for that one. All right, this is what vibe coding looks like. Let's take another look at our hard-coded HTTP response we sent back as this one. This is technically a valid HTTP message, but something is missing. That RFC says include the content length. True. So curl has this thing where if if it receives a request and it closes the connection, it just assumes that's the body, right? That's like a part of curl that does this little like, it just does this thing where it's just like, close enough. Close enough. Close enough. So there we go. We got all these things for messages that do not include content length, field values, providing the framing information necessary, determining whether the data of the message is and. That's right. Technically, this is technically a valid HTTP message, but it's missing something. The RFC is to include this content length. Yes, I believe if but to see what I mean, go ahead and curl your server again using the verbose flag. You'll read the error messages that is printed out. Answer the answer the question. Okay, let's do that again. Let's see. I still have that bad boy running. Let's go curl. How do we do the curl? Let's go like that. Let's hit him. There we go. Look at this bad boy. Receive failure. Connection reset by peer. Closing connection. No chunk, no close, no size. Assumed close to signal end. Right? So I just close it. And so it's going to say, hey, here's what I got. I don't know. Thank you. Right? Someone is trying to write Haskell without a PhD. That's a good question. No close, no psych. There you go. It should be the other one, but I like that. Okay, response. Well, this is an official list of all the headers that should be in most responses. There are a few that are common enough that we should include them, namely content length, the response size of the response body, connection, whether the connection should be kept alive or closed, content type, the MIME type of the response body. So let's build more of the pieces we'll need to send a valid dynamic responses. Remember that HTTP responses follow the same HTTP message format. Start line, field line, registered nurse, message body. The only difference is that the start line is a status line instead of a request line. That's right. There we go. The start line is HTTP version, status code, and reason phrase. For example, this one right here, HTTP 1.1, 200, not found. Bam. Okay, you got that. So you can kind of see how this is coming together here. Some interesting tidbits about the reason phrase from section 4. A client should ignore the reason phrase content because it is not a reliable channel of information. It might be translated for a given locale, overwritten by intermediaries, or discarded when the message is forwarded via other versions of HTTP. A server must send the space that separates the status code from the reason phrase, even when the reason phrase is absent. How do you like them apples? If you don't send that, if you do not send that space, you are in trouble, mister. I love it. I love all these things. Don't you just love that this is server must, right? This is a must send that space, right? You must send the space. Isn't that crazy? TCP report format. No, it's not TCP, it's HTTP. It's the HTTP intermediaries need that space. While the reason phrase are typically included and match one of the status codes, they're not required and should be ignored by clients. Kind of funny. It is kind of funny. And the space, kind of funny. All right, let's create a new package, internal response package, and create a new status code enum. Let's go. Here we go. So we're gonna go over here. We're gonna jump into here. We're gonna jump into here. We're gonna have a response. Let's go. We have a response. We're gonna have a response. We're gonna have a go. Okay. Well, what do you do? Okay. Good. Okay. We're gonna do a little bit of one of those. We're gonna have an enum. Is that what we're doing? No, we're doing... Or I guess we're going to do like okay, status okay equals a status code equals 200. Is that how we're doing this? All right. All right, so I'm not sure if that's what they need, but let's just call we'll just call that here, okay? We're just gonna call that for what it is. Okay, here we go. So let's see this assignment. We're gonna write this response. We're gonna have a status code enum. We're gonna do those things. We're gonna implement a func writer stat. This one. Okay, let's do this. What's the thing? It's HTTP 1.1. Yeah. There we go. We're just going to rip through this because this is just like, now we're just going to have a bunch of these that I just want to get right. You know what I mean? There we go. Now we can go status, bad request, 6 up, that, bam. VI that one, paste it in. There we go. Bad here, bad. Do one of those. Let's go. Paste that one in, yank paste, there we go. Oh, I feel like I'm missing something. All right, what's the problem here? Too many return values. That's right. This does an int and an error. I forgot that it does int error. It does an int error. Gosh. Status line, I forgot that it does that. Status line equals this. I should have known better. Okay, let's go like this. W.write. Yeah. Let's just do that. That seems pretty much right. Do a little one-eyed fight in Kirby. I tried to just kind of vibe code that maybe a little too hard. You know what I mean? Status line equals, right? We can't be doing that. It's a little too much, right? We don't want to be doing that. There we go. That should be pretty much good. And then we'll go like this. And then we can have a default, which should probably return format error, unrecognized, recognized error code, right? There we go. All right, so we've gotten pretty far. So everything's looking pretty good. We have our status line, we have all those things, and so we should be able to just go like this. What is it? It should be, who cares about that? We'll just hit him with one of those, and we should IO. All right, turn that down. Way too much intensity just then. Way too much intensity. There we go. Implement a function, get default headers, content length int. Wait, what? It should set the following headers that we always want to include in our response. Hold on, what? Hold on, this is a really weird one. What am I saying here? Let's see, this function should set the following headers that we want. I don't know this one. I don't think I remember writing this one. That's okay though. That's okay. All right, this is okay. We could do this. Get default headers. Yeah. Okay. Seems a little bit strange, but whatever. I'm not really sure. I don't really understand this one. Why are we doing this right here? Get default headers. That means, okay, that's fine. We'll have this one, and we'll go headers dot new headers. We'll do that one. We'll go set. And then what's the methods we need to do? We want these 4 right here. Okay. Which I think makes sense, right? We're going to do all these ones, right? So we're going to want to do a content length. And we'll do the content length for this one. And then we're going to want connection. And we're just going to set it to closed, right? Because we don't actually need anything beyond that one. And then we're going to go right here. And we'll go content type, which is going to be a text plain, right? So there we go. So we're just kind of setting up these things. I think I know where this is going. Bro, I know where this is going. Why are we copying this out? That makes me feel uncomfortable. All right, we have a little headers, even though I guess it's not that big of a deal. It's really not that big of a deal. All right, content headers, new headers, do this one. Content length, format, sprint F, do this. %D, go into here, content length. There we go. Because that's how you do it in this area. Okay, apparently it doesn't want us to do headers. Can I just do that? I'm going to do that. Okay, I'm going to do that. I probably wrote this. I just can't remember why I wrote this, but here we are anyways, okay? So I have the status line. That's the first line of the response, because remember, I don't know if you guys remember from just reading it literally 14 seconds ago, we have a status line, then we have field lines, then we have the empty one, then we have the message body. So we wrote something to do the top part right here, status line. Let's go, because remember, on a response, it's the status line. It's not the request line, it's the status line. The default headers, we want to give it some basic headers. So when we create a response, it starts off with some basic headers, some basic B headers, okay? Now that we have that, we're going to keep on going, so that way we don't mess anything up. And then we have this assignment. We're going to go here. We did this one, bam. We did this one, bam. We did this one, bam. Okay, we did this one, bam. We got that one done. Implement func write headers, IO write headers. That does exactly what you'd expect. Ooh, I love that. Don't tell them what to do, just tell them what to do. You know what I'm talking about? Let's go. Func write headers, let's go. Oh my goodness. F. Oh my gosh, I couldn't seem to get that one. Let's go. All right, you know what to do. You know what to do. I'm going to do that as that because I don't like copying things, even though, like, technically, if you think about that, I wonder how this works, because when I copy this, I'm actually not copying the map, right? I'm just copying a pointer to a map, so you could have several copies of an object in which is just actually a copy of just simply a struct that's filled with one pointer, which is like, is it the same thing as just copying a pointer? I have no idea. I don't know how these things work, but here we are. We're just doing a pointer to a pointer, which is a little ridiculous. So maybe I need not to do that. Maybe it would be better just to not do that, but here we are. All right, here we go. So I'm going to go like this. You know what I'm going to do, boys. We're going to go like this. 4. We're going to go like this. W. Lots of W's going on. H. For each. Func. Make that happen. Come in here. Do this. Then W. Write. Equals nil. Bam. If. Var. error equals nil. Boom. If error does not equal nil, then return. Bam. Get that there. Right here. Error equals this. And, all right. There we go. Do one of those, and then we're just going to go like that. Format, and we'll do a little sprintf, right? So we're just writing in the headers. This is pretty straightforward stuff, right? Like, I assume you guys can handle its meaning, /r/n. Like, this is easy. Come on. People, this is easy stuff. There's nothing going on here. Okay, there's nothing going on here. We're just writing headers one at a time. You don't know what's going on here? You don't know what's going on here? What does this have to say? Replace this with append. What the hell's append? Wait, now what's the problem? What is append? Append formats according to the format specified, appends the results to a byte slice and return. That's cool. Dude, I literally never knew about. I've never known about append. Here I am, learning about something new. Here I am. I have never even known about that. Very cool. Oh, that's very cool. That's very cool. Crazy. This shows. This just shows Prime is old. Why do you keep saying I'm old? Of course I'm old, dog. New feature, my dumb. It's sort of new feature because it's Go 119, so right after generics. All right, so we did that one. Bam! Okay, update the handle method in your server package to use these new function methods and return our default response. All right, deal. Okay, so this should actually be pretty straightforward. So if we do this one, we're gonna do a little bit of a serve. We're gonna go up here and we're gonna run out this connection. Now, this is where things are gonna get a little bit interesting because as of right now, we don't actually use our server to do anything, which is probably a little bit silly of me. Unused param, well, that's why it starts with an underscore, you dummy. Go, I hate you. Sometimes. I also love Go, but still, it's really like, why you gotta be like this? Yo, Go, why you gotta be like this? Okay, so if we have this, what we want to do is we want our headers, right? So it's gonna be server dot. Is it not server? Wait, where did I put this little, oh, is it response? Oh, crap, yeah, oh, crap, oh, crap. It's response, yes. And right here, I want the default header, so there we go. So I got my default headers, and the content length currently is 0. Right? So content length is one of those interesting ones, which is when you reset the content length. So, okay, so actually this is kind of an interesting thing because, you know, right now when we set something in our headers, right, it just sets it in the headers, right? It just adds it to the thing. But should content length be special? Should content length not get appended values? Very interesting. I don't think I solved this problem last time. Yeah, I don't think this is how I programmed it last time. Well, maybe I did, but I don't think I did. Yeah, see, I didn't do it this way. Yeah, see, I don't like this way. So I was right. Lane, I don't like what you wrote. Because you got to know, you don't know how long things are. Like, the content length should be automatically handled, but you shouldn't be setting things. You know what I mean? We probably need to replace, right? It's almost like our header function also needs, instead of just set, right, it needs something like replace, right, where it's just like, hey, I'm going to replace it if it does equal this way, right? Right? That just replaces the value. Fair critique, yeah. Because yeah, I don't know if I like this. I don't feel like this is good. Like, me personally, I don't feel like this is good. I don't like what I'm writing. But I'm trying to think of, like, how could I write this differently? But we're also just trying to understand how these things work. So maybe it's like, it's okay for this. Maybe there's a better way to go about this. Maybe I'd have a different, you know, what are the expectations of people with headers? It's a good question. It's a good set of questions to understand what the expectation is. Okay, so now that we have that, we have our default headers. And really what we should do is we should actually go and we should read the request in the body. We should read the request. We should handle the request. We should then write out the response. But since we're not doing that yet, let's just do this. We can go like this, response.write status line. And so I'm just going to pass in the con. And what's the next thing? Our status code is going to be our response. Okay, I'm just going to do this, right? And I'm going to go response.write headers, right? Right now we just have it as this. There we go. And that should be a con and headers. There we go. And that's all we're doing. And That should effectively handle this right now, even though that's a default response. I don't really love this, but this will just work close enough. Yeah, we're gonna only use MIME type. By the way, this is really smart in this course. Don't really worry too much about MIME type. This is something you can easily learn and understand. Like if you were doing a file serve, you'd want to be able to associate, like if you serve a JPEG, you want to be able to associate the correct MIME type, as opposed to if you're serving, say, a JavaScript file. You want to associate the correct MIME type. These are like little, this is when I say the edge cases are literally infinite. These are one of those infinite ones. Now, if I've done this correctly without running any tests, which I'm just gonna assume I do because I assume everything I've done is correct because that's how you live a life, I'm just gonna simply copy this thing. I'm gonna run, I've restarted my server, I'm just simply gonna run this, and it's going to run, and it's going to get a status code. It's going to expect this one, and here we go. We're going to run boot.dev, and what do we get? We got status code 200, but we got 0. Oh, wait, what? Oh, crap. Ah, crap. I forgot to do /r/n. Dang it. There you go. Now we see the get. Wait, hold on. Okay, that was my fault. That was my fault. There we go. Now we see it right here. Okay, that was my bad. My bad. My bad. There we go. Whoopsies. That's my fault. I'm the dummy. I am the dummy. There we go. Other comment headers. Okay. We went with content length, connection, and connection type, but there's a few more noteworthy mentions that we won't care about for now. Content encoding in the response, content encoding compressed. Is it gzipped? Is it bzipped? Is it broadly? What are we doing here? Encoded does not equal encrypted. Correct. Date, the date and time the message was sent. This is useful for caching and other things. Control cache, other like nice little things. We're not going to do that. Which HTTP header specifies when the response was sent? X time warp. Date. Which, by the way, I need to increase my failed. All right, there we go. We did not get this correctly. Okay, failed +1. I know I got that. I got it. Does anyone else know which lesson this is on boot? Yes, this is the HTTP from TCP or TCP to HTTP. I believe it's called like Go HTTP protocol. Something like that. Now that we've got a lot of boilerplate out of the way, let's define our handler function. This will allow the user of our server package to define their own logic for handling requests. Here's a function signature we're going to use. Oh boy, I believe I wrote this one. Now I definitely wrote this bad boy, okay? Okay, buddy. Okay, buddy. There we go, handler. Okay, okay, buddy, I wrote, okay there, buddy guy, I wrote that guy, okay, buddy? What the hell? Okay, I didn't write a handler error. What the hell's a handler error? Okay, that I didn't write. I don't know what the heck that is. Remember, the official Go one uses this one. Yep, that's right. We have a response writer and an HTTP queue thing right here, and an HTTP request. What's a handler error? Brother, what's a handler error? Okay, maybe I did. Okay, I'm gonna say I didn't write this, actually. I'm just gonna say I didn't write this. Okay, I didn't write this. I didn't write this. Type handler error. My guess is this is just an error. It's a pointer though, so that like I'm confused a little bit by what that is supposed to mean. Hand L error. Okay, it doesn't really matter. Let's see what it does because I don't know. I'm looking ahead too far without trying to understand it. The main difference between our and the official one is we'll use more general IO writer instead of the response writer. Correct. We'll use our own request type that we just built. We'll return a handler error. It's just a structured error type that makes it easy to always return a proper status code and error message. Okay, truing. So I'm gonna go like this, struct, and then I don't really know what to do. I don't know what to put in here, so I'm just gonna put error. I honestly don't know what to put in there, right? I don't really, I know, I bet you I put this in here because I was smart, but I'm forgetting why I put it in there. Okay, step 1, create a handler function type and handle error struct type in your server package. My handler or handler error contains a status code and a message. Interesting. Status code, message, string. Okay. Porque? Update server to accept a handler function as an argument. Truing. Okay, we can do that. I'm trying to remember why I did this. Hold on. Let's take this and let's take that out, right? Let's take that out and let's go into here and let's go to server. All right, I'm going to paste that in here. Status code. Ooh. Where did I define my status code anyways? Status code and request or response. That seems wrong also. That doesn't seem right at all. So I'm going to take that out. I think I put that somewhere wrong. Where did I put that? Maybe it could be in response. Yeah, I could see why I could make the argument for why it needs to be there. I feel like I would want to think about that a little bit more. Maybe I'd want to put that in some sort of generalized handler so it's a little bit more understandable. So there we go. So we have this bad boy. So let's go like this. We have a server, and do we do a little bit of a port, and we go like this. And then we also have our handler, right? The best part is this is like a complete mystery to me right now. I actually have no idea where we're going, right? Like, that's the fun part. I actually don't even know where we're going. Where are we going? I don't even know. All right, so we're going to do this bad boy. Right? This is kind of fun. It's like a mystery. I'm like having a mystery going on right now. All right, so I do like this, create a handler that, I like that. I know I have this in here for a reason, and I know I put this. This is not a lane fault. This is me. The problem is I'm trying to solve this course ahead of time, and I'm like confused why I did that. So we'll see what happens. Okay, create some logic that writes the handler error to an IO writer. This will make it easy for us to keep our error handling consistent and dry. That does not sound like a phrase I'd say. I'm going to say, but I'll pretend like I wrote it. Shh. I'll pretend like I wrote it. All right, so we're going to have a server. We're going to have this. Let's use our server connection, right? So we're going to have this one. We're going to get the default headers. Then we're going to go like this. Error equals s.handler. And then we need to write something here. And so we need our own little, our own little IO writer right here. That we need our own IO writer. And then we need our own request writer, right? Because we're going to have something, right? There's a way to do a buffer, right? Buff equals, is it Buffio? Is it Buffio? Is Buffio the one we want to use? New, how do we want to do this? Because I want a writer, right? I want my writer. And there's a way to do a buffer. I thought there was something called buffer. I thought there's a buffer module that was just like literally called buffer. Am I wrong on that? Is it bytes? New buffer, right? There we go. And so I can go like this, right? I can just hit him with one of those, right? And this buffer implements creates and initialize a new buffer using the buff as an initial contents. Takes ownership, and the caller should not use buff after this call. Yes, the buffer is intended to prepare a buffer to read existing data. It can also be used to initial size. Used to set an initial size of the internal buffer for writing. Okay, so we could do that. Buff should have the desired capacity, but a length of 0. In most cases, buffer, okay. So I should be able to I think then I can just go like this, writer.write, right? I think I can just write to it, and I think that's fine, right? So I should be able to go like that. If I've done this correctly, I should be able to do this. So I just get I pass in the buffer, which is now a writer, and I go like that. And then I also need to pass in what? I also need to pass in the request. So then I also go like this, request error equals, what is it? It's going to be a request from reader. We're going to pass in the con. So there we go. This is the whole course now comes down to this line, right? Which is we're going to get default headers. We're going to create the writer. We're going to do these things. If we have an error, what do we need to do here? Well, I need to go, right? I need to take these bad boys, do one of these ones, and I need to write response line status, bad request. I'm just going to hit them with the bad request, right? If you give me an error, it's a bad request. I don't want to do anything. That's all we're doing, all right? Right? All right, so if we don't do this here, then now I'll go down here, and just to make this easier, I'll do this little writer. Error handler, right? Handler error equals this one. And then this one requires a request, so we have the nice little request right here. So there we go. So we have the handle request. So that means if whatever you've written, I now need to start doing some basic replacing on, right? So I need to go like this. If handle error does not equal nil, wrong language, does not equal nil. Now we need to do something with this, which I still to do. Why did I do this? And what should I do? To me, in my head, if there is a handler error, I'm just going to go like this. I'm going to yank these two, paste these two, and I'm going to go status internal server error, write out those headers, and we'll call it a day. Now, I noticed also something. My handler, I should theoretically be passing in also the headers to write to, right? In my head, I'd also need the headers because in case you need to write different headers. Does that make sense? Yeah, so there we go. So we have the handler error, we have the handler, we have all these things. We can write out these things. Else, I'm going to do an OK status. We could also have like a hey set status. That's why they have like, if you go here, this is why there is something like in the official Go one, right? If we go back one, where's the official Go one? Where the heck did the official Go one go? Did I lose it? Was it not right here? Oh, yeah, it has a response writer. That's why. The response writer allows you to do things like, I believe, set status. So you can set your own status. A bytes buffer. UFC announcer. Yeah, will you update the course? What do you mean update the course? It depends on if I like what I've done. I think I could have, I think right here, instead of having this handler error, I think it might be smarter not to have that handler error and do something different. I'm not really sure why I did that, why I wanted it to be so specific. It kind of feels like if your handler returns an error, then you have an internal status error. If you try to parse the request and you have one of these, then it's an error. But I guess you could also say, you could technically also say that you have a request that's actually successful, but then that request is actually bad. But then you'd probably want to handle this differently. I see why I did this, but I don't think I really love the way I did this, right? So I could do a status code right here, right? So I could technically, like, say I expected an authentication token and you didn't, or an API token, you didn't give me one, I'm going to give you, I could send you back technically like a bad request, right? And so I think that was the point of that. Server also serves server, but it doesn't do anything. Yes, it does. Okay, look at it go. We did it right here. We're doing S handler. So we're still using the server right there. We're going to run the connection, do all this. We're going to write headers, all this thing. And then we need to go like this. Length equals, what did I call this thing? Where did I do my writer? Okay, writer, that's right. Writer dot, can I do bytes? There we go, cool. So I can grab the bytes, which means I need to go like this. I need to go headers. Did I call it headers? Yes, nice. Replace, and I need to go content length with length, format dot sprintf %d length. There we go. We're going to set this one. So we're going to set that one. We're going to replace this guy right here. We have these ones, which means I should also take this. I should write the status line. I should write the headers. And then really, I should take the connection and write the body. Data. Body. Length. Body. There we go. Body. Right? There we go. Yeah, see, there we go. So that's the last part. We get the body, I reset the content length, I write the status line, I write the headers, and then I write the body, and we call it a day. Let's go. Does that make sense? All right, so here we go. So we update the handler method, parse the request from the connection. We just did that. We create a new empty bytes buffer. We effectively do that. Nice. We call the handler function. If it errors, write the error to the connection. Nice. If the handle succeeds, create a new default response header, write the status line, write the headers, write the response. Oh, nice. We did this all. In the main function, let's create a handler. Yep. Okay, let's do that right now. All right, here we go. So let's go into here. See, this thing is all wrong. Let's go func. All right, there we go. You know, there we go. So we have these things. So let's go, whoopsies. Let's go two. There we go. Return nil. All right. Let's go like this. If a request target is your problem, return a 400. All right, let's go like this. Ooh, I wonder, how does message go? How does message go? Your problem is this one. Is that a body? Or is that supposed to be the reason? Okay, so one, I'd say this one. Okay, here, I'm gonna actually report this one. Have you found about it? Yeah, yes. With the message, is that supposed to be on the reason or the body? I would assume reason. Maybe? All right, like, I don't even know. Like, where exactly do you want the things, right? Yeah, okay, so it is. Okay, so it is. Okay, yes, you can actually tell right here. Okay, my bad. I should have read forward. I should have read forward. It says it right there. My bad. All right, there we go. Okay, we're going back loud again. For a second. Here we go. If request line dot request target equals your problem, then wrong language. Else if, we'll just yank that bad boy, paste that in. And else we'll do this. Okay, there we go. And then we're going to go into here, and we're going to say my problem. There we go. False reporting due to skill issues would be failed to increment. False. Okay, there we go. And so we need this one right here. My bad. Okay. So that means when I do all of this, I actually need to go to the server. And when I have these little problems right here, when I have an error, I'm going to write the status code. And then I need to write the headers. And then I need to go con write body, right? And the body is going to be byte handler error message. Right, this is going to be crazy. This is going to be crazy. Do we get this one? Do we get this one? Do we get this one first try? I feel like I could potentially get this one. Server response internal server error. There we go. And then we should probably have message. I don't really like how like my I don't really like how I have response that hands. Like I think I'd do a little bit more of a holistic package if I was doing this differently. You know what I mean? All right, there we go. So this one I want as status, bad request. And then I'd want this one as your problem, not my problem. Yep. All right, boom, boom. Otherwise, all good for real, on God. All right, we're going to go like this. W.write. There we go. Oh, yeah. We're going to do that one. Okay, so I think I did this one. I think I did everything. Obviously, look at that. I don't like how I wrote it, but I think I'm happy with what I've done. All right, so remember, okay. All right, here we go. Now, if this doesn't boot up, that's fine. That doesn't count as a first try loss yet. That's okay. See, that's okay. Easy. Easy. It's just because I am too lazy to go and check everything. All right, what's your, let's see, what do you want to do here? Response 36. Wait, what? Wait. Hold on, rerun that one? Okay, I was about to say, what? I just forgot this. Serve. There we go. All right. We've always had, hey, we have the same rule before a bunch of people call foul, which is if it doesn't build, it doesn't count. That typically is how it's always been. If it doesn't build, it doesn't count because it's not a logic error. It's just that you always get to at least build it. Okay, so run that. Oh, no! Ha! Ha! No! Dang it. Okay, here's what we're going to do. We're going to go like this. Here's what we're going to do, okay, people? Okay, I'm going to declare, I declare my body, people. All right. I'm going to do these bad boys, okay? We're going to do these guys. We're going to have this one if there's an error. If there is an error, we're going to go like this. We're going to go like this. Var status equals status, code, right? And I'm going to go like this. This is going to be a response. Okay, I will take the blame on that one. All right, if I have a handler error, I'll go like this. Status equals handler error response code status. There we go. And then I'll go body equals, can I just go like this? Can I go bytes.new buffer? And I can go, byte and pass in handle status, handler error message. There we go. Right? Did I not do this correctly? What's wrong with you? Oh. Can I just set the writer to that? I think I can just set the writer to that. I guess I wouldn't want to set the writer to that, right? I'd want to just go like this. Yeah, I'd want to set the body to that. I'm just being stupid. I'm just like, bros, I'm just like being stupid right now, okay? I just really want to. Then we're going to take that one. There we go. We have these ones. And then we're going to replace this one with the length of the body. And then we're going to do a status line. And we're going to go like this. A status. And then we're going to go in the headers, and then we're going to write the body. Okay, there we go. That should be the answer to that one, which should Now do that one. I forgot to set the content length. Oh! I hate that. Anyways, stupid. Whatever. Stupid. Who wrote this shit? Code review. I just want to point out a few of the ways that I implemented some of this and talk through the decisions. First, a server and listen, right? Oh, bam, 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 bam. Did I write it the same way? Oh, I kind of wrote it very similar. I guess I did it a little bit different here, right? Yes, yeah, I did this a bit different. That's fine. You'll notice they're very similar to our original TCP listener with the added handler. Yeah, they're very, very similar. I think this is one way you could do it. I've just been like trying to adopt more of a Elixir style, and so I'm just like passing this in as the first argument instead of hanging it off the object, expecting some sort of more like OOP style or just kind of class-based style. Instead, I just have like data and then pass in the stuff. So it's like should content length be treated differently? No, you should be. Okay, shut up. I should have read, okay? You'll notice that that they're very similar to our original TCP listener with the added handler that to actually handle and respond to the HTTP request. In fact, the interesting part is in the handle method, right? The handler method. We're going to do this. We're going to read all this good stuff. If there's an error, we're going to have a handler error. I should have probably put this into here, probably put a bad request. I didn't do that. Instead, I did this whole thing. There we go. We have a nice little handler error. We have this one. If we have this one, we can just write. Oh, nice. That's cool. That's cool. I did it this way. That's actually one way to do that. Else we do it this way. I like the way I wrote it this time. I think this is not great code. I think that, again, I think I at least wrote it a bit better this way, kind of collapsing them into the same thing. I think that that's a little bit nicer. Either way, it's pretty straightforward procedural code. Procedural code is beautiful. You know, anyone that always dogs on procedural code, I think they're just dogs, right? Procedural code is great. Something interesting things to note. I used raw netcon to implement both the IO reader and writer interfaces, so it works perfectly with our this one and our response write-x functions. Our users applied handler functions are kind of wonky. In the event of an error, they return a handler error and don't write to the IO writer themselves. But in the event of success, they do write to the IO writer and return them and don't return error. Yeah, it's just like a little bit. It's true. It's weird. I agree with you. Right, okay, refactor. I'm not happy with our current implementation. It constrains the user of our library, our main package for now. But hey, the startup is going to get monetized, is going to monetize it eventually. In a few ways, errors are always handled as plain text responses. Headers are always the same. Let's fix that. We're going to need more flexible function signature. That's right. Right? So we have this one right here, right? I'm thinking something more like this. Writer. All right, hold on. What is going on here? We're going to have a response writer. Nice. Okay, nice. So we're going to do our own writer here. That's right. This does make it a lot nicer because you'll notice that this actually looks just like now the Go standard library. It makes perfect sense having your own writer because if we create a new writer struct, this will allow us to modify the headers, status code, and body of the message as they see fit. This will give them control to respond to the HTTP request in any way they want while still encapsulating some of the boilerplate logic. See, this is much better. Can we all agree this is much, much better interface? This is why probably the Go team landed on this exact thing because this makes a lot of sense, right? You can see why they've mandated it. That's why the handler error. Yeah. Now I can sleep well. Yes. I know. I forgot why I did that, but now I remember why I did that, which was actually to throw it away. That's why I was having such a hard time there, is that my own self knowing the correct answer was doing something incorrect to go, no, actually, this is why it makes more sense, is because or else you just do this weird dance where I could have written stuff that gets ignored, and then you pass like these two different things, prime padding, old prime on the back. Dude, I am like Obama meddling myself so hard right now. Yeah, I know exactly what you're saying. Yeah, now it makes so much sense because now I'm looking into now I'm looking not in the past anymore. All right, the assignment. The goal here is to change our handler in the main package to respond with HTML instead of plain text. We'll need to do this one. We'll ensure that the raw or the handler function can write raw bytes to the response body even in the event of an error. Give the handler function control over the response headers, content type, all this stuff. All right, so let's update our response package by exporting the following and go implement the innards. Type writer struct. Yeah. So let's go over to response. There we go. Let's go like this. Type a writer struct. All right, let's go like this. And the writer, what do we do here? We're going to want the following functions. All right, let's yank these definitions really quickly. Let's go like that. Let's go like this. Let's bring them down here. Paste those in. There we go. See, I should have put these all in the same. See, for whatever reason, I put these all as separate. For whatever reason, while doing this, I put these all as separate packages. Headers, request, and response really should have been one package. I don't know why I didn't do that. Anyways, this is just what I did for whatever reason. Headers, right? All right, so there we go. That's what we need to implement, which shouldn't be too hard. So I can just go in here, write status line, go into here, write the status code. The status code equals one of these things. We kind of have this nice little status code that we're kind of writing right through right here. That makes a lot of sense. We're going to have IO. We're going to have a writer, right? We're going to have the writer that has an IO.writer, I think. That probably is right. Yes, let's just call that thing right for right now. And we're going to have IO.writer.write. There we go. Yeah. Let's go. Writer dot this thing, that's the underlying writer, that's the that's the connection, right? So I can set up all these things. So we have that nice little thing right there. Let's delete that one. Let's go in here. Let's take that one out. That should be easy little transition right here. 7 down, do one of these, and then just hit them with the writer.write. So it's everything's pretty much the same. Write body, exact same thing. Writer.write, write the whole body. The body is going to be P, this thing. And even though we should probably be checking for errors, let's we can check for errors. N.err equals this. There we go. We can return N and err. And by also having N, I can go like this. I can go write these headers. So I kind of need access to these headers, right? Write headers is a little bit interesting. Let me understand why we did this. To update our response package, export the following and implement the innards. I also feel like I don't like... now that I'm looking at this, I kind of feel like this is a bit wonky in the sense that we should not have write headers and write status line and write body are kind of like, I guess... They should be private methods. Really, we should have these as private methods because the person who's implementing these things shouldn't have them. They should be able to have status, right? You should be able to have a status, and you should be able to just set the status. Okay, this part is optional, though I think it is a nice touch. Add a writer state to my field writer struct that ensures that my user of the library calls write status, write header, and write body in the correct order. It just gives them a nice explicit error if they do stuff out of order. Yes, we could do that. I think that is fine. Update the handler in your HTTP server's main body to use the new package and use HTML instead of plain text. Here's an HTML to use. Okay, there we go. Nice. You might want to expose a new method from your headers packages so that you can override the default headers for a key instead of adding them. It's on. Yep. Override the default keys instead of adding them. I already did that with replace because you wouldn't want to have to like write all these out. But I guess this is the raw components. Actually, you know what? I'm actually not upset about this, right? Because you'd want your server to have access to all these underlying things right here, such as write status line, write headers, write body, because this is supposed to be like the low level package. Then you construct your server on top of it to be able to do request routing and all that stuff, and then your client wouldn't be using these primitive pieces. It'd be using like the larger set of pieces. That's probably where I'd go with this, right? That's probably where I would go with this, if that makes sense. Yeah, that makes sense. I can see why I did it this way as a means to like build up the primitive pieces to be able to build the next part, which is that I always wanted to do a course on like building an actual HTTP server. Meaning like, okay, so how would you build something like Echo, right? Or how would you build something like Gin or all those other things? Which means that you need these underlying pieces, and then you have to take these underlying pieces and build the next step, which is going to be like string parsing of the different paths, being able to route to different handlers, all that kind of stuff, which is what we don't have. Okay, so I think that's all right. Yeah. Okay, I'm going to keep this. I think how I've organized the code on this, not the best, but this is like part of the fun of just implementing stuff is that when you're just implementing for fun, you kind of toss everything around and you just remember why you want to put things. This is why it's impossible. People always talk about how they think with their, they sit down and you should be thinking more than you're writing code. I just have never understood that because I need to write code and then I can go, okay, I see why I wouldn't want to do it this way or that way. I'm more of a learner by writing than I am a learner by just sitting down with pen and piece of paper. I just can't do that. You know what I mean? Okay, so that means our server needs to change its handler a little bit because the handler is going to be right here. So instead of an IO writer, let's have a response. Writer right here. There we go. So we're going to pass in this response writer, which is currently a struct, which is... we should never be passing in this, but here we go. We have the response writer. Let's go. I think this will work for me for now. I'm actually fine with this because, like I said, I think this would allow you to write a better server. I'd have to still think about that because I haven't quite done it, but we've done that. Booted, boom, boom, boom. All right, so let's also do this one. Let's see. Update our handler to in your HTTP server package to do this one. Okay, that's kind of funny. Okay. Okay, I guess, I mean, we can just do this. It doesn't really bother me to do this. All right, so we're going to go like that, and we're going to take this guy, and we're going to take this guy, and we're going to do that, and then we're going to go back here, and then we're going to go here, and then we're going to go here, and we're going to drop that. There we go. We're going to have this one. We're going to have our set. We're going to have this one. We're going to have a server, and then we need to have our, let's see, what do we have right now? We have a response right now that we effectively have, and so we do it this way right now. Which we don't want to do it this way. We actually want our response writer, right? Is going to be a response writer, and then our writer underneath will be our connection, right? Func new writer. Writer is going to be an IO writer. There we go. Oh my gosh, writer. Let's just do it as a writer. I don't really know how else to do this. Writer, there we go, and then we'll do that, and then we'll do this, there we go. That seems better. A new writer, there we go, and we'll pass in the con. There we go, so we have a response writer, and so we'll go writer, and there we go. So we can write in those things if we want to. We can write in, say, our status line. We don't need a connection anymore, right, because we already have these things right here. We can write the headers, which is going to be this, which is going to be this one is that. Okay, we're going to have to do that. That's fine. That's fine. All right, so we're going to have a new handler right here, which is actually going to take the response writer. Whoopsies. We're going to take the response writer, and then we won't have one of those. There we go. So we have these two right here. So we have our underlying writer, which we don't need to worry about. I want to actually pass in. Yeah, okay. Let's go like this. We don't need that thing. We're going to go like this. We're going to go. See, the reason why I don't necessarily like this. Let's think about this for a second. Let's just think about this for a second, is that I don't know how much content to write, right? And so let's go back to our writer. Let's go back to our writer because it's still not how I like this, right? Because when we write the body, I don't have access to the header, so I can't update the headers, which means that, yeah, it's just, I'm having a bit of a hard time because I'm envisioning this as a client library, which it should be a server. It's like a server atomic pieces library. So I'm just having this weird thing where I'm just like, meh, and I'm not really liking it. So I can really get rid of all of this, right? And there we go. Right, so this all goes away because everything else should be just done for. So if we can't even write our own connection, we do the whole bad request business. Else we do all this right here, which we're going to take this, we're going to write all of that stuff out, and then we're going to go back to this thing, and now we need to kind of consider this thing right here, right? And so I'm going to go here, I'm going to erase this one, or I have that one. All right, okay. All right, let's do each one of these ones. There we go. So we're going to jump into here. I'm going to take away these headers because I don't think we need these headers. We don't need these headers because we're putting it all on the responsibility of the person writing or implementing the library to like pass in the headers, how they want to do all that. This would actually be inside of a server. So then I'd go headers equals headers dot new headers. There we go. Or where did I do the default headers at? Response default headers. Those are really nice. I should probably just do response. I should probably do the response default headers because they're nice. There we go. We're gonna take that bad boy. We'll get this nice bad one right there. We're gonna jump in here and we have these three ones we want to implement. Sorry, I'm thinking out loud as I like work through this. I always have to think out loud how I want to do things. If we have a your problem, right? I can do something that looks like this. I can do w dot write status line response. Bad request. I can do w dot write headers. Now this is kind of the interesting part, which is how am I going to do this? How do I want to do this? Right? How do I want to do this? Your response kind of sucked. Here's what I'm going to do. I'm going to go like this. Let's go like this. Func, let's see if 400 response, right? I guess we can go like this. Respond 400, right? And I'm just going to do a byte response back, return, and let's just go byte. Right, I don't want to put that in the code. Right now we just have these kind of hard-coded, right? We have these all hard-coded. These would be what the client, like, this is kind of like what the client would technically do. It would just, like, write really simply. But I'm not even considering that right now. All right, here we go. Func, respond 200. There we go. So we're going to have those ones. So I can go like this. I can go body equals, I'll just go like this, respond 400 for this one. You know, this isn't the coolest way to do things. We're going to have those headers. We're going to have headers replace content length with the length of the body. There we go. And then we have to do format. You know what? I'm tired of that. You know what? I kind of feel like I want something that's like an int. You know what I mean? Maybe I should have added a better one to do a little int there. Sprint F. That'd be kind of nice, huh? Because it kind of feels like I've done this a few times. All right, there we go. So we're going to replace with the content length right here. There we go. Awesome. And so with this one, actually, I can do just like a little fun little... Could we do something with this? I bet you we could make this a lot nicer, but we're not going to make this a lot nicer. Okay, there we go. So we're going to do headers. We can do headers. We can write the status line. We can write that one. Then we can write the body, which is going to be the body. See, there we go. So these are all this one. Write the headers. What is the headers? Is that thing? Okay, perfect. So that means I go like this. Body equals respond 200. We'll do one of those. Who cares if we have to make a little bit extra? You know what I'm talking about. Status equals, what do we call this? Response. Response.status. Okay, there we go. I'll just make the default idea that that's what we're doing. There we go. We're going to do that one. And then we're going to go like this. Status equals. There we go. Do one of those ones. Take these guys. Yank those two. Hit one of those ones. 500 status internal server error. Else we don't have one of those. Take one of those. All right, there we go. There we go, and then go w.write status line equals status. All right, so that's kind of like how you'd, I mean, this is a very crappy way to implement a server, but this would be like the basics of getting up a server, because then you could do routing right to subhandlers, because you could imagine that if you had some sort of set of subhandlers, you could do some sort of subhandler, right, that can do some sort of writing to its own body. And then you could take its own body, right? You do that, right? So, you know, somewhere in here, right? You do something in here, right? Blah, blah, blah. You could have this, like, you know, subhandlers. You'd have to, like, find based on request dot, what is it? Rec dot request line dot target, right? You could do some sort of find on the request line target right here. Get that handler out. And then you could do some sort of writer, which is going to be some sort of, you know, like bytes dot new buffer, right? You're going to do one of those. And then you could do, like, a handler. And you could, like, call into the handler with the writer, the headers, and the request, right? And then now this thing does its own writing, and it can actually do any sort of, and then you could do an overriding of the writer to be able to set like various status things and do all that. And then boom, you could really have your own server. Anyways, there you go. Sorry. I just kind of want to think about that in like the longer one. There's a lot of subhandlers. Now I'm saying, well, I mean, there is a lot of subhandlers whenever you're doing server stuff, because you're also going to want to take this thing and you have to do one of those, I forget what they call them. It's like a recover. Right? I've never actually used recover in Golang, but you'd have to recover from, if your server panics, you'd want your handlers to be caught in a recovery. And then by catching this thing in the recovery, you'd be able to make sure that your server doesn't go down based on a panic, but instead reports the panic out, does all that stuff. Anyways, so that's kind of like what the end goal of this is, to show you, like, you could see how Echo was created now, right? You can see how Echo could have been created. Instead of just like having a hard-coded one of these, you'd have to go find the response. Like, now you can see it, and you're like, huh, okay, huh. All right. So I have no idea if this is gonna run. Let's do one of these things. Let's do one of these things. Yep, I forgot. I just put in a bunch of fake one of those ones to kind of give you guys all these little nice things. Okay. Oopsies. No. Whoa. This thing is what I want. Okay. Which is that one in? That's in server. Do one of those. There we go. No, stop running that thing. It's not even the right one. There we go. Here we go. All right, copy this one. There we go. Can I do this? Damn. Okay. Oh, no, I forgot about that content type X to A. Dude, I did it again. I forgot the content type. I forgot the content type again. You know how many times I've done this with the content type? h.replace.content type equals a text. Dude, I've done this how many times? I gotta quit. Dude, I have to quit doing that. All right. I never said I was good at reading, okay? This guy works at Netflix. False. I used to work at Netflix, jackass. Got him. You think I'm employed? Have you seen this coding? All right, here we go. So let's move on. Let's pretend you have a server that receives a request and that request wants to download a file. But the file you need to download is 10 gigabytes big. That's a big file. You can't just simply load that all into memory, be able to calculate out the checksums and be able to send it out easily because remember, we need something like content length. You need to know exactly how many bytes are coming down. And what if you don't even know how long this file is? What happens if you're receiving it from another server or a different protocol that doesn't even specify the length? You need a way to be able to send down data in such a way that you don't have to specify the length up front. This is called chunked encoding. And chunked encoding is actually a relatively trivial form of encoding where each HTTP body contains how many bytes are in the body and then the data bytes. And now it's your job to reassemble each one of those chunks. Another kind of neat thing about chunked encoding is at the end, you can provide what is called trailers. Trailers allow you to add extra header fields at the end. You have to specify what header fields you would like to add at the end to begin with, so that way you can't have just infinite trailers at the end. But let's say that you want 5 different trailer fields, you could have them all appear at the end and they'd all be a part of the headers. If you've ever wondered why headers are asynchronous, well, this is why. To run through the basics of the chunked encoding algorithm, it's pretty simple. You're gonna have your status line, you're gonna have your headers, and then you're gonna have a body in which is gonna have a hexadecimal number that is gonna be the amount of bytes that this message contains. So you're gonna have another registered nurse right here, then you're gonna have your data, and you're gonna receive multiple of these style of messages where you're gonna keep on sending more and more of the data down, and eventually, at some point, you're gonna receive a message that is gonna have a 0 for the length, which is gonna contain an empty data field. This is the last and closing chunk of a chunked encoding. That way you don't need to know how much data you have, you simply need to just be able to keep on receiving data and storing the data in an appropriate manner. All right, chunked encoding. We're to the final part of this whole thing, which is gonna be chunked encoding, which is gonna be just a couple pieces. There we go. This should be pretty straightforward, okay? Should be pretty easy. So up to this point, we've assumed that HTTP messages are parsed and sent byte by byte, but we've still treated the message body as a single block of data. This works great for many use cases, but what happens if we want to send updates bit by bit? Well, remember our fundamental unit of HTTP, the HTTP message right here, start line, field lines, and message body. Turns out message body can be a bit deceiving. It's rather flexible field that contains variable length of data, known only as it's sent by making the use of transfer encoding rather than content length. So here's how you do it. Transfer encoding chunked. You could do this bad boy, length of data, length of data, length of data, length of data. There we go. Where n is just a hexadecimal number that's indicating the size of the chunked in bytes. By the way, do you like that it's a hexadecimal number? Hell yeah, brother. Hell yeah, dude, saving so much room, dude. I mean, seriously, we're saving room, boys, okay? Because you know what? If we would have used decimal, it would have been, like, huge. So we better use hexadecimal. Right, dude? Like, you're using hexadecimal, reading it 1 byte at a time. Like, are you really getting anywhere with this? You're not getting anywhere with this, you know what I mean? All right, anyways. All right. I always just thought that was funny when I read this. I was just like, hexadecimal? Who the hell does that? And it's just a hexadecimal number indicating the size of the chunked in bytes, and the data, this is the actual data. So you'll notice that first we say like 0xFF, and then we do the length of data, 0xFFF, and then we do the length of data, 012. You're just like, okay, cool. So it'd be something like this. Oh, you don't even do the 0x. That's right. You don't even do the 0x. You just do this. Never go full Java. Chunked encoding is most often used for streaming large amounts of data, real-time updates, and sending data of unknown sizes. We need our server to support chunked responses because occasionally our servers acts as proxy for another server. Any request to HTTP bin endpoint will be proxied to an amazing httpbin.org service, a wonderful online tool for testing HTTP stuff. For example, get localhost, this right here, will trigger a handler on our server to send a request to HTTP bin org stream 100, and then and forwards that response back to this. Oh, is this true? Okay, so this part, Lane went way different on this part. So this was not something I wrote. So hey, guess what, everybody? We'll be doing this one together. All right, cool. Very exciting. HTTP bin org stream 100 streams 100 JSON responses back to our server, making it a great way for us to test our chunked response implementation. Okay. Add 2 new methods to your response package that do what you would expect based on the knowledge of your chunked encoding. Write chunked body. Write chunked body done. Interesting. Okay, I think I see what's going on here. Chunked sizes should be in size in bytes of the data and should be hexadecimal format. Add a new proxy handler to your server that maps hbin x to x, supporting both proxy and chunked responses. I use string has prefix and trim prefix to handle the routing and route parsing. Be sure to remove content length header from the response and add transfer encoding chunked. I use HTTP GET to make a request. Okay, interesting. And then I use buffer size, this one to, and then print in on every call read. Okay, interesting. I recommend using netcat to test your chunked responses. Curl will abstract away the chunking for you, so you won't see your hex and CRLFs characters in your terminal. So there we go. We can echo this one right here, and then we can do a nice little one of these ones. Okay, very interesting. Oh yeah, also, Lane literally ran into a bug while using curl. Curl turns out had a bug and screwed him for a little while. And I think he was blaming me for a little bit at one point. He was like, dude, I don't love you anymore. And I was like, dude, I love you though. What the heck are you doing? I actually also dropped my buffer size when debugging so that I could have more deterministic 32-byte chunks and then raised it once everything was working properly. All right, interesting. Let's find out what's happening here. So this is a whole new way. So this is not the way that I did it. See, I was doing it the other way, which is that you actually make a chunked request. But okay, here we go. Let's do this. Let's do chunked encoding. Let's go the other direction. I'm ready. Okay, so here we go. So we're going to have to do this one. So if we're going to do this, we're going to have to change things up. So we're going to use transfer encoding. So that means we're going to need to go to our headers. Here, hold on. Checkpoint. All right, headers. All right. So that means we also need to be able to go like this. Delete. Oh, whoopsies. I didn't mean to do that. There we go. And then go delete. There we go. What's your problem here? Found H. Wait, hold on. Wait, what? Wait, hold on. What? Is it supposed to be like that? Is delete more like that? There we go. Strings, is that a function? There we go. That's how delete works, right? It does the collection and then the key. Okay, yeah, there we go. So we need a delete. All right. Name of the string. Yeah. Do the truffle shuffle. We're trying to. .pixel. Thank you very much for that tier 1. I appreciate that. Relationship ended with Prime until I've updated to curl. Until I updated to curl 8.12. Yeah, it's true. Lane was not happy. All right, so there we go. So we got that one. So let's look at the next part. So this should be pretty easy. We're literally just doing hexadecimal numbers, and then we're just doing this one at a time. Now, one thing I can't remember with Go, which is how to actually get hexadecimal numbers back out. If I'm not mistaken, I bet you there's some way to actually convert one to another inside of the standard library. And I've never used HTTP bin, right? I've never done this one right here. So let's go like this. So let's go back to our little, this guy right here. And we're going to go like this. Else if a request line. Let's go like this. Strings has prefix. Where are we going to do? Rec line has prefix. And then let's go like this. Let's go has prefix that, right? So if it starts off with this, that means we need that. We actually need that. Yeah, we need that to make sure we're doing the right thing, because then we also need like the whole like XXX part that'd be like, hey, this is how many of these things to do. And so let's do something a little bit different here. How are we going to handle this one? For the sake of this one doing chunked encoding, we need to be able to take all these responses and get all these responses back. I actually don't even know how this thing works. So what is curl here? What is curl verbose HTTP what the heck is this thing? I've never even seen this thing before. That is stream 100. Let's go stream 5. All right. So we do a little bit of this, blah, 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 do a little certificate. Okay, we're using HTTP 2, so that kind of is annoying, but whatever. Get stream 5, we're going to be able to do this one, so we don't even get to see the chunked encoding. Okay, we're using HTTP 2. There's a way to disable HTTP 2, right? What's the way to be able to disable HTTP 2? How do you disable HTTP 2 in curl? That's right. I remember that. I knew there was something to do here. Because I just wanted to see what it does. Do you actually get to see all that stuff? All right, so we do all this one. connected to HTTP bin, content length, access control, allow credentials, and then we do this nice little HTTP bin business. I was hoping to see the body. I was hoping to see what it sends back. Okay, so it's hiding some of the details in here. Can you do something like, is there like a triple super one? Okay, that's too much. We have too much data going on here. Okay, too much data, way too much data. So how are we setting this thing back? We're doing a little get. Okay, so it does transfer encoding to us. It does chunked transfer encoding to us. Oh, we are going to, and then hold on, how are we responding back? Hold on, I'm actually confused as to how what this course requirement's gonna be. Okay, let me just reread it. We need our server to support chunked responses because occasionally our server acts as a proxy for another server. But are we even really supporting chunked responses? Honestly, Lane, I think I might have to help you rewrite this part because I'm actually genuinely confused as to what to do. So, because we're not parsing it, we're not doing a request here. I think originally I did this as a request, right? I'm going to make an HTTP request, read it from, okay, I see what you want me to do here. Okay. I see how you've done this. So you're going to want this thing, right? And I'm just going to go like this. Are you guys ready for this one? So I'm going to go like this. I'm going to go, what is it? Right, dude, how do you do HTTP again? This module has always been a little bit confusing. Let's go like this. This is not, for me, this is not Go's proudest moment, is this. All right. I'm just saying. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I'll go like this. Plus, let's yank that thing and go like this. Target equals this just to make it easier to write and read. Target, let's go length of HTTP bin, right? There we go. Right, there we go. We're going to take the length of that. There we go, because that should be the stream business that we do all that thing from. All right, fantastic. We're going to do a get. The get is going to return a response and an error. We're going to have a response and error equals this. If we have an error, if error does not equal nil, then let's go like this. We're going to take this bad boy and we're going to respond with a 500. Yeah. Right? There we go. We're just going to respond with a 500. Okay, fantastic. It was a 500. I don't know what happened. Else, what I need to do is I need to respond differently. Okay, yeah, I think I could do this. I think I can do this. I think I can do this. Dude, this is going to be some spaghetti code. Brothers, I'm about to write some spaghetti ass code, okay? Ass code. You may have heard of it. You ready for some spaghetti ass code? Anyways, okay. We're going to write some spaghetti ass code. Here we go. Yeah. Mamma mia. That's right. We are about the mamma mia right now, okay? So I'm going to do a status line. I'm going to go like this. Response. I know. This is just let it happen. You know what? Just to make... Yeah, I'm just going to do it in here. Okay, just it's going to be some spaghetti, as I've said, ass code. Okay, we're just going to do some ass code. We're going to write the status line. We're going to write some headers, but instead I'm going to go like this. Delete. I need the delete out content length, right? I'm going to have to set transfer encoding with chunked, right? There we go. So we're going to set the headers to have that. Let it just happen. We're going to just let it happen. Okay, I'm sorry. We're just going to do this. All right, so there we go. So we're going to have the content type text plain. We're going to do a little bit of text plain. Let's replace any of the content type, right? Content type as text plain, right? Because I don't know what's going to be coming out here. Chunked. Oh, we're going to chunk. It's only spaghetti if it comes from spaghetti region of France. Otherwise, it's sparkling dog shit. Brothers, we're going to write some sparkling dog shit, okay? All right, here we go. Carmack eats pizza. I write spaghetti. All right, so this is how we're going to do this. Now, this is going to be a little bit goofy if you're ready for this one. So we're going to do chunked encoding. But how we're going to do this is I'm going to do the following if you're ready for this one. Response dot, is it body dot read, right? So I'm going to go like this. Data, actually, we'll just go like this. Data equals make byte. I'm just going to do this kind of inefficiently. That's fine, right? Here, we'll do it like Lane said. We'll do it 32 at a time. Very beautiful, right? We'll do that. There we go. We're going to read the data, and we're going to have n.er equals this. If does not equal nil, let's see, errors is io.eof. If that's the case, then we just simply break, right? And then I can write this niceness. If it's not that, what do we write? Now, you know what? I think we should just break either way. Because if there's an error for whatever reading, let's not even you know what? Let's not even worry about that case. That case is insane anyways. Let's just write our final one, which is right body. It should just be a 0. I can't remember. Is it also registered nurses there? I can't remember if that's the case, right? There we go. So this makes sense. So yeah, you do /r/ends. Okay, so it's pretty straightforward. We're going to write the bytes, then we write the data, then we write the bytes, then we write the data, then we write the bytes, then we write the data, and then we do one empty line. Notice that, again, this is just like headers, right? This is just like headers. One empty line says, hey, we're done. End with a 0, end with an empty. Boom. We're good to go. We're off. We're done. So that's kind of like the final one. So if we do read this, then you know what we need to do? We need to write this thing out, right? So we need to write out two things. The first thing we need to write is actually we're going to first need to write the hex, right? So how do I do a hex? I can't even remember how to do a hex, right? In Golang, how do you get the, I think it's, what's it called? %x. If I'm not mistaken. How do you get the hex string value of a number without the leading 0x? I want to say I'm correct on it. I knew I was right. I just wanted to make sure, you know what I mean? So I'm going to go like this. I'm going to go format.sprintf. We're going to take this bad boy and we're going to go like this, %x /r/n, and there we go. And then we're going to take that one and we're going to pass it an n. Beautiful. Then we're going to take the data and we're going to write up to n. All right, there we go. Bada bam, bada bam. And then after that, we'll go in here and we'll write another /r/n, right? Just like the thing calls, right? This is actually so simple. Hopefully you can just see how easy it is to do chunked encoding back out. This is super easy chunked encoding, right? I literally get some data, write some data, get some data, write some data. It's like there's nothing to it. Now, long as I didn't do these things wrong, this should just all work out. And then, of course, we should make sure we return. Again, spaghetti code. Just let the spaghetti happen, okay? Hey, bros. Just a little spaghetti code, okay? Do a status line, make sure we have the proper headers, write out the headers, call it a day. Pretty straightforward stuff, right? So we have this bad boy. Whoa, my gosh. Oh, my gosh. All right, so I think this should just work. Hashtag that one, brother. You know what I mean? Hey, brother, hashtag that one. So let's see what happens here. Let's see this one. Okay. Dude, I literally don't even know what to expect on this one. Okay, true. I forgot that I did that. Okay. Oh, you're probably saying, well, there's a bunch of 20s there. That's not 32. And you know what I'd say? Hey, hold on. Hey, you, hold on. That's not what happened there. That's not what happened there. Were you not paying attention? It said hexadecimal, brother. And if you did not know, okay, that's way too big. That's way too big. Let's go like this. 0 hex 2 0 is the same thing as 0 binary 0 0 1 0 underscore 0 0 0 0. Now this is 1 2 4 8 16 32. Bam. That means it only has 32, which means that's going to be 32 plus 0 0 0 0 0. So the answer is 32. 20 hex is 32 decimal. Get wrecked. All right, there we go. All right. You know what I'd just like to say? Chunked responsing. First try, not a big deal. You wouldn't get it. All right, chunked quids. What's wrong with this example? Here we go. 10. That should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's 10. Obviously, that's wrong. 10 should be 8 because it needs to be hexadecimal. Yeah, that's true. Let's see, the message, it looks like it ends with a 0. The content length should be specified in the headers. It doesn't have content length. Not enough midi-chlorians. I do like that last one. That last one feels the most correct for me. Chunked quiz 2. Okay. What's wrong with this example? Let's see. Okay, hold on. Let me see if there's null. Should not be null at the end. Bam, bada, bam. I got that one. All right, here we go. What's wrong with this example? No more after this, I promise. Let's see. All right. Let's see. Content type, text plain, transfer encoding, chunked. I thought this was Epstein did not kill himself. I just realized how very popular that is right now. Okay, well, what is they asking? Transfer encoding header should be live. What? Transfer, let's see, hold on. The first number should be 10, not 26. I don't want to have to count that much, but that looks way longer than 26. I don't want to have to count. Content type should be chunked. No, there's no content typed. Absolutely nothing. It's just like Star Wars Episode 3. Dude, I can't believe you made me agree to that, Lane. Lane, I can't. Dude, Lane, you should not. Okay, Lane, we don't need activism. Okay? There's no activism. There's no need to have activism here, okay? You made me agree that nothing was wrong with Star Wars 3 is insane. Absolutely unhinged behavior. How long have you been waiting, Lane? Do you think it was a bit odd that we had the right /n//r/n? Well, no, that's because that's a trailer, and the empty trailer signifies you're done reading trailers. Oh my gosh, it's like trailers are headers. Oh my goodness, trailers are headers. But to be completely fair, they should never have been called trailers. Okay? They should have never been called trailers. Okay, I want you to think about something. This is what happens, okay? I want you to think about this. There's the status line, there's the headers, there's the body, and then there's the trailers. Now, if we were honest here, if this is the headers, these should be called the tailors. You know I'm right. You know I'm right. Footers, don't want to call them footers. No one likes footers, okay? Okay, it's entirely too close to soccer, but called with the British way, so I'm never going to say that. He's unstable? Oh, absolutely, I'm unstable. Well, I did. Why not just use one registered nurse? Was there a COVID outbreak on the HTTP spec? Got him. There's actually a good reason for it. It's because you can have an additional headers at the end of the chunked encoding called, of course, trailers. They work the same way that headers do. Okay, first off, I don't think I said that, Lane. I think you're putting that joke in my mouth. Okay, because I feel like I make better jokes than that. They work the same way as headers do with one catch. You have to specify the names of the trailers in the trailer header. Yes, if you don't know, this, which makes perfect sense, by the way. You cannot have trailers, like, because you could imagine, there's like trailer attacks is what they're called, where you can do like a small amount of chunked encoding and then you just constantly do trailers. And so you can do things that are like, I believe there's some sort of trailer attack that you got to be careful about, so you have to specify the trailers ahead of the time. Trailers are often used to send information about the message body that can't be known until the message body is fully sent. Like if you had some sort of calculation, if you had some sort of checksum, you could see this. For example, a hash of the body message body. In fact, let's do that. Let's add a new method to your response package that does what you would expect based on the knowledge of your trailers I've used. All right, right, trailers. Remember, the trailers are formatted just like headers. In your proxy handler in the HTTP bin, announce content or X content SHA-256, X content length as trailer header trailers, okay? Remove the content length header. We already do that. Keep track of the full response body as you read it in chunks from HTTP server, okay? Once you're done with that, chunks, calculate the hash SHA using this one. Okay, I've never done this before. Okay, this seems fun. And add these to the end. Run your server, bada bing, bada boom. Okay, we can do that. Dude, I can do that. Dude, bro, I can do that. Watch this. You think I don't know how to do that? Right now, I'm not doing it the way you want me to do it, Lane, because I don't have to do nothing you tell me to do, okay? What's this one? Replace it with byte sprint F to no, I'm not going to append it. Stop making me append things, okay? Stop making me append things. I'm not going to do nothing, Lane, okay? Okay, Lane? Okay? Hey, Lane, I'm not going to do that. Okay, Lane? Think about that. Let's see, full body. Right, there we go. And I'm going to go like that, and then I'm going to go like this. Let's see, full body equals, no, can we append? Can I just append? Yeah, I guess I could just append and do ... Is it that? I could use that append operator, or is it the other way around? Hell yeah. I know this is super inefficient, but whatever, right? There we go. So we have the full body, right? So we're gonna trailer this bad boy out, but we're going to do some stuff. I'm going to also go like this, set trailers. Trailers? Is that? Oh no, I just got visual satiation. I can't remember how trailers are spelled. I literally cannot remember how trailers are spelled. Oh my gosh. Okay, it's trailer. That's right. Okay, trailer. And then now I need the set, and I need to set in two trailers. I need to set in, where are we setting these things? X256 shop. Okay. Bam, bam. And then we need to set in one more. What's the other one we're setting in? Content length. Oh my gosh, it's like my API works. There we go. Awesome. So I got the trailers. Cheerdy's nuts. Okay, my cheering doesn't work. And Matthias, thank you very much for the tier 1. I appreciate that. Okay, buddy? I appreciate that. All right, so there we go. So now we have these two. Fantastic. which means now, afterwards, I can do all this. I can write all these bodies, and instead of writing this last one like this, I can go da-da-da-da-da, and then now, watch this one. Trailer equals, are you ready for this one? Headers, new headers. What? Headers are trailers? Yes! Headers are trailers! They're the same thing! They're field lines. Trailer dot tailors. Tailors. All right, let's set and let's go up here and let's let's yank these two. And let's go tailors. And let's set. And now I need to use this SHA business. I've never used this SHA. I've never used a SHA 256 sum. SHA 256. SHA sum 256. What is it expecting here? Bytes, full body. Let's go. Out equals this. What is this thing? Bytes. Okay, so how are you going to encode it? How do you plan on encoding this one? Okay. What's the encoding? Do you want me just to paste it? Okay, I think I know what the coding is. I know what you want me to do. Okay, I know what you want me to do. Func two-stir bytes, byte string. We can just write this one. Out equals that. There you go. For don't worry, we got that. We'll just do our own quick one. Because it's not like you told me what to do with that one. Content length. Let's go like this. Content length is equal to full body length. Okay, what's your problem? And then, of course, this is format sprint F0D. Wow. Wow, I just lost my brain completely there for a second. All right, what's your problem here? 32 byte does not have a... okay, okay, buddy. Got him. Slice it up. Slicing and dicing. All right, there we go. So we got that one. There we go. I know, we got it. That's not SHA 256. You're a SHA 256. There we go. Is that the one I wanted me to do? Sum 256. We're summing it up. We summed it up, boys. There we go. So now that should give us some nice trailers. So this one, let's see. Expecting status code 200. Expecting SHA 256 trailer contain. Expecting trailer length this. Okay. It's a very specific trailer length. Don't you need to, first know? Wait, I'm confused. Is that right or wrong? Wait, did I fail or succeed? Did I fail or succeed? Okay, there we go. Let's see. Expected SHA trailer to contain this, but it did not. Well, wait, what are you requesting? Oh. Oh, wait, wait, what is this one? Wait, did I miss that? When did we agree to this format? When did we... We only agreed to stream earlier. Okay, that's my problem. Okay, hey, that's my problem. But why? Failed plus one. No, fail only counts as sections, okay? A slog, info, response. Oh, no, we can't do a length of the response. Let's HP bin, right? We're gonna do that one, and let's go like this. Let's see what the target has to say it is, right? Target, and then we also have, which is that, and then we also have our which is gonna be All right, let's see what happens here. All right. Target is HTML. That seems good. Error is nil. Wait. I forgot to do that as the final thing, because remember, we have to do the whole oh, it already does it for us. Okay. Do you like how we have tailors as headers? Okay. Okay, so that's good. All that's good. Response trailers equals this. Okay, it almost said the same thing. How is there any chance that these things are that close to each other? Like, what are the chances that it's 3F, 3.2, almost that, 4, okay, look, dude, the same one's right here, same one's right there, CF 82. Okay, it's not the same starting right there. Wow, it was the same. These are all the same. That's crazy. And then most of these are the same. They're missing a 0. Wait, how is that possible? Yeah, I know. That's why I said, how is that possible? What are the chances that it's that close? A new line should be a 0. I'm confused. Yeah. Returns the SHA-256 checksum of the data. Yeah, because that means the tiniest difference in data should effectively make a massive difference, right? Right? That should just, I mean, that should be effectively a completely different thing. Yeah, see, that makes it just virtually completely different. Okay, I'm gonna say I'm right on this one, dude. I am just refusing to believe that somehow I'm getting a SHA that's almost exactly it, except for off by a couple numbers. Like, that's just not. It's probably the 2 string. Oh, it's probably the 2 string. Okay, it's probably the 2 string. Yeah, that's probably me. I don't know, problem. That's okay. That's my 2 string. Okay, that's probably okay. Fair. Hey guys, fair. Okay, that's a fairing. You're fairing out right now. Okay, you're fairing me out. You're right. Is it that? Skill issues. All right, let's see, as we've covered, HTTP is a plain text protocol, but that doesn't mean that you can't send binary data. In fact, HTTP is quite good at sending binary data, and it does by using the content type header that indicate the type of data being sent. For example, if you're sending an image, you might want to use content type image/PNG, and if you're sending a video, you might want to use content type video/MP4. That way, the client knows how to interpret the body. Rather than reading it as raw text, it can expect a specific format of video data. Assignment. The beauty of our current abstraction is that we have all the tools we need to respond with binary data. Let's add a handler that responds to a video. Curl to download this video. All right. Add a new handler for get video endpoint that uses content type MP4. I use read file to just read the whole file into memory. Probably not the most efficient, but works for our demo. Yep. Then navigate to this in your browser. Does it work? Pretty cool, right? That stuff's not so scary. Okay, so this is going to be using a MIME type, right? So we're going to be using the content type, that right there. So let's go like this. Do you like all these if else's going on? If only there was something that allowed you to do checking on a per file basis or on a per path basis. If only we had something called like a handler or something. All right, so let's go like this. equals os dot read file, and let's go like this. Assets dot. Yeah, there we go. Dude, Lane, what have you done to me, by the way? I'm just going to assume, by the way, I'm correct, okay? I'm going to assume I am the correctest of the most correcticus, okay? Replace this one, go here, and we're going to go video.mp4. There we go, right? That's the MIME type. Yeah, that's right. It's a video MP4, okay? And so we're going to we're going to do all this stuff, and so then we're going to take this thing, and we're going to go write status line. You like that? I like that. Okay, we're going to do those things. We're going to do all this stuff. We're going to grab all these things. We're going to grab this. We're going to write status line. We're going to w.write headers. Let's go. Headers. We're going to write out those headers. Is everybody ready for this? And then I think we should just be able to go, oh, I can't access the underlying body. It would be so sweet if I could access the underlying body and just do writer to writer, but fine, that's fine. Write body F, right? And then I should probably go like this. Let's go headers.replace.content length with, let's see, format.sprint F %D, and that's going to be length F. F's in the chat, boys. F in the chat. There we go. We're going to replace those ones. There we are. And so let's see if this actually works. Okay. Bam. Hit that bad boy. Let's go to localhost 42069/video. Whoa, it worked. We're not going to watch me. We're not going to watch me. Okay. But that worked. All right, nice. Watch it. No, of course not. Yeah, right. Yeah, right. Boom. Yeah, right. First try. All right, HTTP 2. First of all, great job. You've made it through the TCP to HTTP course. My goal at the course is to dispel magic, not the magic of discovering something new and the enjoyment of new technology or programming language, but the ability to see a problem from a new angle. No magic that makes you feel, no magic that makes you feel like you might not be capable enough. You are capable. That's right. Problem is that I can't tell you how many people think that this stuff is like actually magic, like writing these things is actually magic. It's not actually magic. It's just really simple parsing and just following a guide. That's all it is. Oh, you want to know how HTTP works? Just read the RFC, do it step by step. It's really not that crazy. It truly is not that crazy. That said, you learned a whole lot about HTTP 1.1, but I don't remiss if I didn't leave you with a brief teaser of HTTP 2 and 3 because you'll see them around and they're very different from HTTP 1.1. Well, actually, they're not that much different. They're only different on the wire. However, it's notable that a lot of the internet still runs on 1.1. Yeah, it's shocking how much still does. It's a binary protocol rather than text-based. So HTTP 2, it's pretty cool. HTTP 2 is really simple to understand. It runs on TCP. It just makes it's just really easy to understand. This makes it more efficient and less error prone, but also requires more steps to debug typically. Yep, HTTP 2 uses multiplexing, yep, which allows multiple requests and responses to be sent over a single connection at the same time. This reduces latency and improves performance. Uses header compression. This is called HPAC. It's pretty cool if you don't know about HPAC. HPAC is like the good stuff, right? HPAC. There we go. HPAC. That's where you want to be. You want to be on the HPAC business. HPAC is pretty sweet. It's considered the silent killer feature of HTTP 2. Header compression, allows for server push, which honestly, this is insane. I don't know anyone that got server push correct, right? Server push is just an insane mechanic. Built on QUIC instead of TCP. QUIC is a transport layer protocol that runs over UDP. Effectively, people just call it TCP over UDP, but though I don't believe it's quite the same, which allows for faster connection establishment, improved performance, mandates encryption at the HTTP protocol level. HTTP 1.1 is unencrypted by default, which requires HTTPS to be secure. There's also some interesting stuff. HTTP does leak some stuff, right? Not every part of HTTP can be secure, right? When you're doing like DNS, DNS is still not quite there. You have to do secure DNS. All right, there you go. I'm done with this step. Yes, there's a lot more. HTTP is great. There we go. Boom, claim it. We're claiming over 5,000. Boom. Wow, look at all of those. Yes. There you go. There you go. There's your free walkthrough, everybody. Hey, you better thank Lane because Lane allows this course to be done online and free on the internet. Okay? Jen.
I hope you had a great time in this course. By the way, we have tons of other courses over on Boot Dev as well. You should go check them out. In fact, we have an entire backend learning path in Golang where you learn how to build modern REST APIs, use databases, and other advanced tools like Docker and Kubernetes. So anyways, you get it. Lots of cool stuff over on boot.dev. Again, if you're interested in those interactive features, use code PRIME for 25% off your first year on an annual plan. Thanks, and I'll see you in the next one.